2 minutes.
Oh, you were cross promoting as well for YouTube. Hello, YouTube.
I'm not gonna post this on YouTube.
Oh, okay. Well, anyways,
Actually, I might. Hello, YouTube. Whatever.
so today we are going to do the rest of the graph pool and a bunch of it, and like half of the complex numbers, because you guys haven't had the other lecture yet. We're probably gonna try to do it all, but we'll see how far we can get. So the topics will be series, all the way to Fourier series and Taylor series, not Fourier series, Taylor series. Then we have some multivariable stuff and double integrals, and then complex numbers. So that's gonna be the topics we cover. Um, Before everything, I'm gonna try something where I just go over the slides and look at like the theories that are important. That's something I might do, but yeah, I think we're ready to start. At any point, if anybody has any questions, if anybody wants to interject, if anybody wants to help me, please do, because I am not that smart.
I just want to say, if you want to have a look at the important slides, I can send you an invite link to my OneNote page, because that's what I've been doing, and I've just been saving them to my OneNote. Although it is less organized than on the slides. So you
Yeah,
might
I
want
think I'm just gonna use the slide. Thank you for the offer though, but like then I have like the things. We
Yeah.
are getting a lot of people. I hope it doesn't happen like with the assembly stream where we had to stream it on Twitch because we had too little, or Discord couldn't handle it. It wouldn't surprise me though. Calculus is kind of a clusterfuck.
Mhm.
Okay. So starting off with the recap, I am gonna add this to the timer. So that's all right. Time starting. Starting off with the recap of series. So realistically speaking, series is just a sequence of numbers added together, and then like the sum from like all of them. Series can be convergent. That means if the limit exists as n goes to infinity of n terms. You have geometric series. That is where where like an plus one equals to an times r, or you can also write that like this: r is the common ratio. Um, the sum of those series is first term times 1 over 1 minus r, and the absolute value of r has to be less than, like strictly less than 1 to be convergent, otherwise it's divergent. And then let's see, we have anything else. Um, if it's convergent, then the limit, the very last, or the infinities term is 0. And if the infinities term does not exist or is not 0, then it's divergent. This is useful. And then some more stuff about p series, namely the 1 over n to the power p is convergent if p is bigger than 1 and divergent if p is less than or equal to 1. I think that's all the important stuff, so we can get started on series lecture 11. I'm going to be using the, what's it called, Overleaf as a latex editor, so you guys can see some of the some of my workings on the left screen if I do any working, so I can write stuff like let me give an example. Recompile. Oh, I'm gonna mess up the LaTeX format quite often, but I'm just writing some stuff here so I know what to do. Okay, so this will be like the sum of 0 to infinity of x squared, obviously divergent. If you think this is convergent, I have very bad news for you, and you most definitely will need this lecture. Yeah, I hate to say it. Okay. Determine the term a 100th, and the limit L of the sequence an defined by an is an minus 1 plus 2 to the power minus n with a1 is 0. So let's see. 2 to the power negative n. So that's 1 over 2 to the power n. Oh, I see. So this is yeah. So this is like the series of uh like fractions, like 1/2, um 1/4, 1/8, 1/, etc. And the limit of that function is equal to 2, which you can find because this is a uh, it's not a geometric series. I know that much. Wait, would it be a geometric series? Yeah, okay, help me out there. Because I think it actually might be because the answer is equal to the fraction of, or 1 times the fraction of 1/1 minus r being 1/2.
Well, no, a geometric series gets multiplied by the same thing every time, and the thing which this gets multiplied by changes.
Ah, I see.
It would be a geometric series if it was an is, for example, n plus or not n. Like if it was just an is
Times
two
instead
to the
of.
time 2 to the power minus n, because then every time you would multiply by a half. But now it is plus. So
Yeah, I see, I see. The limit I think is 2. And there's like this formula here that's also in the lecture slides. I think somewhere more down. Where is it? I think this might be from like another lecture. But like this thing where it's like the n term minus 1 over the n minus 1 term, I think, or the other way around. Yeah, do you have the slide somewhere?
probably will. What do you want? Sequences?
Yeah, the one that shows the how to get
Mm,
the a nth term of a function. The first one of every lecture, like we had it in the previous one as well. The first one of every lecture takes a bit longer because we have to find the theories we have to apply. But once we
yeah.
have them, they go a lot faster.
Let's see. Sayonara. Um,
So I feel like what we should do is write the first three terms, and then we find like a certain equation that the whole series follows. So
Yeah, we
if
could do
like
that.
if you try and find the first three terms, it'll make it easier.
yeah.
So it's 1 plus, so that's 1 fraction 1/2. And then we have a2 is equal to 1 fraction, that's like 1/2 plus 1/4 is 3/4. So this is also why I'm thinking it will tend towards infinity. It will always be like um what's it called? It will always be like one less than the bottom one, with the bottom one being a power of 2. Well, I mean, in that case, we can. I don't.
Well, then
Yeah, it will
eventually,
not be this
well,
one.
like Ira,
Yeah.
um, if you want to check if the limit goes to infinity, what do you calculate? What's the first thing you check?
The limit of an as n goes to
Yes.
infinity.
What is the limit of an as n goes to infinity?
2.
Yes.
Yeah. So we already knew that.
No. Or oh, sorry. Yeah, the limit. I thought you were talking about the limit of the
Yeah.
series. We're not talking series. I am also not awake.
I'm pretty sure it's this one. There we go. It wouldn't make sense if it was this one, and we knew the limit was 2, because this would
Yeah.
be like x minus 1/x, which yeah. Then we also would need a 100 already, which is not useful. Ah, ooh. Consider the series. Oh, wait a second. Okay, so it's the infinite sum of e over pi to the power k. Determine the sum of the series if the series is divergent, or if the series is convergent. If it's divergent, then fill in div. Okay, so This is a geometric series with as common factor r is equal to fraction e over pi. Let's see, e is about 2.7, I thought, and pi was about 3.4, so that is going to be an r that is less than 1. And therefore we know the series converges, and we know that the sum is equal to, let's see, what was it? The fraction
1
of
over
1
1 minus
over
r.
1 minus r is equal to the fraction of 1 over 1 minus the fraction of e over pi.
I heard like all people leave, so I was looking, see if we had any people left. We're still at
Yeah,
give or take
like
28.
the start is always really rough, and there's a lot of people leaving because they think it's not going to be useful, which it's like understandable because I'm like I'll also need to wake up a bit, but eventually we'll get there. Check my answer. Let's go. Okay. Isn't this like the exact same? Oh no, this is pi over e, and this is 3.14 over 2.7, which is 1 point something. That's more than 1, and therefore this thing diverges. There we go. See, we're getting somewhere. Determine the first four terms of the series. Okay, so we have the series negative 1 to the power k times 5 over 5 to the power k. I see. So at k is 0, if we think that it is, since the term starts at, I'm actually going to mute my notifications because otherwise you guys are going to see like all my notifications. Well, when it's 0, that's obviously just 5. So a0 is equal to 5. At the second term, this is going to be divided by 5 and times minus 1. So that's going to be minus 1 because 5 divided by 5 minus 1. Then it's going to be plus oh yeah, okay. So this is I was really confused because I was like, wait, this is like, but we're not working with the sum yet. These are just the first n terms, not the sum of the first n terms. So this will become 1, this will become divided by 25, so the answer will be 1 over 5, because it's 5 divided by 25. And then it will be negative 1 over 25. Determine the sum of the series if the series is convergent. If the series is convergent, the series is divergent, write div. Then we have to use the divergence test. The limit at, wait, this is the alternating sum. We hadn't had alternating sums yet, did we?
No, that's like the fourth or something.
Yeah, I was about to say, like, this is, we haven't had this yet in this lecture. However, I think it was if the thing that is not alternating is convergent, then the series is convergent or something like that. We'll get there when we get there. I'll just try diff for now, see if that works. No. But a geometric series test? That's not right.
But r should
Oh
be like
wait,
negative
that
1
is
over
correct.
5, yeah.
It's the thing is indeed negative 1 over 5. Oh yeah, I see. I was too focused on the alternating series part, but this, you can just use the geometric series test thing. This thing. Oh, that's cool. Okay, well that's good. Retry. So we can actually try that now. So the answer would be the we have an r of 1 over negative 1 over 5, and since negative 1 over 5 is a less than that is less than the absolute value, the absolute value that is less than 1, we know that the sum is equal to, or the limit of n goes to infinity of the nth term is equal to the fraction of 1 over 1 minus negative 1 over 5, and therefore, there we go. Of course, you can simplify this a bit more, but I think this is fine. The answer is incorrect. What do you mean? Is it? Oh, wait. Yeah, because we have to multiply by the first term, which is in this case 5. There we go. Okay. Took a few tries, but then you get something. It is indeed like a0 times this thing, and in this case we forgot, or at least I forgot, to write down a0 is 5. So this would have been the proper thing. I just got used to the function that start with the first term of 1, but that's why we're doing this. That's good. Okay, the sum of the series 3 to the power n divided by 3. Okay, right. This series is divergent. Okay, well we'll have the first term that is equal to, well, if that's 0. Well, actually no. The sum starts from 2. This the things we learned only work, as far as I know, from from n is 1. Let me have a look. Let's actually have a look first at the at if it would diverge or not. So at n is 2, it would be equal to 9 over 4 plus 1. That's like 3 to the power 5. Well, I think that's pretty obvious that that like is less than 1. At n is 3, that's going to be equal to 27 over 3 to the power 7. Well, the common factor here is 1/3. Okay, that's good. Okay, so yeah, okay, that actually makes sense, because every time you get like a third power here and 2/3 powers there, so the common factor every time is like 1/3. And then we get oh, I see. So the sum as n goes from 1 to infinity of this thing is equal to a0 being, let's see, if we fill in 0, we get 1 over 1, yeah, just 1 over 3. So we get 1 over 3. The ratio is equal to 1 over 3 as well, I'm pretty sure. I thought I said that. Yeah. So this will be 1/3 times 1 over 1 minus 1/3. So this is frac 1/3. There we go. The thing is, this is equal to the sum as n goes from 1 to infinity. So we need to have this. This is n is equal to from 1 to infinity, and then we subtract the first term, because then we get the sum as n from 2 to infinity. So then we get divided by, or minus 3 over 3 to the power 3.
Couldn't you also just fill in for the first term, just the second term? I mean, you achieve the same result, but like,
That's a
because
good one. Let's actually try that.
it's just the
Because
first term
indeed,
times
the quote unquote first term is at n
arbitrary.
equals 2.
Yeah.
Hell, we could even convert it, say n is equal to n minus 1, then this will become n is 1 again.
Yeah.
So, but we'll have a look. So the first term will be that will be 9 over 3 to the power 5 times 1 over, check my answer. That's actually pretty smart. That's actually pretty smart. So we can pick whatever first term we want because we decide like it doesn't matter if this is n equals 2, n equals 3, n equals 4. The first term is the first term. It doesn't have to necessarily be the zeros or the 1th term. Okay. Describe the number 3.7. Determine the rational number. Blah blah blah. Use the sum. That's gonna be 3 plus 3 over 7, or 7 over 10, plus the infinite sum from n is 0 to infinity of 41 over 10 or 100 to the power n. And now I have to see if my bounds are correct. So we want the first number to be 0.041. But in this case it's going to be just 41. So we need to change this from n to n plus 2. Is that correct? So when n is 0, or n plus 1. So when n is 0, this will be 41 divided by 100 is 0.041.
41
No.
divided by 100. Isn't that 0.41?
Yeah, I was about to say, that's not correct. But in that case, we should just
Yeah,
divide the top by
4.1.
10. So this should
Yeah.
be 4 plus 1 over 10 times divided by. Okay, because then the n plus 2 terms will be 4.1 divided by 100 squared. That's like divided by 10,000. So like 2 more decimal places. I think this is correct.
I would give this an answer.
Hell yeah, dude. Dude, we're solid.
By the way, sometimes I mute and unmute my mic. I don't know if you guys can hear that. If
No,
so,
I
I'll
don't
stop.
think so.
Right.
Okay, determine the series of the sum, blah 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 blah. So after everything, we get 2 to the power 3n. So we get 8 on the top and 9 on the bottom. So that means our r is equal to 8 over 9, and our first term is equal to 2 to the power of 0 plus 1. So that's going to be 2 over 1. So the final answer here will be 2 over 1 times the fraction of 1 over 1 minus 8 over 9. Because at this point we know 8,0 is the first term and 8,1 is, and the ratio is, yeah, that seems correct. Alright, and split. I fucking hate when it does that. When I press my split button and it goes back. Comparison test. What is the comparison test about? So let's see, content. Comparison test is lecture 12. Lecture slides. Do we have 2 things here? Like one comparison test, one... No, only one, the comparison test. Okay. So let's see, we have alternating series, which is equal to... Yeah, this makes sense. Just the sum of negative 1 to the power of n, and then something else. Then we have the AST. So if it is alternating, so a is the sum is negative 1 to the power n times something, and it is absolutely decreasing. Is that the correct term here? Either way, an is like less than or equal to, or greater than or equal to an plus 1. So an plus 1 is always smaller than or equal to an, and the absolute value of an is equal to 0, then the theory is convergent. That's good to know. Then we also have the error bound, which is the actual series minus the first n terms of the series is equal to, or is less than or equal to, the an plus 1th term. Okay, cool. And then we have a comparison test. If bn is convergent and it's strictly less than or equal to an, then an is also convergent. And if bn is divergent and an is bigger than bn, then an is also divergent. Yeah, this makes a lot of sense. Suppose an and bn are series of positive terms. If we have two things that we can divide by each other, then or c is a finite number and c is bigger than 0, then either both theories converge or both diverge. So that's like how you relate two theories to each other. Let's try it. Start now. Use the limit comparison test to decide whether the series sine of 1 over n to the power 3 over 2 converges or diverges. Well, we'll get the limit comparison test. So suppose we have two theories which both have positive terms. Will this always have positive terms though? So we have the sine of a positive number. That is, let's see, when this is 0, that's, oh, this is 1.5. Oh yeah, okay, that makes sense, because that means that this grows, and therefore this decreases, so that makes sense. However, they say a limit comparison test. Does that mean we need another limit? What would be a good limit to divide this by? 'Cause I can't really think of anything that's like...
I think wasn't it always the if you or you take the inside or the bottom, take away the top, so that's 2/3 divided by 1 is, or minus 0. Wouldn't you take the p series of with p is 3 over 2?
But you mean like the sign of the p series, or just the p series itself?
No, the p series. So like I said, that I'm not that good at this, but I remember my teacher taking the p series of 3 over 2 for something like this, but I'm not sure why exactly.
Yeah, it is a P series. Well, and because P in this case is 3 over 2 is greater than 1, therefore 1 over n to the power 3 over 2 would be convergent and would ultimately go to 0. Well, if the sine of some angle goes to 0, if that angle goes to 0, then the sine of that angle will also go to 0 because the sine of 0 is 0. So I will think it is convergent.
That's it. You make a good statement. I'm so confused because then we didn't use the limit comparison
Yeah,
test.
exactly. I don't know
We'll say
why.
it's convergent.
I mean, most of these exercises are fine, but some, like, they ask something that they tell us to skip, so don't go completely off their text. Like,
Yeah.
you'll just be baited.
Oh, I see. You have to take the limit as n goes to infinity, and here this will be 0 and this will be 0. However, I'm not like convinced that this will always be. Let's see. Oh wait, no. The only limit is that they both have to have positive terms, and like,
What's up?
So like this gets to 0, sine 0 is 0. This is 0, or something close to 0, and something close to 0 divided by something close to 0 is 1. But this is still a dog shit question. Change my mind.
Oh yeah, because I don't know if they told you, or this is lecture material, but with n arbitrary close to 0, sine of n is equal n.
Yeah. I know
So
this. I'm
that's
not
why
sure
it's
if it's
1.
material though. So I'm
Probably not.
like I've heard other people talk about it, but it sounds like something that is like a rule of thumb, but not something you could use in a proof.
It is. It's something you can use to prove. It actually mathematically equals each other.
Huh.
Yes. The sine of n equals n as n gets arbitrarily close to 0. they equal each other arbitrarily well as it gets arbitrary. You know what I mean?
Yeah.
Limits.
Okay, series to compare. Ah, I see. Okay, so all we need to know is which series we need to compare with which series. And because we're working with as n goes to infinity, we only care about the biggest term. So in that case, in this case, it would be equal to 6, or like the square root of 6n to the power of 6. So this would be, let's see, the square root of this thing is equal to 6n to the power. Wouldn't that just be 3? Might probably be this one, but I'll look at the rest first. When n goes to infinity, this will be equal to, this will equal to that, so then we get n6 minus 1. So I think a is going to fit with 3, because this is going to, like, as n gets arbitrarily close to infinity, we can get rid of the sign, and we'll just get n times n over 6, which will be n over 5. Or n to the power 5, so that's going to be a, so 3 is a. And here we have n squared on the top, n to the power 6 on the bottom, so that's going to be n to the power 6 minus 2. So c is b, or c is 2. So let's see, we have a is 3, c is 2. A is 3, c is 2, and then 1 is b, obviously. I am curious why this would be a though.
No,
What
it's
I would
B.
say,
One is B.
Oh yeah, okay, I realize now, because that minus 1 is because there's a 1 here. So that
Yeah.
actually makes sense.
and the reason it's 6/2 is because it's
Yeah,
you know
like the
6
square root.
square root.
Yeah, I was looking for just a 6 over 2, but I didn't realize the 1 on the top had to be factored along as well. So it is,
Of course. It's bottom minus top.
yeah, exactly. So it is, let's see, what was it? 3 equal to, or c2.
First one is
3.
B, the second one is C, the third one is A.
Thank you. Okay, next one. Use a limit comparison test to decide whether the series converges or diverges. Well, let's actually work this out. So we will have, and I'm gonna do this real quick. So we'll have the sum as n equals to 0 to infinity of the fraction of 3 over to the power n plus 3 over 9 to the power n plus 1. Compile. So this is what we're working with. We know that this is actually equal to 3 squared times, in this case 3 squared to the power n, but you can multiply the powers together, so then you get this. And therefore as n goes to infinity, oh, excuse me, forgot my brackets. Therefore as n goes to infinity, all we care about is this part and this part. So I'm gonna get rid of this sum part real quick. All we care about is this part and this part. Oh, I forgot something important, a closing bracket. Recompile. Where's my stuff? There it is. This part and this part, and therefore, yeah, we can get rid of one n on top and bottom. Is that correct? Yeah, because we can multiply by 3 to the power of 1 minus n, or 1 over n on both top and bottom. So this is equal to the p series, to a p. Wait, we can simplify this one bit further, so it actually is a p series, now that I think about it. Yeah, okay. So we have 1 over, and like the minus 1 falls away as n goes to infinity. So this is a p series with p is equal to 3, is that right? I've never really understood or gotten used to p-series, but I think it is. That means that this is convergent. Therefore, this divided by that is going to be most likely an
Isn't it 3 to the power n minus 1?
what did you say?
He's
Isn't it 1
The-
over 3 to the power n minus 1?
1 over
The
3 to
last
the
one. The last one, yeah.
yeah. This would be well, not 2n minus 1. It would be n minus 1. Yeah. But as n goes to infinity, n minus 1 and n are equal.
Well,
they
your
both have infinity.
simplification to 3 over 3 to the power n should be different, because 3 to the power n over 3 to the power 2n is equal to 3 to the power n minus 2n is equal to 3 to the power minus n, is therefore equal to 1 over 3 to the power n.
That's
So
what we
it's
end up
not
using here.
3 over 3 to the power n. It's not 3
Oh,
over...
wait, I see what you mean.
Yeah.
Oh, yeah, that's a good one. Yeah, that makes sense. Yeah, okay, thank you. So then we end up with a p-series of 1 over with ps3, which converges. This is probably going to equal a real number. Do we know if it's like if you divide a sum by its p-series, which you get when n is equal to infinity, do you always get a real number?
Well, this is actually not a p-series, because a p-series has n to the power a constant, and need a constant to the power.
Oh, yeah, fuck. I always confuse those two. Thank you for correcting me. We can actually try, because this is, we can like divide one by the other, that's no problem. So we'll do this. And it's gonna be a nasty little fraction, that's for sure, but we'll see if we can work it out. There's no calculus like a little bit of calculus in the calculus. So we want to know if this is equal to a real number as n goes to infinity. And it has to be bigger than 0, or yeah, bigger than 0. I'm not sure if this is a smart move, because as n goes to infinity, this will be 0.
Yeah, but you can use it to do some math in the upstairs
Oh wait,
department.
yeah, because as n goes to infinity, this will equal to this.
Well, no.
Well, not exactly.
You can divide the top, because you divide by a fraction. You can
Multiply the top by.
multiply the top by that.
Okay,
and see what
we'll
you
do
get
that
then.
first. See where we get.
Yeah.
Then we get
So that's what you're supposed to do with it. You're supposed to do some fucking algebra with it. You know.
some magic, some algebra. We'll do that. We'll do that.
Mathematics.
It's good that you guys are like here, because I am like not awake enough for this.
It is 11:41.
Yella, did I stutter? So then this becomes 3 to the power. Oh, I'm gonna copy this real quick. I've probably forgotten something or added something too much. I've added something too much. Cool. Then this becomes. Oh yeah, it all works out now. So this becomes 3 to the power of n
Plus 1.
n plus 1. This becomes 3 to the power of 2n. I can get rid of all this
And now
stuff.
you can divide the entire thing by 3 to the power 2n.
Yeah.
Oh. And I suppose the answer is 1 then, so it's...
Yeah, because we can divide everything by 3 to the power of 2n. That will make this 1. This will be the fraction of this thing. This will become 1. This will become a fraction of this thing. Recompile. And because this power is bigger than that one and this power is bigger than that one, this will both tend to 0. This will become 1, and therefore, since this series is... Okay, so now we know that this series has the same convergence / divergence as this one, which is a lot easier to work with, admittedly. So the sum of 1 over 3 to the power n is just gonna be keep on decreasing, and we know that that's gonna be convergent because this is just a ratio or a what they call geometric series with a ratio of 1/3. So that's gonna be convergent. Let's go. My guys didn't even fucking whatever.
Is this a split?
I think that might be split. Yeah. Let me see if there's any other. No, split. Sick. So then we get.
Yay.
Hey, split. Dude, we're only like half an hour in and we're already at 2 of the. Oh god. Anyway. Gonna be a long day. So this is gonna be the ratio test and power series. Okay, well what's the ratio test all about? If I didn't do all of this, I would like for sure gonna be
Failing.
yeah. Okay, so we have absolute convergence, which is if the absolute value of an is convergent, and conditionally convergent when just normal thing is convergent. And if a theory is absolutely convergent, it is also convergent. Which is interesting because that would mean that you can just always, if you're only checking for convergence, you can always just ignore the alternating part.
Unless you're using the alternated series test, because then it's
Yeah, yeah.
necessary.
Okay, so a ratio test, that means that the first term hasn't, wait. Okay, so it cannot be 0 for all n. And then suppose as it goes to infinity, the ratio between the n plus 1 term and the nth term, if it is equal to 1, then the limit does not exist, or the limit does not exist, then it's inconclusive. It is less than 1, it's absolutely convergent, and if it's bigger than 1 or infinity, which is conveniently bigger than 1, it is divergent. That's good. Okay, let's have a look. Ratio test. I have so much faith. What's the limits of the terms in the following series? I'm going to clear up some space real quick. So we have the fraction of 2 c dot n factorial over 5 to the power n c dot n factorial squared. Dude, am I happy that we only have to do that we only have to calculate this thing and not like actually work with this? I forgot a bracket. Okay, so this is oh, so this is what we're working with. So what we do then is we take the fraction of this thing, where instead of n's we use n plus 1s. So let me fill that in actually. N plus 1, n plus 1, c dot n plus 1 factorial squared. I need to open this bracket again here and close it here. Recompile. Okay, this seems correct. Yeah. Okay, and now we do some fun stuff when it comes to clearing out the numerator, denominator, etc. So what we can do is we can multiply both top and bottom by 5 to the power n. That will leave us with this 5 to the power n disappearing, and this becoming just a 5. Recompile.
Shouldn't be like in the third line, 2 times n plus 2, because we had 2 times n and now it's 2 times n
Oh
plus 1.
yeah, good call. So it's 2 times n plus 1 instead of 2 times n plus 1. Yeah. Okay. So we have... Is there anything else we can factor out real quick? I'll turn this into 2n plus 2. Maybe that might help. So if we have 2n plus 2 factorial divided by 2n, that's going to end up being equal to just n plus 1 times n plus 2, I think. So we can get rid of this here, turn this into a 1, and this becomes 2n plus 1 times 2n plus 2. Yeah, I'm pretty certain that's correct. Okay, and n plus 1 factorial is equal to n factorial times n plus 1. It's good to know that you guys are like watching me because I'm doing a bunch of shit and I'm like half sure most of it is correct. Then this, you can distribute the power of 2 to both sides here. So like this part and this part. Then we can multiply by 1 over, or multiply by n factorial squared. That will get rid of n factorial squared here and n factorial squared here. I have forgotten to add one more closing bracket. And that will mean we will be left with 2n plus 1 times 2n plus 2 over 5 times n plus 1 squared. We can get rid of this fraction here, no longer needed anymore. Recompile. Now my question is, as this goes to infinity, let's actually work out this these squares real quick. Or the square, the brackets. So then we get 4n squared plus, let's see, that is 2n times 1, 2n times 2, that's 6n plus 2. And this is just n squared plus 2n plus 1. Oh, and that's like times 5 as well. So let me multiply everything here by 5. So we get 5 plus 10 plus 5. We've gotten quite a way in simplifying this. It took like 8 minutes, but that's fine. And then we can divide everything by n squared. So then this becomes 4 times the fraction of 6 over n times the fraction 2 over n squared. 5. Like, I know we could just do without this this division, but I just want to make it clear for people who haven't done this yet before. Then we end up with this. And as n goes to infinity, this will fall away, this will fall away, this will fall away, this will fall away. So the final answer is 4 over 5. Woo! Okay, that's cool. That's pretty cool. Oh, and of course I should have used the absolute value. So if we had a negative number, then it would have gone to positive. And since 4 over 5 is less than 1, it is absolutely convergent and hence convergent. Nice. Okay. Oh, this looks a lot more fun. A lot nicer than the last one. So we have the fraction of n plus 5 over n to the power 4. Okay, cool. We grab this and we turn that into the fraction of that thing with n plus 1s over the original fraction. And there are, by the way, no absolute value marks in In
In
LaTeX,
LaTeX there
I
are.
use-
There are.
maybe if you import something. However, there's nothing like abs or something, so I have to use divisibility. Okay.
Okay.
So then this becomes this. God, can I like turn off desktop notifications? I don't have my private life shown all over the internet. SMH. Okay, this seems correct. I'm gonna get rid of these mids because they're like cluttering up the screen a bit. That does not help. Okay. I would get this out of the brackets, but that doesn't really seem like a good time. I can divide. Or do they seriously want me to get this out of the brackets?
Jura.
Yeah?
Can you try something for me to?
Depends what it is.
I'm gonna send you. So try this, where x is your entire equation.
Still not absolute value marked, but we'll see if it's
Well,
better.
they should be absolute value marks. That's the thing.
Yeah. I'll take it. I'll take it.
Yeah, you know.
It's more than good enough. Okay,
I
realistically,
don't know how to exactly work this out, but I know that n plus 1 to the power 4 grows faster than n to the power 4. And therefore, the above term decreases more quick than the lower term does decrease. And therefore, I think it would end up to something smaller than 1.
yeah. We can actually make it a little bit better because we know that this will end up giving something in the form of n to the power 4 plus I
R
don't know 3
R with it's like something with the power or with the
yeah with some
like-
other stuff which have powers less than 4.
4. Yeah, exactly.
And then dot 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 plus 1. And we don't actually care for what the
Yeah, what it
what the
exactly
rest
is,
is
because you're
because
gonna
that's going to
divide.
fall away as we divide by n to the power 4. Okay, so we can divide top and bottom now by n. So this will become 1, 6 over n. And this will become 1, and this will become 6. This will become 5 over n. Okay, recompile. That's good. Now we can divide everything by the bottom part by n over 4. This will become 1. This will become 1. This will become blah blah blah. This will become 1 over n over 4. So realistically, everything will fall away except for these 4 ones. Therefore, this ratio test equal to 1, which is inconclusive. Woo! Okay, that's nice. Oh, I actually had to fill in this as well. Okay, isn't this like? Oh no, this is something different than what we just had. Okay, so I'll take the original fraction, that is n plus 2 factorial over 4 to the power n. Okay, that means the new fraction will be the fraction of this thing, but instead of n we have n plus 1. And like after a while you get a lot better at this. So now our fraction is this stuff. Well, n plus 3 factorial over n plus 2 factorial, that's just gonna be equal to n plus 3, because all the other terms will be cancelled out. And then 4 to the power n plus 1 divided by 4 to the power n is just gonna be equal to 4. Is that correct? Yeah, that's correct. So if we divide both sides by 4 to the power n, I have taken away one too many. Okay, so we will end up with, let's find my equation again, n plus 3 over 4. That's interesting. So what's going to happen here is when we divide everything by n, I have still... Oh no, I didn't. Okay. So when we divide everything by n, we will get 1 plus 3 divided by n over 4 divided by n. However, this means that this is equal to, once it compiles, hello, there we go. That actually means that this is equal to 1 over 0, which is infinity. Therefore, or well, 1 over the limit of whatever, blah blah blah. Therefore, it is inconclusive. What?
Divergent.
Divergent.
It's
Fuck, it's
absolutely.
divergent. God damn it. Okay, that's a good call. I messed that up.
Retry the orange
Oh
button.
yeah, I can retry it. It's divergent. Okay, cool.
You can also see that, well, you don't need to divide by n when you see that the powers above the ratio
Yeah,
are bigger than the powers below it.
that's true. Use the ratio test to decide whether the series converges. Okay, we will have n plus 1 over n. I'm really liking the interaction with the chat so far. Then we'll have the fraction of...
Is there a chat? Oh.
Well,
It's us.
there's not necessarily a chat, but like the people here. I'm just used to Twitch streamers
okay,
saying chat,
sure.
so... My dad's like, "Okay, boys, you're gonna come downstairs for lunch. Did everything go well with the stream? Oh, we've only just started." Well, here you can see indeed the dominating powers are just n, 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 n. So if you divide everything by n, you'll get 1, 1, 1, 1. Therefore, the answer is 1, and that's the inconclusive. At the start, I did want to write everything out. However, I'm feeling like that's not really.
It's gonna take a lot of time.
Yeah, it's gonna take a lot of time. And it's not really gonna add much. Ooh, so like this is interesting because like then I actually have to do math. So we get 2n factorial divided by 6 to the power n times n factorial squared. Copy.
This is exactly the first one, but then the 6 was a 5.
Yeah.
I mean, yeah, okay, but we still need to fill in what it is. I think I forgot something, but I'm not sure what it is. I think a
I
closing
feel like
bracket.
if you click on the series is convergent in the second question, you'll just finish the.
Hmm?
If you just click on the series is convergent in the question, will that be it? Like.
It'll seriously give us the oh I mistyped. What do you mean? Oh my god. But yeah. Next subject. Power series. Are we already at power series?
Are we going to have a 2-minute toilet break?
Yeah, that's a good plan. We'll have a toilet break until this timer says an hour.
Okay, that's good.
Jure,
Yeah.
Yep.
can you doe je verzoeknummertjes?
Yeah, we're...
Right. Like this is the most basic shit, but I'm just staring at it going, no.
Where do you send it?
I haven't sent it yet, but it is the fraction 2e to the power x minus 2 minus e to the power x.
Wait, so it's 2e to the power x.
Divided by 2 minus e to the power x.
And what do you want to do with it?
And I think I must be stupid. How many vertical asymptotes does this function have?
Well, first of all, I'm taking a piss break. You guys can discuss this. I'll be right back.
Sure. So, anyone here who can help a brother out? Because I know the answer. I've googled the answer. I've looked at Wolfram Alpha. I see the answer, but it's not what I think it is.
Sorry, to which question?
The 2e to the power x divided by 2 minus e to the power x.
The second from the bottom.
Yeah, the second one from the bottom. How many vertical asymptotes does it have? Because you can simplify it to 2 divided by e to the x minus 1. And if you plug in infinity, you get 2 divided by minus 1 is negative 2. But if you plug in... if you plug in negative infinity, I see it. Okay, thank you. If you plug in negative infinity, you don't have to divide by it, because then you're dividing by 0, because you're dividing by 1 divided by infinity. Whatever, it's I understand it now. So the thing is, I had rewritten it to 2 divided by 2 divided by e to the x minus 1. So I thought, okay, whether it goes to infinity or not, it's going to be, or infinity or minus infinity, it's going to be minus 2. However, if you keep it in its current form and fill in minus infinity, you'll get 0 over 2 minus 0, which is 0. So, yeah, I did too much work, and that is why I got it wrong.
Okay. I see I've come back on just the right time.
Yeah, and I've also figured it out, because if you divide everything by e to the power x, and then let x go to infinity, you get 2 divided by minus 1.
Yeah.
So that's 1 asymptote, and if you keep it in the current form, and let it go to minus infinity, you'll get 0 over 2 minus 0, which is 0, which is a second vertical asymptote.
Cool.
So I just had the divided version sitting here, like 2 divided by 2 divided by e to the power x minus 1, and I was looking at it like, what the fuck happens if you fill in negative infinity? Then it just becomes infinity, bro. And actually, if you fill in infinity, it also becomes 0. I'm just bad at maths. I see.
Guys, it is time once more. I just want to say, batch 2 gang.
I'm
Batch
not
2
sure
gang.
which gang I am. Let me
I
have a
think I'm
look.
batch 2. I don't know. I forgot.
Like last time I was
You
batch
just
2.
got an email 5 minutes ago.
Batch 2 gang!
Batch 2 gang, hey!
fmail.tdelf.nl. Sign in. Batch 2 gang! Hey! Also, am I the only one who started up the 2021 National Student Survey, filled in 3 questions, saw that there were like 50 fucking questions, and fucking stopped?
It
Yeah.
jumped from like 40% to 95% in the end.
Bruh.
Okay.
I'm still not completing that shit.
And
Yeah,
I am sadly batch 1 gang. Fuck me.
Dude, disgusting. Batch
Imagine
2,
having to get up before 3 p.m.
batch 2 or the death. I mean, for me, for
Is it-
calculus, like I've gotten so used to waking up at like 7:30 that when I try to sleep in the weekends, I wake up at 9 and I'm like, wow, I'm well rested. I've gotten my nice sleep. I'm like, I really want to sleep more, but it just doesn't let me.
I hate calculus and all the other maths courses because they all have fucking 6 hours in the morning.
Yeah, that's true. However, I hate all the math courses, but that's because they force us to use proctoring software.
Yeah, that's also a
Yeah.
very good reason to hate them.
Yeah,
And I
Like, I
might
just-
hate them more for that.
exactly.
I don't see why they don't do the same thing as database and just have open questions where we just hand in the picture of our work.
Yeah, the thing is, I do understand it because like if there's just open question without any proctoring, you can literally use Wolfram Alpha and get like the answer to 9 out of 10 question. But at the same
Well, with
time,
databases, that's more difficult, yeah.
yeah, indeed, it's like it's a lot harder for like CO and databases and stuff because there's just so much resources out there. But at the same time, do anything else than proctoring and it would make me a ton happier. Because like I do proctoring on like a separate laptop, which is at least like somewhat okay, but still I have to like give up the privacy of my own room, and I have to throw a fucking blanket over my computer and stuff.
Oh yeah, if they're gonna fraud check me for that one, they can suck my dick. Like fuck them.
This
I
is
got my
recorded.
own house. I'm still not giving them a room just for exams. Fuck that.
Yeah, no, that's not happening.
Yeah,
For people that really have
You can live with seeing me and me not picking up anything from inside of my room, and you can fuck off.
yeah, it's like
You can also live inside of a VM with your shitty proctoring software.
that's true. You can just use a VM, but
Yeah.
Yeah.
It works fine.
Yeah, I mean, I think somebody did it, and like they didn't.
I did.
This is recorded. Butch your words.
I know, but it doesn't say anywhere that it isn't allowed.
That's true. That's true. It doesn't say
I
that
read
below.
through everything they linked.
Yeah,
I
if
mean,
they,
I
if they don't
wouldn't
say
trust
it
All
Well,
the
below,
Alfred
legal
for
shit
work.
that's written in those documents, and it says nowhere that it has to be ran on physical hardware.
I mean, it's more of a thing like, what if it doesn't work for some retarded reason? Because it's a piece of shit. Then it's your problem.
yeah, that's
Guys,
true. But it
just-
worked last time.
Yeah, it works.
Let's
Like fine.
continue, guys. Let's continue.
You want to start again?
I just want to real quick say, consider fx. How many horizontal asymptotes does it have? What is the y position of the horizontal asymptote?
Hmm? Yeah,
It asked
that
me-
means there's one. Okay, kick.
Yes, exactly.
Yeah. Let's see. So we had power series. Oh god, I remember stuff about power series and it wasn't fun.
Nice.
Yeah. This is I remember this. Ooh. So it's a power series in x minus a if you have a constant that's like a constant that is dependent on n. So it's not just a constant, but a constant dependent on n. Multiplied by x minus a to the power n. I see. Okay, let's try it. Let's see how far we get. Start now. How do we calculate the interval convergence again? It probably should be here, but it's not. Because like, huh? No, now I'm curious because the there was something to calculate the interval convergence, but it's just not here.
It's here on your current slide, from a minus r to a plus r.
Yeah, but how do we calculate r?
That's a good question.
Yeah, I think there was something about that. Wait, I'm gonna take a screenshot of this in case we need it, and go see if it's somewhere else. So we're now in lecture
I think
13.
you can find out r by knowing the region of convergence of just the base case, which is the like if you scroll up a bit, yeah, so you can find it out at the base case, which is like the top one, and then you just look at what you have to do to get to the current function and see how you got there and how that changed the radius of convergence.
Wait, I actually think I understand. Wasn't it like, let's see, if it's convergent at some point, that means that the ratio test gives a what was it? If the ratio test gives a number that is in absolute values less than 1, right? Well, either way, we can fill in the function and then see for which r.
The ratio test means that it's convergent, or if they're both convergent. If they're both convergent, then the output will be something higher than 1. So a positive number, which isn't 1, or which isn't
No,
0.
ratio test is if it's less than 1, then it's absolutely convergent.
Hold on, let me. Oh, I'm thinking about the limit comparison test.
So many fucking tests with so many fucking names, man. I swear to God.
Yeah, I was thinking about the limit comparison test. The ratio test is an plus 1 divided by an, but I don't think you want to do an plus 1 divided by an.
Why not?
Oh yeah, I guess you could just
Let's
fill
try
in.
it. Let's try and see how far we get.
Yeah, sure.
It can't hurt. Well, it definitely can, but we're just gonna choose to ignore that. Over n squared, and we can have the fraction of this thing with n plus 1 over the fraction of this thing with n, and then we just check for which x is this equal to is this, what was it, less than or equal to 1?
Less than 1.
Less than 1. Oh yeah,
If
with
it's
1 it
1,
was
then
in
it's
the
useless.
yeah. And then we get n plus 1 squared. Recompile. I forgot brackets here. Okay. So if we divide top and bottom by x to the power n, we will end up with x on the top and 1 on the bottom. Oh, frac x over, yeah. Okay, cool. Then if we divide this stuff here, we work this out, so we get n squared plus 2n plus 1. Yeah, that's cool too. Then we divide everything on the bottom sides of these equations by n squared. We get 1. We get 1. We get 2 divided by n. And we get 1 divided by n squared. Frac 1 divided by n squared. I've added one something too many. Something too little.
I actually think it is the first option.
So then this thing has to be in absolute values less than 1 or just less than 1? Absolute values less than 1, I know that. So when n goes to infinity, well, of course, we can just at any point ignore this stuff. Because divided by 1 is equal to the original number.
Yeah, just delete one of those.
Yeah, I need to
Who
delete
cares?
more. Cool. So then we get this. Well, as n goes to infinity, we can get rid of this stuff. And then we'll just have x. So we need the open interval from -1 to 1. That means that the absolute value of x, or of the limit of an plus 1 over an is less than 1. And I think this is open interval, this is closed interval, so
Yeah.
the answer is this. Is it less than... Huh? Do we have the screenshot anywhere? I don't want to go back through all of this. Series and... Okay, wait.
Okay, well, what do you want to know? I've got screenshots here. Limit comparison test?
Just to compare the ratio test, I think.
Ratio test. If L smaller than 1, then the series is absolutely convergent. If L is 1, the test is inconclusive and we can't gather information from it.
Wait,
So you
that
don't know
means,
what
that means
happens.
open. That means like square brackets is an open interval.
No, square brackets is a closed interval. However, if L equals 1, the test is inconclusive. So you don't know what happens in the interval L equals 1.
Huh.
What
And
I
as we can see here, we don't know what happens in.
well, no, that's just that's just how they chose to write it.
Yeah.
Like for those 2 points, you have to figure it out yourself.
Yeah, indeed, and they can even differ.
And honestly, if you look at it, you can just fill it in actually. So you'll get if you fill in 1.
Oh yeah, divided by 1, so then we get 1 over n squared, which we know converges.
Yes.
Okay, yeah, that's fair. I can live with that. Okay, cool. Now, we know this works, so we know that this is actually the way we have to do it. That's good.
Well, one way you can do
It's
it.
one way we can do it. N squared over times 2x plus 1 to the power n. Then we can take the fraction of this thing. Oh. Wait, why the fuck am I doing a fraction? I shouldn't be doing a fraction, this is a multiplication. So it's the fraction of this thing over this thing. And then this becomes n plus 1, and this becomes n plus 1 factorial. Okay, if we divide it by n factorial, we get n plus 1 here.
By the way, can you clean the other things up that we don't use now? The other expressions. in the editor, in the, how can you say it?
What are you talking about?
These expressions that
The expressions in the editor that we're not using,
Oh
he wants
yeah,
you
if
to
I can
remove
delete
them.
them. Yeah. So I can get rid of this. I am gonna keep this one because I can't be asked to write the sum as n goes from 0 to infinity again. So I'm gonna keep the sign so I know I can just copy it.
Yeah.
But yeah, I'll delete the rest. Okay, so then we can divide by this thing to the power of n. That will leave us with just this thing itself. We can get rid of the fraction. So when is this thing equal to, or less than or equal to 1? Or in this case, less than 1. Oh, for n goes to infinity, actually. Huh.
It's only when x is equal to 0.
No, because then n plus 1 is still equal to infinity.
And x is minus a half.
But n approaches infinity, and when x is equal to infinity, then the outcome of this will still be 0, and that will be smaller than 1. So therefore, I
What?
think the rate of convergence will be 0.
The
Minus half, right?
If-
Only minus half.
If x equals minus a half, then it's 0.
Always, and that's the only way because.
Oh yeah, okay.
Yeah.
So
Wait,
oh, I see. Yeah. Okay. So is x equal to minus a half? That is then it is 0, and for any other number it is not true. So there is no radius of convergence, or there is. It's 0.
Woo!
And for anything else than minus a half, this will be infinity or negative infinity.
What was the radius of convergence again? It's like the possible range that the function can converge to.
It's the possible range that x can be so that the series converges.
So this image describes it pretty well. So from the radius minus r and r, from like the point where we start, in most cases that's just x.
Okay.
Or that's just 0. From that point onwards, it is convergent. But in this case, it's only convergent on the point half or negative
Sure.
half. So that is the interval convergent, and the radius is 0. Cool. Find the center of the power series. Okay, well, this is quite easy actually when you look at it. So we have the fraction of 4 minus x over 5 all to the power n. Okay, so what you do then is a fraction to the power n is actually equal to the top half to the power n over the bottom half to the power n. So I'm gonna do that real quick.
What is actually meant with center in this exercise?
It is a power series. It can be written as x minus a to the power n times something. So a is the center here.
Yeah, like here. So
Yeah.
you have a constant that is dependent on n times x minus a to the power n. That's like the form you want to get it in to find the center.
Yes.
Okay, so here we can write it like this. There's still too many brackets, but that's alright. And we know that this is actually equal to, well, we can just get this thing out of the top of the bracket. So then this becomes 1. However, this is just equal to a constant in terms of n, because it's not dependent on x. So this is equal to this. Therefore, the center is as x is equal to 4.
Actually, I think that you are correct, but
for
I
the
would
right
add
reason?
one more step.
What then?
Because the center is where x minus a. So you want it in the form x minus a, not a minus x, right?
Let's have a look. Oh shit. Excuse me. And that one.
Excuse you, princess.
X minus a.
Yes. So there is a
I
simple
see
way to
that-
get
so
there.
it is,
Take
yeah,
negative
just take-
1 to the power n out of the bracket, add that to your cn, and then you'll have x minus 4 to the times cn. So
Yeah. So what Yellow's referring to is I can take a -1 out of these brackets. That will become -1 times x times this thing, and we can get rid. Then we can get the distribute the to the power x
n.
or to the power n. Thank you. Then we get this, and then we can take this -1 to the power n over here towards our fraction because it's independent of x.
And then that's your
And
cn.
this is my c1 on the left, or cn on the left side. So,
We zitten
But then it's a -4 and not a 4.
so
Yeah, so
like this.
now you can easily read off that a is 4.
Or a, what you mean like the center of convergence, yeah?
The center of convergence is a.
Okay. Next one. Whew. Oh, well, okay, never mind. That's still really easy. Okay, so what we're gonna do first is,
Isn't it a half or
yeah,
minus a
it
half?
is.
Cool.
But we'll get there when we get there. So we have a fraction of -1 to the power n times 2x minus 1 to the power n over 3 to the power n. Compile. Okay, well, we'll get rid of this -1 to the power n. We'll actually, let's say we'll take this out of the brackets. So recompile. Still not quite in the form we want it to be. We want it in the form x minus a. So what we can do is we can take 1/2 out of these brackets. So then we can get fraction 1 over 2 times x minus 2. Another closing bracket. Compile. Yeah, because if you just, that's not correct. Yeah, I swapped around the 2 and the fraction 1 over 2. So this should be like this. Yeah, that looks better, because if you distribute this, you get 2x minus 1. Then you can take this 2 out, because it's also just a power function of or a power of like n function thingy.
Yeah, and then you
get
do
this, then
minus
you can
2 to the power n.
you can
Or, no, never mind.
you can get this into the denominator if you want. The denominator.
That is actually the numerator. Thank you very much.
Shut up. Dude, I'm literally doing university and I don't even know that shit. And
Well, the one is denominates what the fraction is. The other one, the numerator, just counts. It's a number. It counts. The bottom one is. Okay, the words make sense in my head.
Yeah, but in Dutch it is
Teller, numer.
teller and numer.
Stuck.
Yeah.
That's a lot easier.
yeah.
You're just
Excelsior.
Excelsior. So then we get that the a is equal to 1/2. I always for sure hope that when I like, oh, and that means that this and this and this. Click, wrong. Oh wow, this is actually really neat because it is already in the way we want it to be. Woo. Oh shit, it all for the radius of convergence, not the center. That was the luckiest guess, my god.
I mean, this has to be one, because this is just literally the standard form of a power function. It's just Cn times x minus 1 to the power n. This couldn't be anything other than 1.
Well, it's the radius of convergence, not the
Yes.
center.
No, but the radius of convergence of a standard power series is 1. You start multiplying or dividing or doing wacky shit, it changes. But the radius of the standard power series is 1, if I understand
Yeah,
it
okay,
correctly.
that could make sense actually. Because everything here with n, if there's like no fancy shit, it just divides out afterwards.
Exactly.
Okay, that makes sense. What is the interval of convert? Didn't we already do this one?
Yes, it is the closed interval.
So this
It
one.
is the closed interval. Yes.
Dude, we are legends. That's lecture
What's
13.
up, you absolute legends?
Lecture 13. I'm gonna click like new tab, then I click here, and then I've split. So we have 14, 15, 16. Oh my god, only 2 fucking power bullshit left, and then we can do fun stuff like multivariable calculus.
Woo!
Woo! Okay. Like genuinely, I enjoyed all this stuff a lot more than this. Functions as power series. I'm already in that slide, I think. It doesn't say here. Okay, wait. Functions as power series. Dude, I'm good. Use the first 4 non-zero terms of the power series representation of the function around x theory to find an approximation of. Wow, that does not look fun. Okay. Oh well, actually that's not too bad now that I think about it. So the power series representation. So actually I should have prepared for this. I'm gonna do that now real quick. So what we're gonna do is we're gonna go to Graspol and we're gonna go to course documents and we're gonna go to our formula sheet. And as you can see on this nifty formula sheet, there's a bunch of shit. Like Taylor series, where is it? Is it on there? Huh.
I would
Okay,
say just look up or find out the power series of that function.
there was a way to find out the power series of this function. I remember this. I don't remember how. You want to get it in a. Okay, wait. So there were a few standard power series that you want to get it in the form of, but I'm not quite sure which ones those that were. Oh, hey. Yeah. Okay.
Hold on for a second. Can you stay on that page for like 5
Oh,
seconds?
yeah. This one. This one is actually quite important. I'm gonna screenshot this.
Trust me, I already have.
Yeah, but I'm gonna put it in the calculus thing so that I can find it back properly. Okay, this is good because this means. Oh yeah. Okay, cool.
Yeah.
So okay, we want the power series representation of 1 over x to the power 3. So we have the power series of 1 over 1 plus x to the power 3. Well, if we look here, we know that 1 over 1 minus something, in this case that minus is equal to minus x to the power 3. Let me recompile here so you can look. This is just equal to this, however, the x is just equal to negative x cubed.
Mhm.
So the first few terms will be equal to negative x cubed to the power 0. Let's see, to the power 0 plus plus. So I get 0, 1, 2, and 3. And do we start from 0 actually? Yeah, we do, because it says n is 0 here. Around x is 0 to the first 4 non-zero terms. Does that mean the terms themselves cannot be 0? Does that mean the term it cannot be the 0th term?
No, the term itself cannot be 0.
Okay, good. So we get this. That's good. So then this will become negative x to the power. Well, if you have a power to the power, we can just multiply the powers. This will become x to the power 0. This will become negative 1. And this. So what I'm not sure of is this 0 disappeared, right?
Which one?
Does this 0 disappear? Does negative 1 to the power 0, is that 1 or not?
I think this entire thing is just 1 because it's something to the power 0.
Yeah.
Wait, what do you fill in? Do you get a 0 to the power 0?
No, you don't get 0.
Why not? You're filling in 0, right?
Well, it's
Oh, you're filling in.
around x is 0.
but you're using it to get an approximation of the thing. So,
What happens
I
if
think
-1 to the power 0?
The first term is 1. So so it's okay.
But what I'm wondering about is they have that extra x to the power 1 there.
Yeah, but we'll tackle that when we get there. And this is just this original number, and then we get the negative falls away because it's a square. This becomes x to the power 6. Where did that 2 come from? Okay.
Because you didn't remove the square.
Oh, yeah. And then this becomes negative again, and this becomes x to the power 9. So these are the first 4 terms, right?
I believe so.
Okay, cool. And now we can start doing fancy shit. And now, as Yellow was concerned about, we'll have the integral of the fraction of x over 1 plus x cubed dx.
Oh, yeah. So that equals.
So then we can say that this is equal to x times this fraction. Well, this fraction is just equal to, or at least can be approximated using this stuff. And then we can just multiply that x into the brackets, and we'll get.
And then it's basic
x
calculus.
4, 7, and 10. Watch me fuck this up. Oh wait, I should have first of all added this stuff. Oh, there's a lot of people leaving. Oh, we only have like 20 people
they're
left.
not true OG, sure. Don't worry.
Yeah, we the real kings. Okay, then the answer to this will be and wait, it is from 0 to 1/3. Frac 1 over 3. And x becomes fraction 1 over 2x squared. This becomes frac 1 over 5x to the 5th power. This becomes 1 over 8x to the 8th power. And this becomes 1 over 11x to the 11th power. Oh, that actually looks pretty decent for something I improvised with these things.
Yeah, that's how you do it.
Yeah.
If you really want, you can do double. No, actually, that would look ugly. I would say you can do just double underscore and thing up, but then we just put it on top and below it.
I mean, that's what I do. I do underscore and.
No, but do double underscore and thing for a second. I want to see what it looks like.
And
by the way, can I ask how we came up with this four terms in the beginning?
What do you mean?
These 4 terms, like minus x to the power 3, in the beginning we had it 4 times. Yeah.
Yeah, these 4.
Yeah. How did we came up with this?
Okay, so we have the original function is 1 over 1 minus negative x cubed.
Okay.
And here we know that 1 over 1 minus x is equal to just the sum of x to the power n. So then we have x to the power, or negative x cubed to the power 0, negative x cubed to the power 1, negative x cubed to the power 2, negative x cubed to the power 3.
But where did our original x go? Like it was the original sum was like x divided by x plus x to the power 3, right?
The original sum? You mean this one?
Yeah.
Well, we just get x times this function.
Yeah. Okay. So
we just
that's
distribute that out.
Yeah, we added in later back again. Okay.
Yeah. This is just the approximation of this thing, and then later we fuck around with this thing. Okay. So then we get this. Well, the 0 falls away because every term has an x in it, so we can forget about that. And that means we just let's see. So it's top minus bottom. So this is just filling in 1/3 everywhere. I can't wait to do all these fractions in my head because this stupid fucking thing says we have to fill in the first decimal. I mean, genuinely, I'm not even sure how they would want you to do that. So let's see, this is 1 equal to 1 over 9 times 2. This is equal to 1 over 18. This is 3 to the power 5 times 5. I'm already like, I already do not want to do any of this math anymore.
Hey.
So I'm just gonna fill it in like this. See if that works. Yep. Then we get 8 c dot 3 to the power 8. And then we get 11 c dot 3 to the power 11. Okay. And I need to get rid of the square bracket.
And you need to put
Oh
brackets
yeah,
around
I
the
need to
11.
put bracket around the 11.
At this point, you get out your calculator.
Yeah, but you're not allowed to use a calculator. I genuinely
Wait,
do
Jura,
not understand how they would.
just put this in the normal sense, like 1 divided by 1/18
Oh yeah,
minus.
yeah, like that's the plan. I'm just gonna enter this. This is good enough.
Wait, they accept LaTeX?
Yeah.
Holy shit.
Wait, why is the answer incorrect though?
Pretty sure because you have to round it to 5 decimals.
Yeah, you have to round it
Oh,
yourself.
that's so sad.
They're actually like that
Oh, damn
annoying.
it. Wait, that means we go to
Wolfram
Wolfram.
Alpha! Wolfram Alpha!
Like they accept LaTeX by the way. That's one of the reasons why.
Yeah.
Like that's one of the good things. Like I can just write fractions. I can do infinity. I can do sums. Like
Yo!
yeah, no, like that's the reason
It's
why
the
I have
fucking
time
last week of the thing. Why do I only find out about this now?
That's
Dude,
the
it
only
just-
like redeeming quality of Graspol, that it can accept LaTeX.
Yeah, I know, right?
1, 2, 3, 4.
1, 2, 3,
Yeah.
4, 5. Dude, we are so good at calculating.
I am not looking forward to them asking for, to round things to
The
decimals
correct
on the exam.
What do you-
No, wait, did they actually enter it as a fucking fraction?
Yeah, they want us to calculate it as a fraction, but they don't want them to have to do it.
No, this is not a fraction. This is the answer rounded to 5 decimals displayed as a fraction. Because if you look,
Yeah,
it's
okay.
all 0.5, which is
Yeah,
why
like
they did
this
that.
is the rational answer.
Yeah.
Yes.
Fair enough. Oh, fucking hell, why?
Calculate this in your head.
I really hope they just don't do this shit on the exam, but I'm sure they will.
I believe they already said that they wouldn't do that on the exam. You don't have to round on the exam.
Oh, thank God.
This is honestly just straight bullshit.
Yeah,
So why the fuck do we have to do it here?
good question.
Last time I checked, we were getting an education to be computer scientists, not a fucking computer.
Yeah, they should
No,
have
that's just a
assigned it
part of
more.
it. The same way that mathematicians are pretty much human calculators. We just turn into human computers.
Yeah.
That's shitty.
Okay, so here we have the same power series, but instead of x is equal to negative x to the power 8, we have 3, we have to the power 8. So that means we will get 1 minus this to the power 8 plus this to the power 16 minus this to the power 24. Dude, they want us to do like to the power 24 in our head.
Of course.
Head ass fucking monkey. Anyway. Well, that ends up being if we anti-derive that, we get x yeah, minus fraction 1 over 9 x to the power 9 plus fraction 1 over 16 17 x to the power 17 minus fraction 1 over 25 x to the power 25, and then we fill that in from. I am not doing the smart. Wait, I am. Okay, I thought I was like already multiplying it by x, but there's no x here, so we shouldn't do that, but I wasn't. And then we just fill in 1/3 everywhere, so we get frac 1 over 3. For some reason it's complaining. What is it complaining about? Did I forget like a closing bracket somewhere? Yeah, I did. Well, no, that's not correct. Where did I forget my closing bracket? Okay, wait, let me check this. If I get rid of all this shit, it stops complaining. So the fault is somewhere in here. Does it tell me where the mistake is? File ended while scanning use of frag. Oh! Motherfucker, that's a square bracket, not a curly bracket. Holy shit. The things I do for you guys. Okay, then we multiply that by this thing. Then we multiply that by this thing. Then we multiply that by this thing. Recompile. And then we plop that into Wolfram Alpha.
Hey.
Bop. Bop. I really hope he does understand that like this is multiplication. How many decimals? 5 decimals. 1, 2, 3, 4, 5. Dude, this is like legit 3. Gag. Dude, what do you mean? We have to do this all the time. Okay, wait. Wait, we already did this. But then with... Can I Control Z in here? I can Control Z in here, guys. Guys, we're good shit.
But honestly, how would you do this by hand, like converting it to decimals?
Not.
But I can see them asking this on the exam though.
No, I can't.
I can't.
They wouldn't.
Like, this is such a stupid fucking thing. I don't.
Yeah, that's exactly why I expect them to do it on the
Yeah,
exam.
okay. They're stupid fucking. No, okay. I'm not saying that on camera, but no, like while the education we have been receiving has been subpar, probably because of the COVID TM trademark. I do not think they will pull something like this, and if they do, we will just go to the student board or to like just send them emails en masse, because that's like calculating that is not within our study program.
What do you mean? Are you not able to do 4 billion calculations per second?
Dude, what are
Something
you?
all wrong.
I can do 4 billion calculations per second, which is not very useful.
They just all.
They
have the
just
answers
won't be
correct.
right. They will be
They can be
calculations, right?
I can do like a billion powers of 1 in 1 second. They're just all 1.
How dare you not be the first working quantum computer?
A quantum
But
computer
yeah.
wouldn't help with this.
For your thing about the education being subpar, that's not just a COVID thing, by the way.
Yeah,
It's a
no,
lot worse this year, but it wasn't optimal last year either.
Yeah. It's I can imagine. No, like I must admit I'm really enjoying just doing all this education from home.
Same.
Like I just don't have to go out. I can stay inside. Wait, let me see.
I loved it in high school, but university, I thought it was a lot more fun last year.
I really don't have the discipline to fucking learn here.
That's
I need
I would avoid it for fucking subjects, you know?
yeah. I mean,
Well, I
for me,
don't.
it's like I am really biased because I have 4 hours travel time, like to and from. So like it's 2 hours to 2 hours from.
Well, it's more like
So-
1.5 ish.
Yeah, okay, 1.5 to 2 hours. That's still like, if I have to go 1.5 hours just to get not lectured by Claudia, I am like staying the fuck home.
Wait,
I mean, those were optional.
how did you guys take an hour for lecture 13?
No, this is 11, 12, and 13.
Oh, okay.
It just doesn't show. Like, can you show more of the
Boys,
splits?
I have to go. I got a mentor
Okay.
meeting, so I'll jump back
have a
later.
good one.
Bye.
But yeah,
Also,
when
this
we
is
go
really
back to
fucking
on
big
campus,
brain.
I'm
You can
moving.
just say with x is equal to. What did you say?
When we go back to on campus, I'm moving.
And when is that? Do you know? Do you have any idea?
Next year.
Are
I
you
assume
sure?
that if you want to be vaccinated, then you should be able to by September or something. So I'm
Are
assuming
you
they
sure?
just
Because if that's true, then I'm leaving this city up until the next school year.
I mean, it's not 100% confirmed, but like their plan is to have people. If you want to get vaccinated, you should be able to around the summer. So I just assume it goes back to normal around then.
I very much doubt that our government is going to be able to pull that off.
Yeah, like we have been managing like very bad. I am, like our lockdown was extended twice. I expect it to be extended another 3 times.
I also heard that they made the decision to not vaccinate the medical personnel the second time. They need to actually have it work, and instead decided to now also half vaccinate the elderly.
Yo, what are you doing?
I mean, it's
I
mostly
genuinely
because
don't know.
literally
The
every group
answer's
is
gonna be
complaining.
correct, but whatever.
I mean,
Just
sure.
every group is complaining. Like
I just need a good forecast of how long this would take because I mean I
Well,
need to know.
I'm gonna be honest. Neither us nor the education or the government can say that because we have a lot of stockies, a lot of dumb people who would just like go out and party. Like I am really aggressive against people in the CSE chat who are like, "Hey, is there a party tonight?" No, fuck off.
No,
You're not
fuck
gonna
off,
party
yeah.
in COVID time.
Yeah, exactly.
And like,
No, but
because
at
of people
least
like that, that's the reason why it's taking so long. But yeah,
If
that's
it's
just
Yeah, if everyone would just be introverted as fuck, we'd be done already.
Yeah,
Would have been
exactly.
like, it wouldn't have been a fucking problem in the first place.
My birthday
but
was
people
last year during COVID. During my entire 19th or 18th like birth year, I have been outside less than 10 times. Like genuinely.
But my rights are being infringed.
Dude, shut the fuck up! I'm literally kidding you know.
I mean, I've been outside more, but that's because I live on my own, so I have to do groceries.
Yeah, okay. We
But
get
yeah,
groceries.
I see my
You
grandma.
can deliver home. You can do home delivery.
If you can prove me that we are going to be like distance studying like for this year, then this I mean I would really just don't live here.
Yeah, I can see that. Aren't you stuck with a dual contract though for a year?
Yeah,
So you have
I'm
to
in a
pay up
contract,
anyway.
man. No, I mean, but I can find someone else.
Okay. Although,
So-
who would take your place though? Because I found rooms for like, yeah, you're living right next to the library, for example, which is closed, and it's like, yeah, but in a couple of months when it goes back to normal, I do want to move back in. So you're just paying to have a room in Delft, but there's no reason to be in Delft.
Yeah, for sure. And yeah, I live close to the university, 10 minutes by bike. And if we're going to continue next year on campus, then I would gladly give my room because I will have enough time then to find another room. If I know I'm going to go to campus next year, next academic
Yeah,
year.
but we cannot say for sure that it's gonna be campus next year.
Wait, is the calculus exam only 90 minutes?
Yeah, because you can't do more proctored. That's not allowed by regulation.
Because we need a fee break otherwise, and that's not possible.
Yeah, and they don't want that because, yeah.
So, guys, we want you to sign a waiver allowing us to look at your dick while you're peeing to make sure there isn't any subscript on there.
Oh god, no.
No, there is no subscript on my PP. It's only superscript.
Of course.
Oh.
You fool!
You fool! I written on my dick in bold. I really feel sorry for the fool who has to watch this back.
You know what?
Just
Just get a huge tattoo of your cheat sheet on your arm or something.
They will literally use the cheat sheet.
We kind of have missed the last part of the previous lecture. I mean...
Oh, Jura, this is actually interesting.
Jura was doing a lot. Did we miss
might
a
be
lot?
interesting.
Because I
Yeah.
see Jura is already a Taylor series.
Okay, everybody, we're gonna
Wait,
look
how
at
are we
Taylor
all of a sudden
theory.
at lecture 15?
Roll
What,
ready
what
lecture.
lecture were you just doing?
We were just doing 14. That was like the annoying one.
We just finished it. That was the one with the
round 2.
Yeah, and what is the radius of convergence?
Yeah, but that... Yeah.
We only got like half the questions right, but that's because they
14
wanted
is
you to
fucking-
round the stupid shit.
Maybe we should do it then with more concentration.
14 and 15 are like, it's fucking garbage.
Those are very difficult. So
Those
maybe
are very hard. I was just like, fuck that.
Yes.
If they're gonna ask like 3 questions of that, I'm gonna be so mad.
Yeah.
I'm gonna show my ass on the RP now.
I'm gonna show my ass here. I'm gonna fucking dick and balls out.
Guys, I'm getting
Just fucking gape him.
It's like I'm
guys,
gonna go
shut
to
the fuck up. I'm
question.
getting demonetized.
Cock and ball torture.
The English big.
Honestly, were you even monetized to begin with?
Yeah.
No. Okay, everybody, like Taylor series. This is like the most important thing about
Power series.
like series. So
More derivatives. Yeehaw!
yeah, so basically it's just the Taylor series are like linearizations, but then harder. That's where it comes down to. So you have like the original value at a, which is going to be like the zeroth derivative of f at a, which is just the original value at a, divided by 0 factorial, which is 1, times something to the power 0, which is also 1. So this is just the original value. And then you get the first one, which is the first derivative over 1 factorial, then you have the second derivative over 2 factorial, the third derivative over 3 factorial, etc. So let's have a look at these. So we start out with e to the power of negative 2x cubed is equal to blah 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 blah. Well, first of all, we can see on the formula sheet that e to the power x is actually equal to this
formula
thing.
sheet?
Well, you can see the formula sheet. What's in here you can have on the test.
Fuck.
Did you not do that in the first test?
What? The formula sheet?
Yeah.
But the Taylor series weren't on there, so.
Well, they are.
I
This is
hadn't
the
checked
formula
it, yeah. I
sheet.
hadn't checked it, bro.
Yeah, like you were allowed to use this formula sheet.
But why is the integral of the sinus the ln tangent?
This is 1 over the integral of 1 over sine of x. But this is just stuff that you're allowed to use.
Fucking that's horrible. If you have any of those, all right. That's pretty cool.
Let's just continue. So the Taylor series of 2x, or e to the power x is equal to 1 plus x squared over 2 factorial.
They don't show the most important one though. That's 1 over 1 minus x. So I guess you have to know that one by heart, but.
Isn't 1 over 1 minus x just like?
Yeah, it's 1 plus x squared, and then.
Oh yeah. You're not allowed to have these ones. Like these are not on the formula sheet.
And the power series is x to the power n, which is pretty useful, I think, for 15 or 16, because you have to like keep converting them.
Yeah, these are not on the test. I would say like memorize them. Like just try really your best to memorize them, and then at the start of the test just write them down, and then
I think,
on your scrap paper.
I've done all the book exercises, and I've only used the 1 over 1 minus x. For the others I just used the series, like the long
fair.
ass fucking, which is given apparently. So
yeah, like these. But oh wait, actually, I think like this one is given, and what about the other one? I think that's just this, yeah. And then the other one is just this one divided by that one. Oh no, wait, never mind. It's the arctangent effect, not the tangent effect. Anyways, let's just continue. So we have e to the power x is equal to this, and we need the first 3 terms, or all the first 3 terms after x. So that's like plus x power 3.
I'm gonna say fuck implicit differentiation.
God, why is my implicit differentiation is pretty easy. I'm gonna like no cap.
It's pretty easy, but it's so easy to make mistakes.
Yeah, okay. I can agree with that. Let me work this out. So this is 6. This is equal to 24. This is equal
to 2. Isn't it just welcome to calculus, because that's literally what just happened?
Yeah.
Okay, so now instead of x, we have negative 2x to the power 3. So that's what we fill in for x everywhere. So we take this here, we take this here, and we take this here. So as you guys can see, it's a little bit bigger, That's because we have like a power and some other bullshit. But this is like doable because like the negative sign here falls away. This becomes a 4. This becomes a 6. You can get rid of this square.
Can you show the latex side better?
Hmm?
Can you show me the latex side a bit better?
Yeah, you could maybe squish the graspable window.
Holy shit! Oh. Wait, so oh, never mind. I was looking at the wrong one. I was about to say, like, why doesn't the X change?
Okay, so this one becomes a negative. This one, negative sign goes away. This becomes 8, and this becomes 9. Yeah. And then this, the negative sign goes away here.
Can I
How
ask?
does the negative sign go away with the third term?
Hmm?
Well, you fill in -2, right? So why does that become +4? The third one, the +4x to the power 6 divided by 2.
Because it got squared.
Oh, you already did the square, all right?
Yeah. This
How did you turn like x to -2 times x to the 3?
What do you mean? I just like fill it in.
Well, x
Like instead of
on
x.
it's
instead of
1
x
plus
here.
x. It's 1 plus x, and then it's 1 minus 2 times x to the power 3.
Yeah, because like instead of x here, we fill in -2 x to the power 3.
Oh, that
So
did I
this
see.
x
Okay.
becomes -2 x to the power 3. This x becomes -2 x to the power 3, etc., etc.
Yeah. Okay.
Okay. Okay, let me actually do one up it a little bit and get these x squared out of the powers of x out of the brackets. So that way we have our a, b, and c more clearly. We
By
can
the way,
recompile this.
it is confirmed, right, that the PSA is going to be low by at least 10% or something.
10 to 15.
To 50? 15.
It's 10 to 15%. But
yeah, so
we will hear more about it, hopefully within a week, and it was promised before the 1st of February.
Well, if it's 10%, you're going to have like a reduction of like 3 points or something, 4 points.
They will most likely reduce it to 40, but we do not know anything for sure.
Yeah, I don't think it can be more than that.
It will most likely just be 40.
Maybe they do it from the 60, right?
And it's probably only a temporary change, so that like we have to get those things in the next year to get the BSA, like they did last year.
Like an extension instead of a reduction.
But then they need to get. But then they need to just get like one of. Like, let's say you get 40 points this year. Then next year you have to only
we will
get
see.
one.
Let's continue with calculus.
No, hold on. One thing.
Nah,
I
you already have
want
the
to make one
answer.
thing clear. You don't. Next year you don't need to just succeed on one subject. You need to succeed on one subject which you failed last year. So it's not like the points from that year count with the BSA. The only
That's
points
what I was
count
thinking.
are
Like,
the
not that
ones
you all of a sudden have to
from last
pass
year.
everything. I don't want to
Yeah.
pass. I don't want to go ahead and pass ADS all of a sudden next year, and then if I fail, it's like, yeah, well, you're in your second year, but you're gonna suck. So please leave.
What is A, B, and C in this?
Okay, here you can see that's like the coefficients for x cubed, x to the power 6, and x to the power 9. And here that's just -2, 4 over 2, 8 over 6, or -8 over 6. So it's just the numbers they put in this place, and they want you to know like what is in this place.
Yeah, what are the coefficients of the first four terms?
Yeah, so in that case that is like -2, +2, -8 over 6, etc. Well, not etc. That's just it. The Taylor series of ln of 1 plus x cubed. Let's see if there's anything here for that. Yep. So we have, let's see, do they want, how many? First 4 non-zero terms. Okay. So we will have ln of x, ln of 1 plus x, excuse me, is equal to blah 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 blah. Get rid of this. X minus fraction x squared over 2 plus fraction x cubed over 3 negative minus fraction x to the power 4 over 4. Probably close enough. It's the first 4, 1, 2, 3, 4. Yeah, the first 4 non-zero terms. And then instead of x, we will have
x minus x to the third. Plus x.
X cubed. So we have 1x cubed. That's equal to, this is x to the power 6. This is x to the power 9. This is x to the power 12. I really enjoy these because they don't put any constants in front of it. So it's just...
Does the first x not change?
Oh yeah, it does. I forgot it, but...
Does it become third?
Yeah, x cubed. Okay, that's correct.
I like your 12,
Your formatting is off.
My format here, that's... Like, when you have two numbers, two digits, it's like you have to put brackets around them, but when you have one, you don't. I just keep forgetting that. But anyways, we want to have the integral of this. Well, that's not too hard. So I'll say the integral of this thing dx is equal to the integral of this thing dx is equal to recompile.
What does it just calculate that for you?
No, I'm gonna. I have to write it out. That would be sick, but that's equal to
both the exercise in formula sheet at the same time. Is it possible to show both the exercise and the formula sheet at the same time?
I don't think we have space.
Yeah, we don't have space, honestly. Okay, so let's see. This becomes 1 over 4 x to the power 4. Negative, this becomes, let's see, x to the power 7 divided by 7 as well.
Is 7?
For 14, right?
I thought 14 is
Or are you doing the...
Isn't it 7 times 2, so that becomes 14?
Oh, yeah, that's true.
13, this becomes 4 times 13, that's 42.
52.
Recompile.
Oh, did I miscalculate?
So it's like this.
No, it's 52, right? 13 times 4. That's 30
yeah,
and
52.
12. Yeah.
Thank you.
Yo, big brain.
Okay, cool. And then we fill in
0.
Well, 0, then everything falls away, and then we fill in the third. So they say, hey, round your answer to x decimal places. We go to Wolfram Alpha, we say with x is equal to 1 over 3, I think it was.
Wait, where do you fill 1 over 3? Where do you see that?
Here.
Oh, 1 over 3. Yeah, it's in there. You saw nothing.
And... Cool.
Wow, what a fucking horrible number.
Yeah, obviously. All of them are horrible. 1, 2, 3, 4, 5.
But how are you gonna do this? It's at the 4th decimal. How are you gonna do this in the exam?
Not.
So you're just gonna because I would just fill it in, like straight up just type it out.
Yeah, I will also just put in one.
Yeah, I will like. Maybe one of the ways you could do it is get all the fractions with the same denominator, and then make sure that denominator is equal to, or numerator, excuse me, same numerator, and then make sure that numerator is equal to 1,000 or like 10,000, and then do it that way.
This is lecture 15, right? How do we have the same questions in lecture 14?
Good question. Well, it's not the same questions, but it's the same type of questions.
Wait, can we use the calculator on the exam?
Nope.
Nope.
No.
I wonder,
The only
really?
thing is you have to round up.
Hmm?
No, nothing. Sorry.
Well, the one is the Taylor series, and the other is the Power series. That's a difference.
Yeah. Okay, so the thing of cosine is...
You still fill in the same thing, right?
1 minus the fraction of...
Like, you still just use that one schema, and you just...
Can you show the exercise?
Plug it in.
Yeah.
Okay.
So it's just an integral of x times cosine x cubed, but first we're calculating the Taylor, the first 4 non-zero terms of the Taylor series as blah blah blah. So then we have 1 minus plus fraction of x to the power 4 over 4 factorial minus x to the fraction x to the power 6 over 6 factorial. Okay. By the way, I use the equal sign very loosely here because this is not equal to each other. But
what is not equal to what?
Like this is not equal to each other.
Oh yeah, just with 3 dots behind the last one, and it'll be equal.
Yeah.
Then why do it equal?
Hmm?
Then why you write equal if it's not equal?
Because it is equal. These are like the first 4 terms of this.
So it's an approximation.
It's
so
like
it's not equal.
approximately that. If
Uh-huh.
this goes on to infinity, then it would be equal. But for now, it's just approximately this.
Okay, yeah.
So let's see. And we have a cosine of x cubed, which is what we needed to calculate. Yep. Yeah, and that's just x cubed minus.
Oh yeah, I just did a linearization in 2
power
seconds.
6. Then we do x to the power. Let's see, 12. Oh, now you have to do the thing. Now you have to x to the power 18. And then we have to take the integral of that if you multiply it by x. So we take x times this thing, because that's what's inside the integral. And we get x to the power 4, x to the power 7. Oh, I'll get rid of this thing. We got x to the power 13. I'll get rid of this thing. 4 factorial is 4 times 3 times 2. That's 24. I'll get rid of this thing. This becomes 19. And this 6 factorial is 720. And then we take the integral of that. That will result in 1 over 5 x to the power 5. That will result in 1 over 16 x to the power 8. That will return in 24 times 14. That's 240 plus 4 times 24. 240 times 96. 240 times 96 is 336. And then our favorite. Oh, never mind. It's actually pretty cool. It's just 20 times 720. That's equal to 1440. And then they want us to fill in a half and then calculate this out.
You mother.
So let me get this in so it looks a little neater. This is the answer. This is the antiderivative of this. Then we have to fill it in the integral. Or then we have to like fill in a half and 0. So what we do is we fill in x is half. That gives us a fractional representation. That gives us a decimal representation. 1
to the
two,
power
3.
because it's 1 in the original function. Cosine x is 1 minus something.
That's a good one. That's a good one. I didn't see that. Thank you.
Yeah.
So this becomes oh fuck, wrong thing I'm editing. I thought it was x. Yeah, that's a good one. So this becomes 1. Then this becomes x. Then this becomes 1 over 2x squared. Thank you.
What changed? What changed?
So here I said 1. If you fill in x cubed, that becomes x cubed, but that's not true. It's still 1. So
Yeah, you don't multiply.
Yeah.
So that's the
and
whole
then
thing
we
with power
multiply by
series.
x, and then we integrate.
There's 2 ways to change things in power series. Either you multiply both sides or you fill in something for x.
Yeah, and here, like, this thing here is equal to x times this thing here.
It looks like your timer's farting now.
And why do you integrate many times?
Hmm?
Why do you integrate many times?
You only integrate twice.
I integrated once.
Okay.
This thing
Why?
here is
you
because
multiply by
I
x.
multiply by x, and this thing here is when I integrate.
Yeah. You could have used an x cosine x to the third equals, but whatever. To like be more clear, but you know.
Yeah, I could have. So this is equal to 8. 1, 2, 4, 8. Dude, that's hilarious.
We're still with like fucking 20 people. You're absolute legends.
Yeah.
Should we have a lunch break though?
Yeah, let's do a lunch break after lecture 15.
Okay.
Dude, look at this shit.
Look at this dude. No.
Oh, no. Okay,
I don't even know how to
I think
start
all in all,
with
like, this looks really hard, but it's not that hard.
Wait, what was the answer actually to the question? What did you say?
0.1248.
Yeah.
Okay. Yeah, never mind.
I guess just take the one, take the Taylor series for the cosine, take away 1, and divide it by that entire bullshit.
Yeah, indeed.
And then fill in 0.
We take the Taylor series of the cosine. I'm just gonna use like the first 3 because I'm 100% certain that this is gonna like divide away. But we have the cosine of x
I've been doing the first like 10 lectures by myself, and every time I've got a red or yellow, and I'm like, it's fine.
It's sure it'll be fine. Okay, the cosine of x is equal to 1 minus x minus fraction x squared over 2 plus fraction of x squared or x cubed over 4 factorial minus the fraction of x to the power 6 over 6 factorial. So I'm doing 4 terms, so the only terms that are on the paper. Same goes here. E to the power x is equal to 1 plus x to the x cubed over 2 factorial plus the fraction of x cubed.
Oh, so you take Taylor series of both?
Yeah.
Okay.
I'm gonna put ... here because as you can see, it will strip away quite nicely. So first of all,
can't we rename those things with just some from n to infinity?
We could, but I think this conveys the message better of what we're doing.
Yeah, okay.
So I'm using ... here. That just means this series will grow on further. We can get rid of this -1 here. We can get rid of this 1 here.
Can get rid of this yee-ass haircut.
We can get rid of that yee-ass haircut. You get some bitches on your dick. We get rid of this -1 minus x. Recompile.
Hey, why did you remove minus?
Yes. Oh, that's not possible. Only when you multiply, not when you.
Yeah, why did you remove minus x?
Okay, I'll show you guys again. 1 plus x minus 1 minus x.
Okay, I'm blind.
No worries.
Okay.
Okay, so I'm actually gonna write a few more terms here. So I'll take this term and just copy this on 4, 5, 6. 4, 5, 6. Okay. So this is what it will look like.
They want us to evaluate the
Yeah, they want the limit as x goes to 0.
Huh.
So that's just 0 over 0. However, what do we do when we have a 0 over 0 situation?
Hospital.
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 Sorry.
Hospital. But yeah, we have a 0 over 0 situation, so we can use l'hôpital. So we get rid of this one.
Becomes minus x.
Yeah,
but this will continue infinitely large. If you want to do l'hôpital on a series and you have written out that series, then you will also have a value that is above the current values that you displayed.
Yes. So we extrapolate from what we have displayed here.
Yeah. Let's see. So 3, and then this becomes 4 squared times 3.
You can just drop all the factorials one lower.
No, because 4 factorial times 3 is.
But you multiply by 4 because you dropped the 4.
You're a mammoet.
X to the power of 4, and the derivative of x to the power of 4 is 4x cubed.
God damn it, you're right. Dude, I have Pepe.
This doesn't look like it will fix much. I'm just saying.
Oh yeah, it will. It's just gonna take a while.
Because you can also drop it down in the bottom, and then you can factor out some terms. I think. I hope.
Hold on for a.
No, we just do it. We just do it again. So this is gonna be 4, 4, and it's gonna be 5, 5. We recompile and we look. Ta-da! We haven't progressed.
Actually, no, it's a sum. I'm retarded. You can't factor.
Oh yeah, yeah. If you do it once more.
Yeah, we just do it once more, and then we'll be left with Like I can already tell you we're gonna be left with -1, but
yeah.
like.
Oh, yikes! This is not a fun exercise.
Can you just simplify by x?
Well,
what do you mean simplify by x?
No, but then you have to also drop
divide the denominator and the numerator.
Yeah, you could. That would actually be an easier way to do it, I think.
Yeah, fair enough.
Yeah, we could have done that from the start already.
Yeah, we should have done that at the beginning.
Check my
But then you would get -1/2 divided by a half. Okay, that's -1, yeah.
Yeah.
Monka.
Monkey.
Oh, God.
Determine the coefficients an of the power series an(xn) of e to the power.
What's the number behind the timer again? Just slightly curious.
This one?
No, behind the timer. Just move the timer. Almost there.
Almost there, boys. This is the last of the series, and then we can have lunch. I genuinely don't know what my pause button is. It's page up. Okay.
Genuinely don't know what the derivative of a tangent is. Wasn't it 1 minus cosine squared?
Oh, I see. I see how we have to. The derivative of the tangent.
Yeah.
1 minus tangent squared x, or 1 divided by cosine squared x. That's probably wrong.
Welcome to things you probably should know by now. You're doing university education.
Yalla, do you want me to punish you? You don't know either.
Okay, you know what? I'm going to grab a piece of paper and I'm going to do sine of x divided by cosine x. That is.
Okay, so.
I'm gonna do it by hand.
Okay, so looking back at our thing, e to the x is equal to this thing, right? Therefore, e to the x minus 1, and this is university level math, is equal to this thing. Therefore, if we do e to the power x divided by x, frac e to the power x divided by x is equal to 1. Drop down the power by 1.
I highly recommend filling in the 2x before dividing by x. Because if you fill in 2x now, I think you're going to have to divide by 2
there's
again.
a 2x here. Dude, that's a good call.
Yes. So I don't know.
So wait, that's 2... okay, so it's 2x, but not 2x squared. So I can just fill in... and of course, don't forget your brackets. Well, I can do this by heart. That's like 4. And this is like 8. I'll do one more. I'll do fraction 16x cubed over 4 factorial. Okay, then I divide everything by x.
My God, I'm good.
This becomes 1. This becomes a powerless. Fuck. Damn, I'm good. Fuck. Becomes powerless.
Not a word.
Powerless. Okay. The coefficients of the power series. So you guys see, they want the stuff that is not in front of that is not included in the x. So yeah, so it's basically this stuff.
Wait. Okay.
So that is.
Why it's a simple question, but why did we start to look e to the power x to find this coefficient to do this exercise?
Because we need the Taylor series of e to the power x. And from there on, we can convert that series to something that looks like this. So here we filled in 2x and subtracted 1. And here we divided everything by x. So yeah, then we get... So this is with 0, this is with 1. That means we get 2 to the power n plus 1 divided by n plus 1 factorial. Is that correct? Then we get... No. Let's see, okay, so this is for the 0th term. This is for the first term. So for n is 1, this becomes n... Yeah, that's correct. And this becomes correct as well.
But for the 0th, it's 2.
Yeah, but that's the thing. It indeed, I don't think it's right for the 0th term, which is annoying.
Yeah, it's 2.
But how do we get rid of that though? Like... Oh, wait.
What do you mean?
Wait. Give me a sec.
Oh.
Yeah. I fucked up. Yeah. Okay. Thank
Why?
you guys.
Why look only? Why we look only at the 4 terms? It's like the first 4 terms.
Because from there we can develop an intuition on what we are supposed to do.
Yeah, if you want on an exam, you can write all infinitely many terms.
Yeah, you're just gonna run out of time, like infinitely fast.
You're just gonna die of malnutrition.
Yeah, you will be 0% done by the time the exam is over. So therefore, like, we only write out the first few terms because from there on we can derive what the pattern is.
Yeah, so actually you have plus ... at the end.
Yeah. This will be plus ... Yeah.
Yeah, but because this is a subject where they don't look at your calculations, we just write ugly and dirty math.
Yeah, exactly.
Because this.
Also, real quick, so what happened is I forgot to replace this x by 2x. So this is actually 2, and therefore this will hold because at n is equal to 0, this is equal to 2 over 1. So that's 2, that works. Check my answer. Woo! Okay. 5 of 5. That means we can go to a new tab, click the next time button, and we are 2 hours and 20 minutes in. And we still have 1, 2, 3, 4, 5, 6, 7 things to go.
Wahoo!
The timer is paused, guys. We will have a small lunch break until 5 past, half past. Dus 13:35. So 10 minutes.
35. Let's put it at 40, shall we? Let's give everyone time to have a decent lunch, not scrunch.
Yeah, 40. Yes.
Okay,
40.
15 minutes.
Yes.
Everybody, be back in 15 minutes, and I will see you guys then.
Yeah.
Voer.
What was actually the answer to the last exercise? 2 to the power n plus 1 over what?
Where? What do you mean?
No idea.
Yeah, no, it was that 2 to the power of n plus 1 divided by n factorial. I think.
N
yeah, you see it. Yeah. To the power of n plus 1 divided by n factorial.
And this is the form of the Taylor series, right?
That's for the coefficient of this Taylor series. A-n.
Oh, I see. Yeah, this is the form that we use because, yeah, this is what it goes to. Yeah.
It's 10 min 3 tweede.
Thanks.
Correct, toch? Ja. Waarom is dit 3/8? Ja, oké. Je kan dat ding naar buiten halen. Nee, je hebt hem omgedraaid. Het is 3/2 in plaats van 2/3. Want het is 1 delen door wat er staat. Ah, oké. Mijn methode was goed. De methode was goed. Behalve dat het fout was. Ja, dat zeggen ze. Als je een fout doet, dan zeiden ze het gebruik is.
Is there anyone here who has gotten connected to the fiber network in Netherlands and knows how the swap goes? Like, is it instantly or do you have to wait?
The what network?
I'm gonna get fiber installed on Thursday. I'm just wondering how long it takes to actually have internet via fiber instead of the copper cable.
What company?
Regge Fiber.
Okay, I have no idea. Maybe you should probably contact them. I have from Zigo, and like they respond pretty quickly.
Hey.
Gegroet, neven en nevinnen.
Gegroet. Okay, guy. I just wanna put an F in the chat for the guy who 3 days before the hand-in date for the web assignments asked in the looking for group chat like, I really need somebody for the web assignment right now.
Holy shit! He's gotta be kidding.
I really hope he's kidding.
I mean, I haven't started yet. I might do the first assignment and fuck the other two.
Last year I didn't even do the assignments, studied for 1 day and passed. But like I skipped half the courses, half the lectures. So it's fine.
I heard that so often people just skip half of it. How are you sure that you're gonna be fine?
I wasn't sure.
Because this sounds like a recipe for disaster. Like not to flame you, man, but no.
Yeah, like I'm gonna be honest. Most of the time, people say, you know, I just watched 3 lectures in a day and I didn't do the exercises and then I just went into the exam. It usually doesn't end up fine.
No, I just read the slides, like a speed run, like 3 hours.
Oh, reading the
Everything
slides
working.
works.
Yeah.
Tangent of 0 is 0, right? Yeah.
Yeah, most likely.
Oh yeah. Sorry if I'm going hell yeah often. I'm doing integrals, okay?
Yeah, that is really not like certain about the integral. Curious, out of curiosity, what were you guys' like midterm grades? Because that shit was fucked.
Yeah.
2.9.
What? A 3.9?
2.9.
Ah,
Went
okay, don't
fucking
listen.
awful.
Dan is het.
Why?
I'm curious. I had like a 6.3, but I spent like fucking 5 hours, no, like 8 hours doing just calculus, and even I just got a fucking 6.
Like I finished high school, yeah, with a 10 for maths D and a 9 for maths B, and my midterm grade was a 5.7. Like what? Like I think it's mostly because of the fact that they don't check your workouts. Because if you make one mistake, entire question's wrong. Which is I think like because you would have had at least half of the questions wrong by now, because every second question someone has corrected you.
Oh yeah, definitely. But that's because like during the speed
You're
run,
doing it quick, of course.
I go any percent, not 100%.
Yeah,
I mean,
Kinda saved
that's
by
what
the
messed up my
portion.
midterm too. And also, a couple of questions I had the right answer. I was like, wait, no way, it's this easy. So I changed it, and yes, it was that easy.
Yeah. For me, it's like usually I do the questions on an okay pace. If something is too hard, I put it away until later, and then I just like go by all of the questions, and when I have time left, I go back to the hard ones, and then when I have time left, I like double check everything. Look for mistakes.
Although I also just went really slow because I ran out of time. I didn't even have time to check most of them for a second time.
I think I had like half an hour left or something. I had a lot of time left on all of the midterms, I think, or yeah, almost all of them. I had like a lot of time left on my first the first half.
Did you guys check the statistics? Because it wasn't as bad last time. Did you check the pass rates
Well, I'm like.
for the midterm?
Huh? What? I'm not
Did you
sure.
check the statistics for the midterm of calculus, like the grades?
Did we look at them yet?
Mhm.
I'm not sure if we actually have access to those. I thought you were talking like, did you take the course PTS? I was like, what? But no, I'll have a look for you. Grade. I don't. No, calculus isn't available on the thing, so we don't have statistics.
Nice.
And we do know it's like pretty. It's probably pretty fucking yikes. Hopefully, because of that, they will make the end term a lot easier, though. Probably
Or
not,
maybe-
but a man can hope.
Yeah.
I'm hoping
Like,
for an easy end term. I'm expecting it to be at least twice as difficult.
We don't have partial points, right, for the end term?
No, it's all or nothing, the whole exam.
Yeah, and you can wait. No, actually,
Well-
like for JavaScript, you cannot go back
Didn't they say
before.
it's open?
So they did give partial points in the midterm.
Did they?
No.
Yeah. Partial. No, they did partial
They
points.
did.
How would you get partial points as you only write down your answer?
Yeah, so I don't get how they did it, but they did it.
I don't believe.
Yeah, I got like a 5.
My
or 6
grade on
Apple,
Crespo
and I
is
have
like
8.4.
20% lower than what I got in thingy.
Yeah, mine's 30% lower.
So they did give some partial points. And I also said they did.
I just assumed they kind of scaled it up towards a 10. Because that more or less fits whatever they gave me.
But you need to watch the 10.
Ooh. Okay, guy. If you look at the looking for group guy, that guy's fucked.
Yeah, he is fucked.
Like,
No, he's not.
a close friend of mine in the server, he dropped out, and like, he still finished the thing. Sorry, they still finished the thing. And they like even though they dropped out and had no need to, like, it's a dick move to not respond.
Yeah.
Yeah.
I'm sorry for that guy.
Yeah, I feel sorry for
He's
him.
not passing those assignments.
No, he's not. I mean, all in all, like, you could theoretically do it yourself,
Yeah, you could.
but it's not fun.
No. Oh, by the way, let me give a word of warning to everyone. If you decided to use classes in the JavaScript assignment, you might want to change it.
Why?
They got kinda pissed.
What? Why? They literally say like, hey, you
It
are
wasn't
allowed to
one
use-
of the 3 ways they had it in their lectures, so they got annoyed.
How do you know that? Do you go to a team?
Because we already signed it off and we almost got failed because of it.
Oh yeah. Cool.
I literally just converted our code to one of the other things right in front of him, and that's the only reason we got a pass.
Like, you mean classes instead of constructors or something?
Yeah, so they don't want you to use the class keyword to write your classes. They want you to write a function, assign it to something, and then assign the methods to that function as an object.
I'm gonna see what we did, yeah.
I'm pretty sure we did that. Yeah, we don't use the class keyword.
Yeah, they probably did.
Gigabrain,
Make sure it fits one of the 3 things they give in the JavaScript lecture.
edit. Find the word class. No results found. Capital C, class. No results found. Ah, it's Gucci.
They are probably good.
Yeah, actually, I think actually most of the code is in the other page, so I'm gonna check our app.js as well.
For like web.
Class, no result found. Class, no result found. Epic.
For the web assignment, you can, but do not have to use the newer features. That's the thing. But
Yeah.
At the same time, earlier they say, you have to create. Yeah, choose at least one of the object patterns designed in the lecture and yeah. So.
Yeah.
Because of this line.
Yeah, that's why they got annoyed by it. But class keyword is just an abstraction of one of those patterns. But
Yeah, correct.
I think people are joining and leaving expecting calculus.
Yeah, we're doing calculus when the break is over. That's like 3 minutes ago. Don't worry.
Oh, there's a break.
Yeah.
There's a break until like 3 minutes ago, but then this came up. But like, yeah, I'm finishing this and then we'll continue with calculus.
How are you doing it, by the way? Just solving.
Yeah,
How is it organized, this thing?
We're just like going
I
through
actually
the whole thing.
I actually got I'm looking at my midterm grade now.
Yeah.
And I did get kind of partial points. However, the partial points are not partial points. If the answer, for example, is minus square root of 2, square root of 2, and my answer is square root of 2, then they give partial points, but they do not give partial points.
oh,
for
okay,
working
that's how
out.
they did it.
Yeah.
Okay, so if you had your sign wrong, you still got a part of the points.
Well, no, not if you have your sign wrong. If the answer, so here is give the horizontal asymptotes, and I just put down y is square root of 2, and there were 2. Minus square root of 2 or square root of 2, so that is why they yeah.
Okay, that makes sense. Yeah. So they gave sort of partial points.
Not partial points for your workings, but partial points if you had parts of the answer.
Yeah.
Yeah, well, that's better than I expected of them, honestly.
Guys, let's continue. I just realized I do not understand or do not know how to do vectors in LaTeX, but we'll see how we can. I think I should be able to return with this key. Whoa! Okay, lecture 16. Let me quickly put a thing in the general chalkboard. Break is over, guys. Okay.
I like how Jure used to be the assembly guy, and now he's just taken over the role of chaperone of the entire fucking year.
Yeah, I thought after assembly interest would dwindle, but we have 20 people, so turns out that
You are giving better lectures than the lecturers, so.
yeah, okay, that's fair.
What is the reason that you have forgotten own voice channel?
At the start of the year, real quick, at the start of the year, people had to do assembly, and nobody knew assembly because all we got was a really fucking shitty lab manual. It did the job but barely. So I on Tuesday I started coding assembly, and I spent 8 hours trying to do it, learning it, and making 3 different programs. And then on Wednesday I said, hey, at everyone, I'm gonna do some assembly in this channel. You're welcome to join. And it turned out we had so many people in that channel interested in it that they couldn't watch my live stream anymore because we had too many people for Discord to share my screen to. So somebody had to stream my screen to Twitch, and people had to watch from there. So a lot of people were interested in assembly and in me explaining those programs. And from there on, I just gave multiple lectures about assembly, about everything really. And I do exams as well on here. And that's just the reason why I have my own channel, to just do these exams so people who are too lazy to do them on their own can do them with me.
Amazing.
Yeah.
Shall we go?
Yeah, okay, so we are looking at the let's see, it was lecture 16. No, yeah, 16. And we're starting out with something relatively easy. We have to find the cosine of a this one. So we're using this function. A dot product b is equal to, so I'm gonna do a c dot b is equal to mid a mid b mid times cosine theta. I'm not sure if I even spelled theta right. I'm not gonna use the infinite series anymore. Okay. So our question was, so we have the dot product of a and b, so that is equal to ax times bx plus ay times.
Oh, someone's echoing.
I think it's you.
Can't be me. No, it's
Demon.
Yeah.
Plus az times bz. Is this correct for dot product? Yeah, right? It's just
yeah.
Yeah.
Okay, sick. And then we have the length of the vector, and it's just the square root of -4 squared plus -1 squared plus -3 squared times the square root of -2 squared. So I'm just gonna write down 2 squared because it's less effort. Plus 9 plus 1. Cool. So, oh wait, I need to use other types of brackets for my square roots. Excuse me. There we go. Okay, for the left side, we have ax times bx. That's -4 times -2. So that is just 8. We have -1 times 3, that's -3. And then we have -3 times 1 is -3. So we have 8 minus 3 minus 3, that's equal to 2. And then we have square root of 16 plus 1 plus 9. Well, that's the square root of 25, that's just equal to 5. And then we have the square root of 4 times 4 plus 1 plus 9, that's equal to 14.
Square root of 26, I think.
I was about to say, I made a mistake there. Oh, wait, no, huh? Okay. So you said square root of 26. Is that for the first one? Yep, you're right, square root of 26. And then we hear
square
square root of 14.
Second one.
Okay, so then we have this is equal to cos theta is equal to 2 divided by this thing. So then we end up with this. And I think that's good enough. Like, you could simplify it a little bit more if you want to, but there we go. Okay, next one. For which value of h are the two vectors perpendicular? And being perpendicular to each other means they are loodrecht, toch?
Yeah.
Okay,
Yep.
Yes.
so for two vectors to be perpendicular, the dot product has to be -1.
Doesn't have to be 0.
No, it has to be 0.
Thank you. And this is why I do these things, because I also learned. So we have -2 plus 4 plus minus 2h is equal to 0. Well, like, this should be relatively easy. So then we have 2h is equal -2h is equal to 2, so h is equal to -1. I swear to God.
Isn't it 1?
We'll see. Hey. Oh, because this is -2 instead of 2. Okay, yeah. Excuse me. My math is rusty. Determine the length of the vector r. Well, the length of the vector r is equal to, so I'll put that down, mid r. And I know there were some questions about this, so I'm just gonna roll with it and see how far I come. And if I don't get there, you guys can help me out. But I wanna see if I can get this. So it's gonna be equal to the square root of 2u squared plus 3v squared. Yeah, because the absolute value of a vector is equal to the component squared. I keep using the wrong fucking thing, man. I swear to God. Okay. So recompile. There we go. So we have u. We know that the absolute value of u is 3. We know that the absolute value of v is 1. So let's see. What about u squared? What is that?
Nine.
I'm not sure if we can replace u by absolute value u here. But
I kind of forgot how to do this.
What...
So I would just work it out like that, and if it's wrong, then it must be something else. Because I'm also not sure anymore.
Okay, fair. So then we have r being square root of 19 or 22, because we have.
I don't think you can do this.
Hmm?
Because they're not connected in a straight line. They're at an angle. So you
Yeah,
can
you're right.
their lengths.
Yeah, that's true.
To use the dot product to find the angle, and then
there should be.
Wait, I think I remember this one. Can you show me the question real quick?
Let me scroll up a bit. Yeah, sure. Question here.
Yes. Okay. Determine the length of vector r. Yes, I remember this one. So the length of vector r.
Yep.
That will be, and you're gonna really thank God on your knees you've got latex. It will indeed be 2u squared plus 3v squared.
Yep.
So, actually, no, it is not u squared plus v squared. That would only work if u and v are perpendicular. and they aren't. So it will be 2ux squared plus 3uv squared, or 3v squared, or vx.
Vx.
What I'm saying is you have to calculate the x component and the y component different from each other, and then it'll cancel out and work. I've done this one before. It is quite a bit of work, but it's very satisfying. I barged into your room and made you do this one.
I know. I just don't remember. So we have the x component.
Yeah, like you just need to write it down differently. You need to write down the length of r is, and then you got to find out what the x component is and square that, and find out what the y component is and square that.
Okay, so it's r underscore x squared and r underscore y squared.
Yeah.
Like this makes sense. We knew this.
Yes.
Okay, so the x component of r is equal to quick brain. So we have 2 times the x component of u plus 3 times the x component of v. Let me write that down like rx is equal to. Oh wait, I see what's happening. Okay, and we have ry is equal to 2 times uy 3 vy. Okay, so we know this much is true. Do you guys understand where this is, like, that this is correct so far?
Not yet.
I guess not.
Okay, so yeah, you can just, like, if you add 2 vectors to be another vector, you can just add the x component to be the x component and the y component to be the y component. And in this case, we just multiply. Like, I only care about these 2 things, like these 2 equations. Do you guys understand that?
Yep.
Okay, cool.
No.
No? Okay, so if you add 2 vectors, let's see if there's like anything about adding 2 vectors here. Yeah. So if you add 2 vectors, you add the first term and then the second term and then the third term and then whatever. Like, go on and on and on. Like you basically use these 2 rules. So the x component of r, well, I'll write down the equation for r as well. R is 2u plus 3v. So the x component for r is equal to 2 times the x component from u because of this 2, and 3 times the x component from v because of this v. Because as we know, like 2u is equal to the vector 2ux 2uy.
Kind of.
Okay. Let me see if I can get this a little clearer, because this is like an important concept.
Maybe you can write this in matrix notation.
I'm not sure if I can. What happens if I do this? Like the notation they use? It will probably crash. Oh, it doesn't. Pog. Okay, so we know.
Can you go to the exercise?
The
exercise.
The exercise is this.
Yeah.
But so far we're not doing anything with the exercise anymore. I just want to explain how these 2 lines work, and from there on we can continue with the exercise, because the exercise is a bit of a tricky one.
I mean, I think I have an idea. Okay, let's continue with your explain.
So let me just write this down. So we have u is equal to ux uy. Like, I sure hope you guys can agree with me on this line. This is the vector u.
Yes.
Therefore, 2u is equal to 2ux plus 2uy. Because of this rule, scalar multiplication. And therefore, for the same reason, 3v is equal to 3vx 3vy. And therefore, r is equal to 2ux plus 3vx plus 2uy plus 3vy. and that is because, like, when you add two vectors, you add the x component of these two vectors, together, and the y component of these two vectors together to be the y component of the new vector.
This makes sense.
Okay, good. And like what is written here is exactly the same as what is written here, right? Because the x component of this vector is equal to this, the y component of the vector is equal to this. Okay, that's good.
Great.
Now we also know that the length of r, which is what we want to get, like that's like literally our exercise, the length of the vector r, is equal to the x component squared plus the y component squared. Right?
Mm-hmm.
Okay, so then we can fill in this. And we can fill in this, because this is just literally equal to the x and the y component of r. Recompile. Then we get this. And we can work out the bracket, and we get 4ux squared plus 2 times 2 times 3, that's 12ux vx plus 9vx squared. So this is what you get after working out the left side. Okay. And then we work out the right side as well, so then we get 4uy squared plus 12uy vy plus 9vy squared. Somebody is breathing into his mic. It is Marek. Or
oh, sorry.
Okay, cool. Okay, so far all we've done... Oh, that doesn't work. All we've done is we've expanded this fraction, right? Now we can group... now we can group some terms together. So... Yeah, okay. So what I'm gonna do is I'm gonna group the 4ux and the 4uy. I'm pretty sure I said the wrong thing, but it doesn't matter. I'm gonna group those two together. And I'm gonna group together the 12ux vx and the 12uy vi. And I'm gonna group together the 9vx squared, 9vy squared. So all I did with this line is I just changed some stuff around. So I moved this one over there and this one over there. That's all I did, right? So what we do then is first I'm gonna get rid of some exponents to make stuff clearer. So I'm gonna get rid of this 4, this 9, and this 12. Or well, with getting rid of, I just mean like dividing out the fractions. So all I've done for this one is I've just divided this stuff out, yeah. Okay. But now we can start to realize something. Namely, the length of a vector is equal to the square root of the x component squared plus the y component squared. Well, here we have the x component squared plus the y component squared. So to turn this around, if we have mid of u, so the length of u, the absolute value of u is equal to the square root of ux squared plus uy squared. Right? We know this. This is one of the definitions of the thing. Therefore, if we square both sides of this, we can get the square root of the absolute value, or the absolute value squared is equal to this thing, right? You guys with me so far?
Yep.
Whoa,
good.
Yes.
So therefore, we can replace this part, this ux squared plus ui squared, is just equal to the absolute value of u squared And vx squared plus vy squared is equal to the absolute value of v squared. So therefore, by filling in this, oh, put it on the wrong line. By filling in this into here, we got so far. And we can also notice another thing, namely, if we have the vector v with the dot product of the vector u is equal to ux vx, yeah, plus ui y. So if we compile this, you guys can see, this is like the definition of the dot product, right? Okay, dot product is just you add the x's, you add the y's, you add the z's, whatever.
Nice.
And we can
All
fill
of
that
this
in
looks
here as
so
well.
beautiful.
So this is just nothing more but 12 times the dot product of u c dot v. And now, by just filling this stuff in, this is all stuff we know. So we know that u is equal to mid, so that's like the absolute value of u is equal to 3. We know that the absolute value of v is equal to 1. And we know that u c dot v, so the dot product of v and u is equal to negative fraction 3 over 2. So we can recompile this. And this is just a number. So from here on we can just fill it in. So we get 3 squared, that's 9, 4 times 9, that's 36. We'll get, well, 9 times 1. And we can add these two together, that is 45. We get, we can get rid of this negative sign. We can do 12 times 3, that's 36. We can divide that by 2, then we end up with 18. And then we end up with square root of 45 minus 18, that is 27. Yeah, I'm pretty confident about that. And that's like 3 square root of 3. And that's a good place to stop. Somebody got that fucking reference. Let's go. Enter. And there we go. I took 20 minutes to explain one exercise, but by God is it like probably helpful, because they're probably going to pull something like this in the exam.
Nice.
Next one. And this one is a little easier. I'm going to put this into the VC channel real quick. Just so that, like, if I want to show it again. Actually, if I just get rid of that YES haircut. Oh, LaTeX bot isn't enabled on the channel, whatever.
Why did that name suddenly come
I
back?
can enable the latex
No,
bot.
it's enabled, it's enabled.
Okay,
Why
good.
did YES haircut suddenly get revived though?
I don't know.
Like the fuck happened? I've
I
been
don't
seeing
know.
a lot of recommendations
I'm
about it
pretty
on YouTube.
sure. I'm pretty sure it's just because everyone is just depressed as all hell, and we want a taste of when coronavirus wasn't a thing.
We just want to go back to 2013.
Yeah, I wish.
Really, just let me go back, man. Let me be happy.
Okay, so now, well, they're asking are these two values perpendicular? So then we just take the cross product again. We get -6 plus 3 plus 3. Well, that's equal to 0, so the answer is yes. It holds that r is equal to 3u times u plus -2 times v plus 1 times w. Furthermore, it's given that the 3 vectors are unit vectors. Determine the length of vector r. Fun.
Yes.
I mean, this doesn't look so bad. So I'll write down what we know. We know r is equal to 3u minus 2v plus w. Whenever I see the w in math, I think of the Lambert w function, but it's like not relevant at all here. We also know that the absolute value of u is equal to the absolute value of v is equal to the absolute value of w. Because
Well,
they're all,
if they are unit vectors, can
yeah,
you
because
just...
they're all unit vector, because they're all equal to 1.
Yeah, but then you can just say that this is the vector 3, -2, 1.
No. Can we?
Yes, I think so.
Yeah, you can.
Yeah.
Holy shit. Oh wait, not just because they're a univector, but they're perpendicular to each other.
Yeah.
I see.
Exactly, that's what I meant.
Yeah, I was like, no, like this is not enough info, but this is. So when they are perpendicular to each other, that means that one of them is equal to 0, 0, 1, one of them is equal to 0, 1, 0, and one of them is equal to 1, 0, 0.
Exactly.
These vectors can also be called I, j, and k in this field.
But they're interchangeable because you don't know which one is which.
Yeah, exactly. We don't know which one is which, but that doesn't matter because all we need to know for the length of vector r, well, we know mid is equal to the square root of, well,
14. 3 squared plus 2 squared plus 1 squared.
Yeah, that's true. I was gonna give some like explanation, but we can just say like 3 squared plus -2 squared plus 1 squared. Dude, I swear to God, my fucking is equal to square root of, well, that's just 9 plus 4 plus 1 is equal to square root of 14. And 14 is 2 times 7, so we can't factor anything else out of there. Recompile up. So yeah. Okay, for which value, we already did something like this. Maybe even this exact exercise, whatever. So we have -3 minus 4 minus 2h is equal to 0. This is equal to 2h. -7 is equal to 2h. H is equal to -7/2. And that's lecture 16 completed.
Whoop whoop! Amazing.
Woo! Okay, we actually genuinely are like getting quite fast, especially with like we only have a few more things
Honestly,
to go.
I've done all the things after this. After then it gets easier.
Yeah. Wait, fuck. Oh god. How do I undo my split?
I think.
Numpad 8.
Yeah. Check if numlock is on.
I'm doing that, but like, wait. Oh wait, I think it doesn't recognize numpad 8 because of mouse keys. So numpad 8 for me when numlock is not on is arrow up. Whatever. Domain
That's what
array.
you get.
Hmm?
That's what you get for playing RuneScape.
Dude, I will punch you now.
Let's
Okay.
skip 3 as well.
Find the maximum domain of domain d of f in R squared. Well, given is this function, the only place where the domain where this doesn't work is when this thing is equal to 0. So when we have the domain is when y is not equal to 2 minus x, because in that case the bottom will be 0. Find the range R of f. Well, what can be the output? If these two are like infinity, then we will have 1 over infinity, which is 0. And if these are like what is the range of 1 over x?
It's the second one, isn't it?
Hmm?
The one negative infinity to 0. Yeah.
Yeah, it is.
Yeah. Because like if we go, I'm pulling out the paint on that, by the way. You guys can't stop me. My fucking keyboard can though. Jesus Christ. But if we have it like this, then the function would be like and there's only an asymptote at x is equal to 0. But all the other function values can be achieved. Nice. Okay, find the maximum domain of this function. Well, the function. Oh, okay, of f. No, wait. So the domain can be anything, But that's because they are not implying whether or not the output can be real numbers as well. We know that the input have to be 2 real numbers because that's what they say here. But if we put like, oh wait, never mind. Ah, smart motherfucker. They use square, so you can never get below something. Okay, cool. So the domain of r squared. Well, I think for anything we fill in.
Yeah, but because it's always going to be squared.
Yeah. So and
So
even if we
put
filled in,
negative.
even if like the squares weren't there, then you can still fill something in. It's just not going to give an answer in the real number plane, but you can get like an imaginary answer. But we don't know that yet.
Yeah, but they want real.
Well, they don't. Give me a sec. What?
Okay, what?
So negative x squared minus y squared. They only want real answers. That sucks. So that means.
Well, isn't it just 4 minus x squared minus y squared must be greater than or equal to 0?
Yeah.
But then it will be the
X squared plus y squared has to be less than 4.
Yeah, correct. I didn't do the rewriting. Find a range. Well, that's all the possible answers we can get. So the maximum value is 2, and the minimum value is 0. Because like, if these two are both 0, then we get like 2, and if this is like both 2, then we'll get 0, and there's like nothing further than that. Even though there is in the imaginary plane. That's the thing. Like they say in r squared, but that means the input are both real numbers, but they don't say anything about the output, right? Question stupid.
This is actually a very good question.
This one? Well, we know the
no, output r squared. What is the output? Can it be imaginary?
Yeah. Like they say that the input has to be r squared, but the output can be imaginary. But like the maximal domain, I assume doesn't. Wait, let's see. Maximal domain definition. The set of all real numbers which the number is defined at. Okay.
Plus, it asks for the maximal domain in r squared.
Yeah, but r squared is the input. Because you have x and y is r times r.
Yeah, but if oh yeah. L in r squared.
Yeah, you can get imaginary output with real input.
But like they say maximum domain, and that's like the maximum domain on the real numbers. That's like per definition, apparently. Okay, so the domain of ln is anything above 0, right?
Yes.
Yeah. Yeah, that makes sense. Okay. So anything above 0. So 4 minus x squared minus 4y squared is bigger than 0. You have to use greater than. Can you do ln of 0? Does that work? No, that's minus infinity. So it's greater than
infinity.
0.
It's undefined, I believe. Or no, it's minus.
Well, it's not.
I don't know, 0. I think it's infinity.
It's negative infinity.
Oh.
Because let me draw you the ln function. The ln function looks like that.
Okay.
However, it's like asymptotic. So the ln of 0 is nothing, but the ln of x, x goes to 0 from the right, is equal to negative infinity.
Okay.
How do you do greater than in LaTeX? Like
GAQ / GAQ.
Yeah, but I don't want it to be equal to. I just want it to be greater than.
Just like the actual character.
Yeah, you've got it on a keyboard.
We are allowed to do that? Holy shit. Dude. We live in a luxury, guys. Wow. Yeah. I mean, I already used that today. How did I not know that? So then we say, we add these two things to the right side. So this becomes plus, this becomes a plus. They want us to divide both sides by 4, so this becomes this. This becomes the fraction of x squared over 4. And this becomes 1. And that is equal to this thing. Man, I'm good. Next one. Find the maximal domain of D and F. Well, it's just F, D and F. X plus Y is greater than or equal to 0. Woo! Ooh, okay, never mind, wait. Well, okay, this is also easy because they just can't be -1 or negative anything. And this one is just let me draw this one out, or write this one out. So we have x squared plus y squared minus 16 is greater than 0. Therefore, we have this thing is greater than 16. Greater than or equal to, because what? Oh, it's division by.
0.
Oh, what a motherfucker. Oh my god. Okay. Find the maximal domain. Okay. Well, that's just r times y is bigger than 0, and z is bigger than or equal to, and
that can be
part of
anything.
all the real number. Yeah, because it's squared.
Yes.
Yeah. Okay, cool. And the range is all negative numbers, including 0, because there's a minus sign in front of here. Find the maximal domain of D and F. Well, that's just y is not equal to x minus 2. 2 minus x. I fucking clicked the wrong one. My god. And the answer here is just the domain of 1 minus x. We already had this question, man. I got a question wrong that we already had. And domain, well, these two things have to be greater than 4.
We had this exact one.
We have all had this one.
Yeah, we already did this one. Which one was it again?
The second.
The middle one.
Thank you.
And I want to say right, but I'm not 100% sure.
No, it's not the right one. This is between 0 and
Left
2.
one, yeah.
Dude, we gotta, and now we cannot split because we already split for this one. Yeah, so now we're doing lecture 17. First are the partial derivatives. Let's go.
Whoop whoop.
Okay, now things are starting to get interesting. This is like more interesting than the rest, or than like the previous stuff. So we want to.
Honestly, I really find it not interesting, but okay. I really find partial derivatives not interesting, but it's just indefinite integrals, but less difficult.
I find them enjoyable.
It's fair.
Jurielle, how long does your computer take to upload a video of 3 hours?
Long, like tomorrow morning type shit.
More than 3 hours.
Yeah, I mean YouTube is pretty fast with uploading, and like, not to flex on you guys, but I'm gonna flex on you guys.
Okay.
It's usually a lot more, but I'm like streaming my screen and stuff and recording everything.
I feel like you're flexing on us.
Yeah, I don't feel like you're flexing, because, you know, it's fucking shit for the Netherlands.
The real question is that Wi-Fi or cable?
Cable, obviously.
Then
it could be Wi-Fi.
Dude, I have like 5.8 on this side.
My Wi-Fi is like 150 and my cable is 600.
Yeah, my cable is 600 as well, but now I'm like streaming my screen and like my parents are also home.
300 to 500 on our cable.
Now I have 300 kbps.
Fucking rip.
Okay, let's do this. So we determine the derivative of this thing with respect to x. Well, then we first have to derive with respect to x. So basically, 2y squared is a constant here. So that means we just and the y cubed here is a constant as well. I copied it again. What the fuck? So that means we do sine becomes cosine. So we have cosine, and then we multiply by what is in front of the x. So we have 2y squared, y cubed, that's 2y to the 5th, cosine of x, 2y squared. I think. But this seems really annoying to fill in, because then we fill in x is equal to, oh wait, no, never mind. Fraction of pi over 2, and then times 2, so then the fraction goes away again, and then we have 1 squared, which is just 1, and then this is just 2 times 1 to the power fucking 5. So we have 2 times the cosine of pi, and the cosine of pi is equal to 1. So this is just literally 2. Fuck.
Minus.
It's -1.
Minus 2, thank you. I thought about the absolute value of the cosine, and I was like, wait, that doesn't make sense.
Can we take 1 minute to go over the slides to get in this subject? 1 minute.
What did you say?
Can we do 1 minute to go over the slides?
Oh yeah, shit, I didn't do that yet. Good call. So we'll do, this is partial derivative of linearization. Then we'll have the lecture slides. Okay. So partial derivatives are just derive, like, if you have a derivative like this, like f of x or df dx of a function, that's just derive everything with respect to x and ignore everything that is a y because that is a constant with respect to x. It's like saying derive, take the derivative of with respect of x of 3y. That's just going to be 0 because it's a constant. You also have higher order partial derivatives, which is which you can write like this, and it's like f of x is equal to f of x is equal to the derivative with respect to x of the derivative with respect to x of f. And you also have like xy and yx. But we later proved that the derivative of x with respect to x and y is same as with respect to y and x. And that's over here with Clairaut theorem.
Beautiful name.
Yeah, I know, right? And then we can also create tangent planes. That's just like linearization, but instead of doing it only in the x direction, you do it in the y direction as well, and you can do it in the higher dimensions as well. And oh, jolly!
Gosh,
beautiful.
Gosh, golly!
Really?
It's a lot of fun, guys.
Yes, let's go.
Yeah. Anyways, so yeah, I'm just gonna, let's see, anything else here? No. What's the muddiest point? I don't know, we don't do that shit here. Okay, I can practically like close the formula sheet. Yeah, we don't need any of that anymore. Okay. Anyways, next one. So determine the value of this thing with respect to y. Well, this now it's interesting because this is something with respect to y times something with respect to y. So we have to use the Shanlu. The Shanlu. So we take the the derivative of the first part times the second part. So that is 3y squared times the second part, and then we take the derivative of the second part, and that's going to be x times cosine of, wait, that's not true. The derivative of x to y squared is equal to 4xy. Yeah, so I'll do 4xy cubed sine, or cosine, because the derivative of the sine is cosine. So then we get, this. Then we fill in x is equal to pi over 2. And well, because there's 2 here, we can get rid of that as well. Y is still equal to 1. So then we still get the cosine of pi, which is equal to -1. Then we will, yeah, this become -1. Then y cubed will become 1. Then y squared will become 1. Then we can multiply these two together is -12. X is pi over 2, so this becomes 6. X becomes pi. 2y squared becomes this. Pi over 2 becomes times x becomes, or times 2 becomes pi, and the sine of pi is equal to 0. Is it? Wait.
It is.
Wait, so then the whole thing is fucking 0. What a scam! Okay, no. I made a mistake somewhere. Good.
Maybe -2. -2. I got -2.
Okay, I want to find out where I made a mistake though.
So, can you place the on another place? Now I can't see the function anymore.
Oh, minus 2p. Okay. Minus 2p.
So y is the left side not 0. X becomes wait, we have 3y squared. Well, that becomes 1 because y is, or that becomes 3 because y is 1.
Cosinus of p is minus 1, right?
Yeah, the cosine of pi is minus 1, but the sine of pi, yeah, that's just 0.
0.
But then it should be 0 times something. Am I seriously messing up the chain rule?
Isn't this the product rule as well?
I can tell what I got for.
Okay. What do you want to compute?
What are we doing?
The derivative with respect of y of y cubed sine 2xy squared.
Yeah.
That is 3y squared sine 2xy squared plus 3y or y to the third, and then
cosine, and then times 4xy.
4x.
4xy cosine 2xy squared.
Yeah.
Wait, the sine of 2. Oh wait, is it?
No,
yeah, it's like this. Yeah,
I am
like
multiplying here. Do we have to do?
Plus.
You have to.
That explains it. Okay, because I was like, wait, if we multiply by x, it's like, okay, cool. So then this is just 0, and then it's just only the right side then. So I'm gonna calculate this again because I'm pretty sure I made a mistake there somewhere. So x becomes pi over 2, so this becomes 2, this becomes y is equal to 3. Cosine y squared is this becomes cosine of pi is equal to -1, so then we get -2 pi. I do a bunch of calculations and they're all wrong, but this one is right.
Yeah.
Okay, this one seems like a lot more fun. Am I right, guys? So
yeah.
Fraction of x to the power 8, y to the power 9, z over x squared plus y squared. Well, that with respect to x. Well, then we have not mint on enough. Bless you.
Please.
So then for the bottom we will have this thing squared, and for the top we will have the bottom times the derivative of the top. So then we'll have x squared plus y squared by the quotient rule, by the way, times 8x to the power 7. I'll put an 8 in front of here.
Real homies never opened the book.
Imagine opening your book. Minus, then we take the derivative of that, so that is 2x times this original thing. Because the and remember here, like the plus y squared, that's like a constant, so that falls away. So the derivative of it with respect to y is with respect to x is equal to this, I think. I made a mistake. No, I didn't. Okay.
It looks good.
Yeah, it looks good. Okay, then we start filling everything in. So x is 1, y is 1, z is 2. So z is 2. Oh. Z is 2. Y is 1. X is 1. X is 1. Y is 1. Y is 1. X is 1. 2 squared is 4. Y is 1. X is 1. X is 1. 2 times 2 is 4. This thing is times 2. This becomes 2. This is all multiplied by each other. This is 4. 4 times 8 is 32. 32 minus 4 is 28. 28 divided by 4 is 7? 7. 7! Hey! I had it correct. Holy shit, nice. I do so many calculations that I'm like almost adamant one of them is always wrong. But it wasn't. Wait, I'm gonna see if I can do something real quick.
I am the hugest brain motherfucker.
Okay. So this is derivative when you take it in respect to x. Instead we're gonna take it with respect to y. Then we change this to an 8, this to a 7. This becomes 2y, and the rest stays the same. God, here we go again. So this is equal to 4. This is a 2. This is a 1. This is a 1. This is a 1. So this is minus 4. This is equal to 2. This is a 1. This is a 1. This is a 2. So 9 times 2. So 9 times 4. 9 times 4 minus 4. That's 8 times 4. That's 38. Divided by 4 is 8. Bop! Dude, I should be a human calculator for like a Minecraft speedrun or something. Oh, wait.
Exactly that.
And then we get the derivative with respect to x. So with respect to z, that's going to be a lot more interesting. Because the derivative of the bottom with respect to z is like nothing. That's like make everything a lot easier. So the bottom of this thing is still
But everything is constant.
It's 1/2, right?
Everything is a constant, and you can do that times c. So it will only be x to the power 8. Y
Yeah, it's only going to be c.
Yeah, that's true.
You can treat literally.
Yeah, indeed. Like
constant.
You're right. So that's a good one. So what they're saying is like this is just a constant. Then we do times c dot z. So this is actually what there is. And because this is just a constant, when you do constant times z and you derive that, then you just get rid of the times z. And they can just fill it in. So this is going to be 4, no, 2. And this is going to be 1. So that's just 1/2. Good call, guys. Next.
Good.
Oh, another one. This one looks easier though. So we have the fraction of xy squared over x squared plus 3y squared. Okay, derivative with respect to x is just numerator afgeleide teller. So first of all, we square the bottom. And second
Do you
of all,
also use not minton in your head?
Hmm?
Do you also use not minton in your head?
Absolutely.
Not minton veel enkelaar.
Who doesn't? Enkelaat is my shit.
I'm sitting here going Soskastoa.
Soskastoa.
Do you also remember that beautiful picture in your math book about not minton, that's grandma?
Yeah, I was looking at his back where it says ton and there.
Exactly.
And he just says min hè, which doesn't mean anything.
That is so beautiful.
And it just says min hè, but it doesn't mean anything. It's not a logical thing to say in that situation. You go, ah, fuck, my code's ruined, fucking piece of shit. You don't go min hè.
But the real question is, did you guys get that in just the very first year of Dutch high school? Did you also get that just song about multiplications and like minus times minus is plus and plus times minus is minus?
No.
No. That probably
No,
doesn't
was
work
that
in
just
English,
me?
so I didn't have it.
No, it was just a Dutch thing, and my math teacher was like, "I like this song, so I'm making you all watch it."
We do have Customon screaming, als de teller nul is en de noemer nul is, heb je een perforatie. Perforatie. Like that. Shit slapped though, gotta be honest.
Let's go back to the lecture.
It really works. I always remember what a perforation is now, thanks to him.
Then we have 4 times 3, that's 7, minus 8, that's minus 1. Is it really gonna be? I highly doubt it, but maybe. Motherfucker.
Oh.
That's the thing of calculus. You can't just go, well, that's not a round number anymore, so I'm sure it's wrong. Dude, those were the good times, man. Okay. So we have number times derivative of the teller minus 2xy squared times the derivative of that thing, that's like 6y or something. Okay, compile. Also, I'm sorry for like not clicking compile often, so you guys have to read off my left side of my screen. But yeah, so I think this is correct. Therefore, I can just fill in y is equal to 1 everywhere. It's so nice because I can just remove everywhere where it says y if it's a multiplication. and x is equal to 2, so that's like 4, 2, that becomes 12, becomes 2, this becomes 4, and this becomes 4 as well, this becomes 7, therefore this becomes 7 times 4, what the fuck is that, like 28 or some shit? Dude, it's like 16, and then we get 16 over 49. Is there a negative sign somewhere? I don't think so. Hey, dude, we gaming.
Amazing! Woo!
Woo!
What's the answer?
It was negative 16 over 49.
Hey.
I think. Yeah, it was. Okay, next question. Ooh, I think it's Shan Lu again. Okay, so we have 3x minus 2. Dude, this is like the first question in like a while where we just don't have a fraction yet. To the power 9. So this is the original statement. We derive it in terms of x. Well, then we do 9 times this thing to the power 8 times the derivative of the inside. And with respect to x, the derivative is 3. So that becomes 36 times whatever this is. Oh, okay, cool. We don't even have to fill something in. It stonks. Fuck.
It's 9 times 3, so that's 27.
Dude, holy shit, I'm busted. Motherfucker really did a wrong answer on 9 times 3. What do you mean?
It be like that some of the time.
Some of the time it do be like that. And the worst thing is, it's on video! You guys can like bully me with this forever. Because you guys will totally remember this. Dude, what the fuck? The equation of the state of a van der Waals gat in general is...
What the fuck? Did we also pick a chemistry minor?
Dude,
yeah, that's
or like
what I
physics?
thought when I saw this question.
Yeah, like, obviously
Like,
it will just be logical, but like, fuck off.
And also during CO?
Yeah. Then we... yeah, that's like, that. Just use
my God.
How far
I
are we
completely forgot what goes. Like, my fucking monkey ass brain just looked at the fucking unit circle. Was like, where is pi? Oh yes, at the top.
Yes!
Yes!
Fucking
Of
monkey!
course. The unit circle filling 4 pi.
Oh god, with v a function of t, check at point A. Calculate the derivative of v with respect to the t. Wait.
I already don't like this exercise.
Me neither.
Same, I've skipped it every single time it came up. It's
But
just too much reading.
we can do this, guys. We can do this. So it's p.
I have had this one so much that I kind of like know how to do it now.
Let's see if we can do it, because we can't just be like, hey, I'm gonna skip this one if we get it on a test. So let's have a look. This is the original equation, yeah? So v is a function of t. The derivative of v with respect to t. Ooh.
Well, first do implicit differentiation and...
Yeah, but the thing is, like... Huh, what? This is not like... This doesn't have anything to do with the fucking thing, man. What do you mean? Okay,
We
wait.
can treat it as a constant. P will be a constant, and then you will only have V and T.
Wait, can we write this so it's v is equal to something? That would be like, that would make it a lot better. I'm just gonna see how far I can come. So then we get v times p minus p plus 2 over v minus 2 over v squared equals 80. Wow, that does not look fun. Oh no. The thing is, it's they usually the thing is they give us they usually give us a function like f of x and just derive that. But now we have a function not just in terms of like v is equal to blah blah blah.
What you have to do is every time you differentiate v, you have to Also multiply it by dv dt or something.
Yeah, that's what.
Yeah, that's like that's how implicit differentiation works. But I'm like,
Yeah.
I'm not sure if we're just allowed to do that.
You have to do that in this
Of course,
question.
you have to do it and then just like work it out.
Yeah, work it out, and then the answer
Okay,
an A.
so like this gets rid of that. Then VP becomes.
By the way, I recommend skipping the question 2 here. Just saying.
Negative P will become. Will it get rid of it at all? Okay, wait, real quick, right? I'm just gonna multiply everything by V squared. Because a lot of nasty stuff is gonna go away. Okay. So I'm just gonna group everything by V. So we have VP plus 2 minus P minus 2 is equal to 8t V squared.
Well done. You answered 5 out of 13 correct.
You wanna
Good
cry.
enough.
Okay, so when we derive this, well, we derive it with a function of t. So wait, this is actually okay. So this is like something we now have to do this with. So we take this thing and take away the t, and then we take this thing, add the t, and divide. Multiply this 16 v, and then times the derivative of v. Right? It's so hard when it's not x and y, and it shouldn't be, but it is. Negative 2 falls away, negative p falls away, and p plus 2 times v becomes the derivative of v times p plus 2. I think this is correct. Okay, so that means that...
Hail of Blades.
Takaruna. How did you do the first step of the implicit differentiation when they were still in the brackets?
For which one?
Just the first step from differentiation.
From
did
here
you
to here?
expand the brackets, or did you do it inside of the brackets?
You mean from like this step to this step?
Yeah.
So what I did is I got rid of everything inside of the brackets. Like I multiplied it out.
Yeah.
And then I multiplied everything by v squared, so I didn't have any fractions.
Oh yeah. So there's not any differentiation over there.
Yeah, this step is just no differentiation
Okay.
yet, and then I start
Yes.
differentiating.
Yes. Okay.
So then every v becomes. So yeah, I think this is correct. Pretty sure it is. Then I get this thing to the other side. Then, well, this becomes minus. Then this is also v squared. So this becomes that, and then we can change this into a fraction of v squared is equal to the fraction of this thing over this thing. Recompile. Yeah, so then we get this thing to the other side, group it by the v prime, and then we get v, or like the derivative of v is equal to this thing. This seems correct. Let's see if it is. Fuck! Now the question is, where did we go wrong? I'm gonna add the intermediate step between this one again.
Don't you just have to fill in the values of the point?
Well, here they say check that the point satisfies the equation. Oh wait, you're right, because here it says of a.
Yeah.
Fuck, you're right. Good call. 3 divided by 16 is equals to 3. V is equals to 2. I am gonna, before I do that, make a copy of this so that I don't fuck it up. So this becomes 3, v becomes 2, that's 6, p is 1, 1 plus 2 is 3, minus 6 equals to negative 3, v squared is equal to 4, 4 times 8 is 32, it's, oh fuck, negative 32 over 3. I made a typo. What? What do you mean?
Okay, what did they say?
They said it was 8, which is like 33 over 4, so I probably made a mistake in this one. So let's see, t is
what are steps?
3 over 16, so this becomes... I'm gonna try this again. I surely hope I'm not that stupid, but I think I am. So it's 3 times v, v is equals to 2, so this becomes 6, p is equals to 1, so this becomes... So I fucked up my, this looks... You know what, guys? Ik vind het goed zo.
Yeah, that's what, like I said.
You should give an answer. The answer is 5. Damn it!
You can just skip it. Like, just use the
I
skip
can't
button.
click on the skip question.
It's not that one. It's
The other
below.
skip.
Oh. Oh,
That's
Paul,
why
can
you
I click
couldn't
that?
skip.
Okay, thank you.
Although you might, and you didn't look at the answer, so now you might get the same one later on, and then you have to skip it again, and then
Yeah.
you might get it again. Because I've
Correct.
gotten it 4 times once.
Correct.
And then you skip it on the exam.
Yeah. But like
if that question is on the exam, I'm skipping.
I'm dead skipping, yeah. I hate
there are
this.
more questions.
Okay, so wait, we derived this with respect to y. I'm sure on the exam I'll be able to do it. It'll be easy. With respect to y. Okay, so then we get 15 y squared. And this becomes y squared as well, and this becomes 9. I wish all questions were like this, man. Like the last question, you know? Would have been a lot more fun like this. Wait, what? Wait, you kidding? Guys, we could have done a neat little simplification.
What? This is extremely easy.
Yeah. I wish all of them were like this.
Exactly. Well, this is actually worth 1 point, like you see, and the question you just did was 0.5 point.
I love how they randomize these things. Yeah, no, they randomize these things, so they are not like used to the fact that these two are equal. But in my case, they were.
I really hope that also happens on the actual exam. That would be
It
fun.
might. It genuinely might. We already did this one. What do you mean?
The fact that they use randomized numbers for the exams is just such a bad thing.
I mean, it is understandable, but...
Because it just makes the questions sometimes easier for some people.
Yeah.
Because they're just better numbers.
So we have y to the power 4.
It's not exactly the same question, because this is y to the power 4.
Y squared.
And we did y to the power 3.
Yeah, we had different numbers, but this question.
Yeah, true.
So let's see, derivative with respect to x. Well, then it's just cosine of this thing, and then also take the derivative of that. It's 2y squared, that becomes y to the 6th. Cool, and then we fill shit in. X is equal to blah blah, y is equal to that. So then we get pi, cosine of pi is -1, we already did that. So then we get negative, and then we get -2. Ooh. My train of thoughts goes so fast, it's probably not possible for you guys to follow. But at the same time, it's like...
How can I train my brain to think so fast? Teach me.
A lot of I'm gonna be honest, just be born gifted, lol.
Just be born gifted.
Watch Ben Shapiro.
Ooh. I'm gonna have to ask you to lead now.
Hard work beats talent when talent doesn't work hard. Ooh.
Sell the houses to who, Ben? Fucking Aquaman?
fucking love that game.
Yeah. Real men of culture will understand. So that's gonna be 4y cubed plus y to the power 4 cosine 2xy squared times 4yx. So filling that in, y vanishes, y squared vanishes, y power 4 vanishes. This entire thing fucking vanishes because it's pi over 2. Or because it's pi. Then we get cosine of 2x, cosine of pi is negative 1, then we get negative 4, then we get negative 4 times pi over 2, then we get negative 2 pi. Every time I do some really quick maths, I'm like sure I made a mistake somewhere. Okay.
How many points do we still have to do? For this?
I think this is like the 2 more. Oh no, this is the last one actually.
What? Yes.
Poggers, boys. Okay, so this is the original equation. And we have to take the derivative with respect to x. So that means we just take this is 6, that is the 7 to the front, and take the derivative of the inside, which is just 5. Then we do 5, that's like 40, 30. Do please, Papago brain, please, 35. And we fill that in. Nice. Okay, then I press here. 3 hours 30 minutes, and we're on lecture 18 already.
Amazing.
And we still have like a relatively good amount of people. Like at the last time when we finished, I was with like 4 people. Then again, there's also a few people with their mics muted and deafened, but that's alright. Okay, Graspel. Now we can go to lecture 18.
No, there's a second
Motherfucker.
part.
I can't undo my split either. Dude, why is there like 2 again? What do you mean? Linearizations and tangents in multivariable blah blah blah.
Blah blah.
Determine the equation of the tangent plane in x, y, and z being f of 1, 1. Okay, I can do that. So first of all, f1, 1 is equal to 4 over 8. That is like 1 over 2. Okay, that's a nice thing to know. So let's see the function for a tangent plane. So a tangent plane is like a linearization, but then for
2 dimensions. Yeah.
Yeah.
2 dimensions.
So we have L. Yeah, okay. L of xy is equal to that is f of a plus fx of a times x minus a plus f y of a y minus a. So I'm just like I'm also gonna do this on my test. I'm just gonna write down the equation. And like yeah, that's most likely gonna help me honestly. Okay, so we know f of a is equal to 1. We know we're gonna try f real quick. Fx of a or of x comma y is equal to. Oh god, I just realized it's a fractional function, so we're gonna have to do not metal over n kwadraat. Then we have 4xy over 5x squared plus 3y cubed. This thing with respect to x is equal to so the bottom gets squared and the top is not minton, so that is the bottom times the derivative of the top, which is 4x plus 4xy times the derivative of the bottom. Well, this thing falls away and this thing becomes 10x. I added like 20 brackets too many. I can simplify this to 40x squared y. That's honestly all I'm going to simplify for now, because we just need to fill in a point. So I can say f of
I
1,
think your
1.
timer lecture because it's still the same lecture.
Hmm?
I think
Yeah,
your
he
timer
split and he can't unsplit.
Yeah, I can't unsplit. I've done this twice now in a row.
That.
So this is 8. This is all equal to 32. This is equal to 32 plus 40. That's like 72. This is equal to 5 plus 3. 5 plus 3 squared. That's like 62 over 72 over 64. We can divide both sides by 8. That gives us 9 over 8. That gives us 1/8. And I should keep it in the fractal form like this. Okay. F of y of this thing is equal to the original thing here on the bottom squared times the derivative of the thing on the top. Yeah, so then I can get rid of this thing. Then derivative of this thing times 4x. Wait, that's not correct. It's 4xy times the derivative of this thing. Yeah, that seems more like it. So we derive with respect to y, so this thing falls away. This becomes y squared, this becomes 9. Compile! Just so you guys can see what I've done. So this seems to be correct. I'm just gonna add 1 in here. I promise once we're done with this subject, it will get interesting again. Don't leave.
I told you this was a shit subject.
Shouldn't you have a minus instead of a plus in the numerator?
That's a really good call. That's why I need you guys. That's 32. I also did it in the top, didn't I? Yeah, I did.
Yeah.
Honestly, we kind of just need to work together on the actual exam. Do you think they would notice?
I mean, like, the thing is, we all get different questions, so anytime you give up to somebody else on your own questions, it's kind of like wasted for yourself.
Yeah, that would only work for people who are done early, so they can help others.
Yeah.
I've made the same mistake 17 times in a row.
Yeah, me too. High five.
Or let's just send them a message and be like, yo, can we get extra time to check each other's work?
Oh, that's a good one.
Oh, I like
that would be amazing.
I like that. I like this guy. Okay, so this 9 over 8 is actually bullshit, so I'm gonna copy this thing again. Okay, fill that in again. So this becomes 64, well, you know that by now. This becomes 40. This becomes 4 times 3 times. So this becomes 32. This becomes negative 8. This becomes negative 1 over 8. So we have negative 1 over 8 and negative 1 over 16. Poggers. Okay. So fx of a is equal to negative. Oh, I made a mistake here. 1 over 8. Wait. So this thing is positive 1 over 16 instead of negative. I'm pretty sure. I see we need to calculate it again, man.
Why?
Hmm?
Because I also got a minus.
Okay, then it's minus because like I put down a 1 instead of a minus then. Let's see. Negative 1 over 16. Yep, you're right. Thank you. On an actual exam, I would just go through the trouble of calculating all that shit again, and I didn't want to do that to you guys now. Okay, and then we have y minus a, and in this case that will be y minus a underscore y. And a underscore y is 1. And this is also 1. So this is going to be the plane. 1 plus 1 over 8, x minus 1 minus 1 over 16, y minus 1.
Wait, why is it 1?
Hmm?
Why is it 1 plus?
That's a good point. That's 1/2. I'm sure it'll be better on my actual exam. DM trademark. Spoiler, it's not gonna be.
Yeah, that's what I also thought last time, and then I got a fucking 3.
Yeah, I got a 6.3. I feel ya.
Like I need a 7.2 now.
Damn it!
It's -1 divided by 8.
Okay, so I just made a mistake copying. Oh, fucking hell, thank you. I'm really bad with my minus sign, I think you've noticed. Okay, let's try this again. So from the top, make it drop, that is some mathematics. F of A.
I was like, shit, I wouldn't know this on a test, and then I realized formula sheet, yes!
Nice. Okay, so we have f of A is equal to 4 times, yeah, this is 4. Big brain time, yo. F with respect to x for this thing. This is so much better, holy shit. X comma y is equal to xy e to the, no? Y squared e to the power xy. And with 0, 4, that's equal to 16. That's it, that's the number. It's so much fun when there's no fractions involved.
Everything is much more fun when there's no fraction involved.
Oh, I'm getting a message. Oh, it's from somebody else. Can we talk whenever you are free? I have 2 questions about like pre-calculus. I'm like, no, I'm teaching calculus to 30 other students.
Join us if you want to learn calculus. Or be forever silent.
So damn, good luck. Okay, so it is e to the power xy plus y x e to the power xy. But it doesn't matter anyway, because this is going to be filled in, this is going to become 0, so this will become 1, and this is going to become 0, like completely. Okay, so then we have, I can just copy this thing.
Jesus.
F of A is equal to 4, fx of A is equal to 16, fy of A is equal to 1, and that is the answer.
Check it again. Like, are the A's supposed to be there?
Damn it! X minus 0.
In this case, do you still have to put x minus 0 in there? Or can you just put
No,
x?
you can just do it like this.
Okay.
You can even get rid of the bracket. Get rid of that yee ass bracket.
Yeah, I think you're pushing it.
Shut up. No, I did the fucking. Oh my god! Stop. Oh.
Oh. Place?
Monka. You know, you're
Right now I understand
you,
this,
but
but
it's
I'll
kinda
probably
funny.
forget one part of this by next week, and I'll be fucked again.
Yeah. Well, luckily we still have 5 times to do this all over.
Well, that's 5?
Yeah, I'm at 0 to 5 because I made a mistake.
Oh, in that case, like restart, because you're probably gonna have to do it more than 5 times, I think. Or does that not matter for this?
I don't know.
Like it might give you more than 5 to compensate for all the ones you got wrong, but I'm not sure about that one.
Yeah, I mean, I think it's good.
I mean, the biggest mistake you make is being sloppy. Like
yeah, that's like
not replacing the ace. So doing it multiple times is just gonna make you more frustrated.
It is. Okay, so let's see. What do we have? Oh, it's fractions, dude. Poggers. Holy shit, poggers. So we have f of a is equal to let's see, 2,3. So that is 8. 8 divided by 1 plus y squared. 8 divided by 10. 4 divided by 5. It's okay, f with respect to x of xy is equal to... Oh wow, that's actually relatively cool.
I'm chasing you. I'm at lecture 10 now.
4x over 1 plus y squared. Now for the people with a keen eye, you will have seen I have not used the quotient rule. That's because this is just x squared times the constant 2 over 1 plus y squared. So you don't have to do any magic voodoo bullshit. They can fill in 2,3, or let's just say fx of a. 2, that's 8, and then 3, that's like 10. That's exactly the same. What do you mean? Oh yeah, okay, that makes sense. So it's also 4 over 5. And then we have f y of x comma y is equal to 2x squared times fraction of 1 over 1 plus y squared but how am I gonna... Is there an easy way? Let's actually try.
Can you compile your stuff?
Hmm?
Then I can.
Oh yeah, sure.
Easily.
Sorry. The bottom thing is not correct yet, by the way. I'm still figuring that one out.
I think it should be minus 8xy over 1 plus y squared.
Which one?
Minus the bottom one, because normally you would do not min 10, but not a 0, so it would only be min 10.
Yeah, that's fair. I was just gonna do the whole not min 10 thing. Let me actually see if it will work.
Well, not a 0, so you only have min 10.
Yeah, but still over n kwadraat. So min 10, so that's negative the teller, so that is 1 times derivative of the numerator, so that's 2 times y. Well, actually, I can take that one out of the, or actually, I can get this one in here. So that is, this becomes 4. So this is gonna be the answer then, huh?
I have minus 8xy.
Minus 8xy.
Yeah, because the derivative of the number is just 2y, and of the teller it is minus 4x. And
why would it be minus 4x?
No, this seems right.
Yeah, because we start out with 2x and then we multiply that by 4y, or 2x squared times 4y.
Min 10 is minus 4x.
No.
No.
Let me have a look at this again. I'm pretty sure mine is correct, but we'll have a look. So we know that we can take the 2x squared out here, so this is just 1. So then we have negative the derivative of the bottom. So that's negative 2y. And negative 2y times 2x squared is negative 4x yx squared.
Oh yeah, you're right. Yeah.
Cool. And then we fill in a 2,3. Then we have x is 2. That means x squared is 4. 3 here. 4 times 3 times 4. That's 16 times 3. That's 48. Y squared, y is 3, y squared is 9, this is 10, this becomes squared, that's 100. That means we have 48, negative 48 over 100. So then we have L, I'm going to try to do this one correctly in one go. L of x comma y is equal to fraction of 4 over 5 plus fx of a, that's another times fraction 4 over 5 times x minus 2 minus fraction of 48 over 100 times y minus 3.
On the exam, do they care if you simplify it or not?
Graspel with a calculator, so no.
Yeah, I know Graspel doesn't, but the exam program is not Graspel, right?
Yeah, it is.
It is
Oh, right,
Graspel.
wait, it is. Yeah, you're right. So it doesn't care.
Let's go! 1 out of 5.
Hey, whoa!
Woo! You must submit. Shut the fuck up.
Yeah, they didn't change the question for this one, probably.
No,
Like,
I don't think
there's
I
another
will.
one. There is one in sequences about absolute convergence. No, in this one about absolute maximum or stuff, and we skipped that one. But the correct answer is absolute maximum. Like they didn't. Most of the questions are fine. Some aren't.
I see.
Just ignore the ones that aren't.
I see. I think it still should be doable though. This one.
Oh yeah, just didn't upload it.
Yeah, I'm not gonna upload it. I'm not gonna fucking upload this shit in the middle of a fucking.
I mean, you're kind of uploading it, but not to them.
Okay, but not the Brightspace.
Just submit a 6-hour YouTube video.
Just submit like a 10 terabyte video to Brightspace. See how they react.
Yeah, without a timestamp, and just be like, yeah, check this, please.
Check this. I don't think their server would handle like. Oh my god! Imagine all of us uploading a 10 terabyte video. That'd be sick.
Just do that during the exam, then they have to cancel it. Easy.
Dude, get cancelled. 4. Okay, so wait. F x comma y equals 4x squared plus 5.
Well, actually, during the exam, they are watching 3-hour videos of us.
Hmm?
During the exam, they are watching videos of us, live videos.
I don't think so. I
Yeah,
think it's a
they're not
program
like-
that determines if you're acting like it could be a fraudulent case, and in that case, you are reviewed.
Yeah, like they
why
do
not
not
let
have
it-
500 people watching us. They basically only like if there is something that happens that's like weird, like something shiny shows up in your fraud check or in your like.
It's really shiny.
Yeah, I don't know, like text or something is recognized by like Tesseract OCR or whatever the fuck they use. I don't know, but yeah, 9 times 4 is 36. So basically you should be fine if you don't mess stuff up.
It's
like the
also
rule of
why
thumb.
you don't have to cover everything as long as you don't do anything that they see as fraud.
Well,
And
yeah,
if
but
they
you might be reviewed, and it's like then you'll get an email like, "Hey, you've been reviewed," and then you'll spend like three hours worrying if you're gonna be fine or not.
And then you tell them to suck your dick.
Dude, I wish.
I wish op die chance.
I wish op die chance, poggers. 5-1. 151. Why are we working with these numbers? At the same time, I'd rather work with 151 than 48 over 100.
Can you compile your stuff more often?
Yeah.
If you could compare stuff more often, Jure.
Yeah, sure. I'm like really forgetful in that, so sorry, but like it's good of you guys to remind me. X comma y, x is 3, so that is 24, that's 29. Is there a hotkey for this? Control Enter. Dude, boggers, man.
I don't see how you get 151 out of FA, because my calculator gives me 201.
Same.
Okay, then let's do another one.
Also,
Guys, I've been doing
calculator,
ca-
hello? Fraud?
Fraud? Hello? Fraud?
Hello?
I'm gonna be honest. I've been
And they
doing...
joined the call.
Oh, I see why. I thought 5 times 5 squared is 75, but it's 125.
It'd be like that somewhat.
Okay. Anyway, so y xy is equal to 10y plus 5. Fy a is equal to 55. This one is a lot easier than the other one, I'm gonna be honest. 201 plus 29 x minus 3 plus 55 y minus 5.
Beautiful, looks good.
Bobs. Let's go.
Let's go.
It's 2 out of 5, guys. Let's go. Why did I say we would do this? F of x equals x. Oh, this one is easy. X e to the power xy. Dude, Pog, I wish all of these would be like this.
Didn't we already have one like this?
Probably. F of a is equal to.
Oh,
What is
they
it?
changed it
4
up.
2. So this is 8. X is equal to 4. So it's like literally 4 e to the 8. Then we divide. Then we take the derivative in the ith way. Then we get x squared e to the power xy. F a derivative with respect to I of a is equal to like, I don't know, fucking 16, like this. And then we can take the derivative with respect to x, and then it gets fun, because then we have e to the power xy plus x times y times e to the power xy. Oh shit, should be like this. And then we fill in, then we get 8, and then we get 8 e to the power of 8. Recompile, and then we will see that it's a little bit of a clusterfuck. So then we get z is equal to 4e to the power 8 plus, let's see, so that is plus e to the power 8 plus 8e to the power 8 times x minus 4 plus 16 e to the power 8 times y minus 2.
Compile.
And now I'm actually curious. I'll compile. Yeah, now I'm actually curious. Since this is such a neat little equation, can I take e to the power 8 out of the brackets?
Sure, but you can make it e to the 9 e to the power 8 before the x. 9 e to the power 8 before the x.
Yeah. So then we would have this, which looks a lot neater.
Exactly. Beautiful.
Oh, dude, that's so much better. Holy shit, man. Oh, Paul,
yes.
you didn't even accept it. Dude, that's a W in my book. Okay, so that is currently 3 out of 5. 2 more, guys. We're almost there. We literally had this, except for at a different point. And this was a 5, and this was a 5. Still. Bugger gamer moment. What the fuck? I don't want to... x comma y is equal to 4x squared plus 4x plus 4y squared plus 5y. F of a is equal to 4 times 25, that's 100, plus 4 times 5, that's 20, plus 4 times 4 squared, that's 16 times 4, 64, plus 5 times 4, that's 20 again. And that is equal to 204. Quick maths! Get a mental block. Smoke trees. At least you'll be certain that you're like able to do this now after this. Because we have to do this like 20 fucking times and it's really fucking annoying. Then we get f of a is equal to 8 times. That's 44. Big shock. You can hear my mental health deteriorating the longer we go on.
Yes.
But hey, that's the grind we chose, man.
Maybe
It's the
we
life
should
of a
then take
Minecraft speedrunner.
Maybe we should take a 5-minute break after this subject.
Yep, we will. 32, that's 37. That means... And now without looking at this line is whack. We don't use this line anymore. We now know this shit by heart. We have the linearization of x comma y is equal to 204 plus 44 times x minus 5 plus 37 times y minus 4. If after this we have to do a single like normal linearization again, it's gonna be easy. Dude, I'm a god. Quick reminder that in the last time we did this, we were done like 20 minutes from now. I don't think that's gonna be the case anymore.
I mean, there were also fewer lectures.
That's true. That's true. We have done
Like,
like
we're
from 11
10?
to 18, and we only have like what? After this one, we have 1, 2, 3, 4 lectures left. Oh, easy. Okay. Determine the linearization of this thing.
Are our voices also being recorded, by the way?
Yes.
Yep.
Oh, beautiful.
Yeah, because otherwise, like, you'd hear me talking to myself, and that's like really creepy.
Well, hello, all the people on YouTube. My name is Gert-Jan. Nice to see you.
Hey, Gert-Jan, you're from my calculus class. Groep 3.
Yes, I am. Exactly.
Yeah, I see you around in the chat. You're like really helpful. Good guy. Go follow this guy.
Groep 3 gang.
Groep 3 gang.
Good.
You are currently the only user in this conference.
No.
Okay, no, please do not give me
Yeah,
those feelings.
yeah, I know. For the people who aren't in group 3, we have had a lot of issues with this shit. Okay, so if we fill in A, we get...
Wait, you guys still go to lectures?
Yeah, like for calculus we do.
I found out recently that you can also speed those videos up, so I started watching them back at like 2 to 4x speed. But joining them 9 AM is just too early and it's too
How
slow.
can you do 4x speed?
With
really slow teacher.
I mean,
yeah,
if
some
they're
of
just...
these teachers speak at like half speed, so
Yes, like 2 is normal
Yeah,
for
but
lectures,
still,
and
like-
that's sometimes 3. But if you're just like the part where you have to work out some equation, right? And then you're done, like why bother watching it at 2x speed if you can also just 4x?
Oh yeah, makes sense.
So with respect to x is equal... Wait, Yella, I'm gonna do something fucking cool.
Oh. Alright, I'm ready. Let's go.
Let's go! Okay, you see this one, right?
If you recompile, I'll
yeah,
see it.
I'm recompiling. You see, right? I'll recompile again. And we can say, without loss of generality, either that or like bisymmetry. But this thing is the same.
Is that the case?
I wouldn't say without loss of generality. I'll say bisymmetry.
I still don't think that's the case.
Why not?
Oh,
It is.
you mean the the differentiate with respect to y? Yes. Okay, that's true. I thought you were just saying okay, fxy equals minus 6x so fxy is minus 6y. No.
No.
Nice spaceman.
Yeah, no, like if you're writing inside of the math stuff, it thinks these are all math symbols, but at the same time, if I don't do that, then it's not going to show up in the middle of my page. So if I get rid of these spaces, it will do this. And now our bisymmetry is over here.
That's even worse.
Yeah, so I prefer
Put a
to do it
slash in between or something, maybe?
Yeah, escaping the space might do it.
Hey, let's go. Okay, therefore, fx of a is equal to -6 over this is like 5. This is 5 squared, 25. And then we have this thing with respect to a. Then we get ayo. 25. And therefore we have linearization of x comma y is equal to the fraction of 3 over 10 times or plus the fraction of -6 over 25 times x minus 1 plus the fraction of -12 over 25 of y minus 2. I almost wrote down dx, man. That shows how far I'm gone. What do you mean? What do you mean that's correct? Incorrect. Did I fuck this shit up? Oh! Oh! 5. Update. 1 squared plus 2 squared is not equal to 10. Now we have to do another one because I did it wrong. No! 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 Fuck my life. Because I thought 3 instead of 2. No! Okay, y sine x plus y. The faster we've got this done, the faster we can take a little like 10-minute break or something.
Hey.
F of a is equal to y times sine of xy. That's like -9, right? Oh wait, x plus. Okay, that is a lot better. And sine 0 is equal to 0. Okay, I can live with that. And then we have f with respect to x of x comma y is equal to y cosine of x plus y times the derivative of x plus y, which is literally just equal to 1. I hate to break it to you guys. And this thing, yeah, this thing when we fill in a, that's like -3 times the cosine of 0, and the cosine of 0 is 1. Woo, and then we get this thing with respect to y. I could go for a drink. Equals to 1 times the cosine of this thing plus y times... No? Y times the cosine of this thing plus the sine of x plus y. It doesn't matter, that shit's fucking 0. Why am I even... Okay. So then this becomes -3, that becomes sine x plus y equals to 0. I put 2 x's there. And then we have the linearization of x comma y is equal to -3 times x minus 3 plus 3 times y plus 3. I think that's correct. If it's wrong, I'm gonna cry. What do you
Big
mean?
rip.
Okay, guys, I'm gonna cry. I'm literally gonna cry. I hate it.
So that's another.
Wait.
Honestly.
Okay, no.
Is that another 2 then after this?
No, it's
You
1.
gotta just skip this, honestly.
Okay, what was different from what I had and what that was? I had -3, x minus 3.
Minus.
Fucking.
Why is this a mine? Oh,
Because the integral thing is a negative thing.
Yeah, y is -3, not 3. Fuck me. It's still 4 out of 5, okay. Oh, okay. Here, this is great because now I can do shit with symmetry. So we have the. Oh, dude, and x and y are the same thing. Dude, this is easy.
Yeah.
We can say square root of square root of x comma y, x y. Then we can fill that shit in, and that's like literally 2. Okay, then we can take the square root of. Okay, I'm kind of struggling how to do this one, but we'll see. X, so that's fraction 1 over 2 times the square root of the original thing times the differentiate of what's in there, so that's going to be y. And then fx of a is equal to 2 over 2 times the square root of 4, which is 2, that's 4, that's 1 over 2. And then we can say fy of a is exactly the same thing. And then we can say Lx comma y is equal to 2 plus fraction 1 over 2 of x minus 2 plus fraction 1 over 2 of y minus 2.
Looks good, Chief.
So, if this is
no, wait. You should do. I believe it's Lx comma y equals because they said determine the linearization. I'm just saying, like they can fuck you up on that. What
5
can
out
I
of
say?
9.
But
We in these.
Just saying, I'm on your heels. Like I started at the same time as you, and I'm at lecture 14 now.
Yeah, like, shut the fuck up. Page up. Wait, no, page up. Okay, 411. We can take a little break until like 15:45. Stretch your legs, drink some water, stay hydrated, people.
Good idea.
Are you sure a 10-minute break is enough though? Like, shouldn't we have a longer break and just continue in like an hour or something?
If we're continuing an hour, we're gonna do web.
No, we're taking a 10-minute break, guys. We only have like what, 1, 2.
Yeah, 10 minutes. Okay.
We have like 4 more subjects, dude. This should be easy. We've already done like what, 8? Like 7?
Are we gonna do complex numbers or skip that one for now?
We're gonna do complex numbers, but like only the parts that we know. Otherwise, I'm just gonna skip it. But like, I
So we're
already
never
know
gonna
everything else
complete
they're
it.
gonna tell us. I think.
Yeah, complex numbers aren't that difficult.
I mean,
Yeah.
I've never had it, so I don't know.
Yeah, okay, we've had it in high school before. But yeah, enjoy your break, everybody. See you back in 8 minutes.
Alright, see you.
Yo. My fucking throat, man.
Fuck. Bonjour. Buongiorno.
Just thinking about it, I'm kind of afraid of the integral over area part.
Nah, it'll be fine. I've done them. It's really just it's partial derivatives, but then in partial integration practically.
Yeah, okay, but like with a rectangle it's easy, but with
the other one it's also easy.
Yeah.
Do we know anything about the project yet?
Hmm?
Because I saw some people say that you're in a group with 5 people in total, but I thought it was like 7 or 8. Did they change it?
None of the information is confirmed yet.
Okay. So
People
it's
are
just
usually talking
guessing.
about stuff from next year. Or last year.
Okay.
I'm so glad that with the power series thing where you have to give 5 decimals, you only have to have 2 answers correct. Like actually.
Yeah, that's kind of nice. Imagine them saying making the project was too hard, or you're doing it alone now.
I mean, it would be kinda nice, because then you could just like treat it like an OOP exam. Just sit down, work on it for 8 hours, and hand it in.
Fair enough.
Well, I don't think you're gonna finish
Yeah,
the
okay,
OOP
not 8
project in
hours.
8 hours, but like, yeah, I get what you mean.
Like
I
now,
mean,
a big part
honestly,
is gonna
we
be
would
in...
still call together, but like, we wouldn't work on it together.
Yeah. The thing about the OOP project is I have a list of people I would really like to be in a group with. It sounds like a lot of fun.
It's random.
Yeah, but at the
Yeah,
same
and it's gonna be random, and I'm not looking forward to
Exactly.
that.
Like, Kalle, if we are in a group together, we can.
That's gonna be amazing.
We are destined to do great things, my friend. There's also some people I would rather not be in a group with.
I did the
Yes.
project last year. What do you want to know?
No, I know most of it. Or at
It's
least
pretty
like.
fucked.
Hmm?
It's pretty fucked. Random.
Yeah, like
RNG.
Yeah,
like,
random
the,
doesn't sound
the
fun.
group get randomly selected is pretty annoying.
Your grade is random.
How long has the break been going for?
Like what? -1 minute.
-1
Oh,
minute
okay.
of break, yes.
Yeah, you gotta
Well,
do
you
-1
said you
minute.
did the project last year. How many people did you have in your group?
Please, I can't learn one anymore.
5. And how big
Wait,
is the
hold on.
project?
It's pretty big. Like you can't do it in one night.
No, but I mean, I heard that the course is pretty much a free 10. Or a free
No,
pass,
it was.
and 1 year it was a free 10.
Yeah, because it was really easy. Now they added like a bunch of rules, and you need testing, and you need no.
Lucky. But is it still 20 per pass, or not
No,
really
no,
anymore?
it's a completely different course.
Fuck.
You need to try. And then, like, if some people don't do their work, they end up
You're
screwing up.
fucked.
You're fucked because you need to do their part, and you need to spend time on OPP, which you reserved for other courses. And if you don't, you're fucked.
Yeah. What do you do? Like, I understand that you're with a TA, and they like watch what you're doing and what your group is doing, and if somebody is not participating enough, they will like call them out on it. However,
Yeah.
like, what if the person just doesn't change? Is
They
it
kick 'em
possible
out.
for?
Yeah, they fail.
I see. So they fail, but you don't.
Yeah.
But you will have to do their stuff.
If
because
you
know
did
they're
your
not-
part, even if the whole product is pretty fucked, you can still pass. I think.
I see. That's
Like,
cool. I was afraid of like if somebody figured out that they want to drop the course after the 1st of February, and they just like stop putting effort in. Because like the courses for WDR or WDT were like created before, or the group, not the courses. The group for WDT were created before the deadline. Hell, the deadline's still not over yet. But I've talked to like multiple people who are dropping out, and their group mates like. I've talked to one guy who is like, yeah, I don't do the course anymore, so I dropped my group mate. Now he has to do it alone, which is like a big no-no. It's like being a dick. And like SJN, that one guy or one person, he's like, they're like, yeah, I just still do it with my group mate because they don't want to like let their group mate like just leave them to die.
Yeah, that would be really annoying.
Yeah,
So
like
I had 6 people, not 5, and 3 of them failed. One guy just didn't do jack shit, so he got kicked out.
And
The other 2 didn't do enough, so they failed.
I see. Well,
And our final grade was a 6, so I sent them a big email, bumped it up to an 8.
nice. Just send an email, lol.
And
Yeah.
I mean, I am really genuinely curious, like, how many people drop out after the first. Like, did you get a statistic on that last year? Like, hey, you're still with so many people?
About half.
Well, no, about half.
I don't know how many drop out, but I think 50% get BSA in first year.
Yeah. Like,
But-
because you can, like, not drop out now and still get, and not get your BSA.
You're probably gonna get an extension though. We all
Yeah,
got an
yeah.
extension.
We're gonna hear that, like, within a week or, like, hopefully within
Yeah.
a week and like,
Hopefully
probably
within the
before
test week.
Pretty
Hopefully
much
they also
everyone
drop
but
BSA
Ben.
because extension is it's a curse.
Pretty much everyone but Ben got an extension, right?
I think like they first made
lot of people
made
are
a
an
thing about
extension.
like, hey, HBO and MBO are getting like dropping their BSAs. MBO didn't have it. It didn't even have a BSA. And then universities that like recently they said, okay, you're gonna do this, but they're still deciding on it. They're still talking about it. And it's most likely going to be the case of like, how many credits can we miss because all our courses are like 5 credits or 0. So either it's going to be like a BFA requirement of 50 or sorry. Let's see, it's like what, 60? That's 40 points. So they can fuck up 4 subjects. Hopefully, no, not necessarily hopefully, but like maybe they're going to do it so that you have like you can miss 25 because they said it would go between 10 and 15% of
Yeah,
like
so they're
the
gonna
main
drop it
thing.
by 5 or 10
However,
points. They're gonna drop it by 5 or 10 points, hopefully.
hopefully they're gonna do that, but at the same time, like yeah.
Imagine them dropping it by 4 points.
Yeah, that's what I'm thinking. I'm thinking, and it's just gonna be like, yeah, you know, we're dropping it. We're dropping it to 41. Get fucked.
Yeah, like.
Well, I would do 42. Come on. They would do 42.
No. Because it's 45 points for BSA, right? So drop by 10, which is 4.5. So you have 40.5. But you know, you can have half a study point. So we're gonna make it 41.
Oh wait, so
you can just take some bullshit theology course from another.
Guys, are you ready to do some calculus?
Oh
Yes.
yeah, we can do calculus.
Yeah.
I guess we could do calculus.
Yeah, we could. We don't want to, but.
do we want it? No. Okay, so we have to start with course 19. What is that? Minimum and maximum. Woo! I mean, this is mostly just like recognizing stuff, right? Not really calculating stuff. Well, calculating the point at which it is.
Did we just skip directional derivatives? Do we have to do directional derivatives first?
Oh wait, did I not do that one? Wait, back to lessons. Oh, okay.
Nope. Even one lecture more.
Damn it. Wait, then I split again incorrectly.
Oh.
Fuck. Dude, holy shit, I'm dumb. I'm Papega. I'm 5.
All the bad words. You're all of them.
I'm all of them.
Every
We're
single
gonna go
one.
until lecture 25 out of 22.
Out of 23, by the way. Okay, so the directional derivative is
the gradient.
Oh, it's this thing. It's like the gradient times the vector.
It is not extremely difficult.
Yeah, this is like relatively easy actually, in my opinion.
Understandable.
Like my way of doing it is I always just calculate this thing.
Yeah, exactly.
Is there a way to do gradient triangle in LaTeX? Gradient triangle LaTeX.
Backpack gradient.
I used Nobla.
Werkt ook. Ja, gewoon Nabla.
Yeah, we're begin equation, dude. That shit's gay. We don't do equations. Okay. So looking at the thing, I'm gonna put up here if we have the gradient. The directional derivative of x comma y is equal to the nabla of f x comma y c dot the u. Looks fucking fancy, holy shit. Well actually it's the nabla or the directional derivative of in u. So the writing would be like this. Right? Yeah. At least it would be like this for two-dimensional two-dimensional vectors. Because we can also have like three-dimensional stuff, but we'll get there. Blah 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 blah.
You're not recording, by the way.
Yeah, I am.
Are you?
Yeah.
Okay.
I'm using XSplit. I'm not timing.
Yeah, why's your timer stopped?
Yeah, I still thought we were in a break, but I messed
cheating.
up. I'm cheating on my own speedrun. I made the category. What do you
You're
mean?
a cheated.
Oh,
we
dude,
should ban him.
I'm Dream. Ben Dream. Okay, so
yes, for any mod seeing this, ban Dream.
Yeah, if a mod sees this, ban Dream. Okay, given a differentiable function, blah blah blah. Okay, let u be a unit vector and theta be the angle between u and the directional derivative of p. Cool. du f of p is the directional derivative of f at point p in direction u. Determine theta such that du f of p equals 4. Whew.
Sounds really enthusiastic, but not.
Yeah. Theta be the angle between a unit vector and the
Well, you can just do that gradient times that vector u equals 5/4 square root of 14. And
yeah, that's true. So let's see. We'll do nobla fxy c dot u is equal to the fraction of 5/4 times the square root of 14. Nobla. Okay, this is correct. Determine, let's see, so. Oh, wait. Because this is the cross product. Oh, I see what we have to do. Oh, dude, that's 400 IQ, like legit. So because this is the cross product, we know that nobla f, x, y, c dot u is equal to mid u mid times mid nobla f, x, y mid times cosine of theta. And this is just a general rule about the things, about what's it called?
Yeah, exactly.
Yeah, about cross products or like vector in general. Oh, that's smart. Okay, and because it is between you and that thing, so this theta will be the angle between you and that thing. So we know that the left side is equal to this thing because that's given. We know the length of u is equal to 1 because it's a unit vector. So we just need the length of the gradient of f. Of nobla f. How do we determine the length of the gradient of nobla f? Oh wait, we literally have the nobla, the gradient. So we have the nobla is
You
equal
just
to
find the
2,
magnitude of the complex number.
3.
You just find the magnitude of the complex number.
The I is not a complex number. The I is
So 2i minus 3j plus 1k.
Yeah, but so in general, like if you're not working with complex numbers, this is I.
Yeah.
This is J. I'm just putting this there for whoever doesn't know yet, and this is K. And then it goes on to like however many you need. So it's not a complex number. It's just the X, Y, and Z parts of the thing, to say it like that. And therefore we can say that the absolute value of nobla fxy, or let's actually say fp because it's not xy, it's xyz, whatever. So the absolute value is equal to the square root of the x component, which is 2 squared. Then we have plus -3 squared plus 1 squared. Do you guys understand where that comes from? So the line I wrote is this. I assume that's a yes.
Yep.
1 squared is 1.
Just the length of the.
Yeah.
Vector.
Exactly. And then this is 4.
Oh, I'm bad.
Correct. What do you do?
I thought that the Taylor series was in terms of ln x, but it's in terms of ln 1 plus x.
Yep.
So my entire calculation could be done a bit easier.
F. Oh wow. Okay. That really really simplifies it a lot, because then we can divide by square root of 14 on both sides. So then we have the cosine of theta is equal to 5 over 4. That means okay. So realistically, the answer is not applicable because there within the real numbers, I'm not sure if it's also within the natural numbers, but there is no number so that such that a cosine is larger than 1.
There is an imaginary number.
Yeah, there are imaginary numbers, but within the real world, yeah.
Moral of the
Wait,
story.
can you scroll up a small bit?
Just type any and save time.
Yeah, I've got the exact same question,
LeMayo. Determine theta such that DUF. Huh?
Just the same.
Oh yeah, it's the
but
same
now-
one. Okay.
Yeah, 1 over 2 square root of 42.
But in that case, like, yeah. So this is instead of 4 or 5 square root of 14, it's just 1, 2 square root of. Oh, dude, look, it's 42. That's like the funny number. And then here we divide this thing by square root of 14. Now the question is, would this be Okay, wait,
Yeah,
really?
Pi over 6.
What did you say?
This should be 3, square root of 3 over 2. Yeah.
Oh, yeah. That makes sense, because 42 over 14 is equal to 3. But that is square root of 3 over 2. And what was that you said?
I think it's pi over 6.
Yeah, that could be. I don't know the unit circle by heart. Dude, we're gaming. Such that
just another number now. Again, the same as we just did.
Yeah.
Another number.
So then we have negative blah blah blah. Oh yeah, but then what's the? I wrote 24. I meant 28.
It's probably 3/4 pi.
Yeah, this is like
yeah, it's 3/4 pi.
Square root of 2 over 2. And for cosine we can get rid of this minus sign. So what's the square root of 2 over 2?
Square root of 2 over 2.
Wait,
Wait, positive square root of 2 over 2?
Yeah, because cosine of negative x is equal to the cosine of x. I mean, if you want to do negative, that's good too.
This is not cosine negative x equals cosine x. This is cosine theta.
Pi over 4.
Yeah, okay. I see what you mean, Yellow. You're right. My bad. It's not pi over 4.
It's 3/4 pi. Yeah. Because you can't just say, if it's negative, it has to be 3/4.
Okay, cool. The more you know. Determine the direction u in which the directional derivative is maximum. Let's see.
Is maximum for the in the direction of the gradient. That's what TA told me. The directional derivative is maximal in the direction of the gradient. That's what a TA told me.
Yeah, in the direction of the gradient.
Yeah, that's the or that's the place of steep descent. So.
Yeah, okay, that makes sense. So then we just need to find out the direction of the gradient.
Yeah.
Okay, so we have d underscore u of f of b is equal to. Well, let's. I guess for this one we first calculate nabla f of x, y, z. We do that by calculating the directional derivative for every. Oh yeah, Nobloff.
Nobloff.
And this is equal to, well, first we take the derivative with respect to x, that's y squared z cubed, comma, then we take the derivative with respect to y, so that's 2xy z cubed, and then we take the derivative with respect to z, and that's 3xy squared z squared. And then in the case of u being being in the same direction as this thing, well, we can just fill in the numbers then. So we can say nabla f of p is equal to, and then it's 1, 1 minus 1. So this is just 1, this is negative 1, this is negative 2, and this is... Wait, is that correct?
3.
This is not correct. This should be z squared.
+3.
Yeah, it's positive 3 then. So this should be the direction. Then we should be able to put in a negative 1, negative 2, positive 3. Check my answer.
It's a direction
You should
u.
divide by
That
the
is,
length, right?
yeah, I was about to say that's not a direction.
Yeah, okay, that makes sense. That makes sense. So then, if we want to have the direction, we can take nabla. So that is fraction of nabla p over mid nabla f of p slash mid, and that's equal to this thing divided by the length of the thing. So that is the square root of 1 plus 4 plus 9. Compile. Yep. Okay, then we can, oh. That's like, okay. This is square root of 14. So therefore this vector has all of its sides divided by 14. Divided by square root of 14.
I really admire your LaTeX handwriting skills.
Thank you. I have worked hard on them. So let's see, you can get rid of this fraction thing. Recompile.
Yeah, sounds good.
Okay.
Try to insert that.
Hmm?
Try to insert that.
Let's go! Dude, that's such a fucking ugly answer, but let's go. Give the corresponding maximal value of the directional derivative def max. Dude, we were working with subscript, topscript, fucking everything. Wait, didn't they already ask this? Oh, minimal. Okay, never mind. Well, that should be that, but whatever. We'll get there when we get there. Corresponding maximum value. Well, this is the direction u. So this is just the u. Oh yeah, but that makes sense because it's a unit vector. So if this is equal to u, we already have nabla. We already have nabla p even. So therefore, all we would have to do is multiply u by nabla p.
Yes.
Is this thing multiplied by this thing, which realistically it's not that hard. Actually, I shouldn't be using a dot. I should be using a cross product dot. Not a cross product.
C dot.
Yeah, but like this thing. But like realistically, that's like really fucking easy because that's just where is it? What do you mean? Where the fuck do I? Why is there no way to? Oh wait, never mind. I'm stupid because it's a number, not a. Okay, so we multiply -1 by -1 square root of 14. So that's actually I can do it like this instead of okay. So then we just get 1 over square root of 14. Then we get 4 over square root of 14. And then we get 9 over square root of 14. Because we're just multiplying the numbers by itself. Compile this so you guys can see what I'm doing. And it's just 14 divided by square root of 14. Oh. Woo!
Yeah.
Okay, determine the direction in which it is minimal.
The opposite
For them
direction.
to be minimal, that means that u times nobla. Oh fuck, I'm not working inside of things. That's when they are perpendicular to each other. So u times
Wrong.
nobla is equal to 0.
Wrong. I did this. It's wrong.
Isn't it just with minus?
It's negative. Just throw a negative in front of
Yeah,
everything.
yeah.
I think it's very easy, yes.
Okay, cool.
And the directional derivative, so just like take your previous answer, throw a negative in front of it, you're done.
Yeah.
No.
No, that's the wrong one. What do you mean?
Yeah, you gotta put that one's there, yeah.
You guys told me to put a negative in front of it. You're all stupid.
I told you to put a negative in front of your fucking vector.
No. You said that. Oh my god, you ruined it.
Oh my god, it's all ruined. No, it's dead. Oh my god,
no.
it's dead. It's
How
never
can
gonna.
you do that to those orphans? 1 over square root of 14. Then this is 2 over square root of 14. And then we have negative.
What if you gave your whole answer as just the whole thing divided by square root of 14? Like, would it accept it?
I'm not sure.
If you did vector 1, 2, minus 3.
Beautiful.
No,
Right.
it's a direction, so it has to be normalized.
Yeah.
Yeah.
Okay. Cool. Next one. Given a point and a function, determine the directional derivative in a p in the direction this thing. Well, the thing is, you absolute fool. That's not a that's a direction, but it's not a unit vector. So it's 3, 4, but it should actually be u is equal to 3 divided by square root of 25. So that's 3/5. And then 4/5. By the way, the reason I did that so fast in my head is because, you know, the length of this thing is the square root of 3. Fucking hell, man. I forgot the frac. The
It's
length
just
of...
because you're so smart.
Yeah. Like, the length of this vector is equal to square root of 25 is equal to 5. So you divide by the square root of 25 to get this thing. And then we can calculate nobla. xy is equal to... first we take the derivative in respect to x, so that's 3x squared y minus... Oh, 3x squared y. And then x cubed minus 9y squared. And then, because we want the du of x comma y is equal to nub of f x comma y, that's this thing, dot product the unit vector we figured out, and the unit vector we found, that's just this thing. And because it's a dot product, we can just add the two together. So we will get this times this plus this times this, and that will turn out to be this.
Fuck. Was the determinant, was that a square or xxyy minus xy squared, or was it xy squared minus xxyy?
What?
I'm doing, I'm sorry that I'm yelling questions through the thing, but I'm doing directional, no, not directional derivatives, stationary points, local maximum and minimum and saddle points.
Yeah.
And the determinant, which tells you if it's a saddle point, a minimum or a maximum, well, if it's a saddle point or the other two, was the f in, or the derivative of f in respect to x twice, times f in respect to y twice, minus f in respect to x and then y squared.
Yeah.
Yeah.
But it was either that or the other way around.
No, it's that way.
No, yeah.
That way. Thank you, kind citizen.
I mean, the other way around. Do you mean like the?
No, I thought it was either
XY, the other
yeah.
before
xy squared minus xxyy.
Okay.
Yeah, but
No,
it
that-
isn't. Okay, great.
Okay, this is just Yellow casually flexing that he's like gotten past us.
What? No, this is before you. You skipped over it.
Did we?
I believe so.
No, we haven't done this yet.
No.
Really?
That's the next one.
Yeah, that's
Oh.
the next one. Dude, you're fucking flexing.
Oh, but I skipped over like 5 lectures because I've done them before and I know I could. Don't worry, I'm not actually here
okay.
yet. I'm just wondering.
Would
just
this
doing
be
it
the
for
right
myself.
answer though? Like the
Don't
direct...
you plug in the points? The
We
point.
don't
Yes.
have. Oh. Yeah.
You do need
that's
to plug
P.
in the points.
That's P. I didn't even see that. So we have d of P, or d of u at point P is equal to 2, 1. So that's this thing. That is 3 times 4. That's 12. Let me close this. Fraction 3/5. That's 36. Then this is 2 to the power 3. Dude, there's so many people joining. Hello, welcome. I'm sorry.
Or is one person that just keeps rejoining?
That could be. Don't fucking ruin
my happiness.
My happiness. Okay, so that means that the d of u at P is equal to 32/5. Fuck. I forgot a backslash. Dude, fuck. By the way, what's standing there is not correct anymore. Holy shit, it's correct. Whoa.
Whoa.
I've done so much math that I didn't expect it to be correct, like no cap. Determine the equation of the tangent line L to the contour line f of x through point P in the form ax plus by is c. Okay. Okay, the tangent line L to the contour line of...
Yeah, there is one small trick. Once you see the trick, it's easy.
I have no idea what a contour line is.
A contour line is something that is perpendicular to the gradient vector.
Oh, it's a perpendicular to the gradient vector. Okay, that helps.
Yeah. So how do you get a line perpendicular to a vector?
Cross product is 0.
Say you have vector a comma b. Yes.
Yes.
Then the perpendicular line to that is
negative
ax
b
plus
over a?
by is equal c. Then the line perpendicular to that is ax plus by equals c.
Oh yeah, I remember from high school.
Yeah, you've got this. Like, you can just fill in for a. You can fill in the top parts of the thing, like the gradient vector. For b, you can fill in the bottom part of the gradient vector, and c you have to calculate because the gradient vector doesn't have a location, so you have to plug in 2, 1 and see how it ends up.
So wait.
You picking up one, putting down?
Yes and no.
Okay.
What do you mean with the top and the bottom?
Well, the x coordinate or the x part and the y part, I guess. If I'm being really ugly
it's
here.
like this, and then we do Like this? I'm just kind of trying to go with you.
No. What is no? Literally, the gradient. The gradient is a vector. It's not a function.
So it's 32x.
Oh, like the
Yeah, 32x. Or actually, I'm not sure what your function was. Could be 32 and then minus 5, I think. 32 over 5. No, that's the directional derivative.
What?
The gradient. It is a, it's the lambda 2 f2 comma 1.
Oh, the nobla at 2,
Nobla that one. Yeah. At point P.
Oh, so we need the gradient at point P instead of the 2 gradients in general.
Yes.
Yeah, okay, that makes sense now that I say it out loud.
Yeah.
So we have nobla f of P is equal to this original nobla, but then we fill in 2 and 1.
Yeah.
So this is 8, this is 1, that's negative 1, this is 4, that's 12.
12 negative 1. Okay. So your A is 12, your B is minus 1, and your C you're going to have to calculate.
Okay. So 12x minus y is C. And then we just
and then fill in 2 and 1, which leaves you with 23.
So 12 minus 1, 23?
Yes. 12 times 2.
12 times 2. Oh, yeah, okay. 24 minus 1.
1 is 23. So it's 12 minus 1, 23. That's your vector.
Dude, holy shit. I'm like all the bad words, man.
Starting to die?
Probably. Like,
yeah, it's just a small trick which you have to know.
Okay, determine the directional derivative and the function at the point blah 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 and the direction of the vector v. Well, the direction of the vector v can go fuck itself. We're only the real homies care about u, and u is negative 1 over square root of 2 twice. And like at this point, I'm just like, when I see a vector, I'm taking the unit vector of that vector, and that's just like.
That's how we roll, baby.
Yeah. If you don't understand how I'm doing this, just ask, but it should be relatively easy. Okay, so we have the direction. Determine the directional derivative of the function at point in the direction. Okay, cool. So we have nobla fx comma y is equal to the thing with derivative with respect to x, so that's like 9x squared y cubed plus 10x y squared, comma 9x cubed y squared plus 10x squared y. Okay, then we take nobla of. Well, at this point we can already start filling in numbers. So we take nobla of p, and I'll say p is negative 1, negative 2. So x is negative 1, x is negative 1.
I swear I could deadass just fall asleep to you doing algebra.
I hope nobody here is doing that, because it's not very good for your grade if this is like your only hope. 46. And then we have. I can't imagine, now that you mention it, how that would go now. And this is like negative 8, so that is negative 8 times 9, that's negative 72, that's minus 40, that's negative 112. And the direction. Wait, so the directional derivative is this thing plus. Oh, wait. So this is just a nobla, and then we need to multiply that, or take the dot product of that times the unit vector.
Yes, exactly.
Yes, it's starting to dawn on me. C dot u is equal to, and since the u is equal to this thing, okay, I'm kind of getting it.
I see you have a minus 64, 46, but I have minus 56.
Then I will literally take your word on it right now because I'm like so tired.
Oh.
Okay, and then we have this thing, which is just first times second So that's this thing over here. Well, -1 and -1 cancels. That becomes 112 positive over square root of 2. And then the 56 cancels as well with the negative sign here. And since it's literally just both over the square root of 2, we can add them together. I need to get rid of this weird thing. So then this becomes a 6 and this becomes an 8, and then we can get rid of this thing. Recompile.
I think that will be it. Try it.
Yeah.
Let's see. And after this, I still have to do web, man. Oh, fuck yeah.
Yes. Woo!
Wow! Wow! Determine the direction.
How many points do we still need? How many points do we need for this to succeed? Oh.
I have like 5 points.
Yes.
So get all of these correct, and we're done with this one.
Yes.
Dude, I fucking hope so.
But after this one, there's still 2 left, right?
No. This is only lecture 18, so we still have 19, 20, 21, and 22, 23 to go.
Fucking hell.
22 and 23 we can't do them yet because there are also stuff for next lecture in. So I would not recommend to do complex numbers right now.
What
Just
did you
don't
say?
do it. Don't do complex numbers already because it's about stuff that we'll get tomorrow.
Yeah, okay, that's true. And complex numbers
So
really aren't
don't-
that hard, so I expect you guys to like get it. Holy shit, we're still here with like 18,
we only have
like
double
20 people.
integrals in local extrema. That's the only stuff we have to do. But maybe if we are getting too tired, we must maybe choose another moment to do that because
No. I said speedrun, we're gonna speedrun, boys.
Okay, well, come on.
Okay, so we have the direction u in which the directional derivative is maximum. So let's see, that would be if the direction is in the same direction as the nabla. That makes sense. So then we will first have to calculate the nabla. I swear to God, once we're done with this, everybody's going to be talking about the nabla, and like the university professor is going to be like, what?
Exactly.
xy is equal to, so first take a derivative in x, that's just y squared z squared, and the the derivative with respect to y, that's 2xy z squared. And then take the directional derivative with respect to that, that's 2xy squared z. Okay, the nabla at point P is equal to, fill that shit in. So that's gonna be 1. That's gonna be -2, and that's gonna be +2. Okay, and we need the direction, which is the same as this one, but then the direction has to be a unit vector. So we take this and we divide it by
3.
That makes sense, yeah.
That's divided by 3.
Yeah. 1/3, -2/3, and 2/3. I really shouldn't be running it like that. I should be.
Can you compile?
Oh yeah.
Yeah.
Zo'n zin in web, joh.
Wait, this does
That's
not
not
yet seem.
Wait. Oh, I'm using square root, not fraction.
Yeah. Exactly.
I was like,
That's
huh? That
better.
doesn't make sense. So then we have 1/3, -2/3, and 2/3.
Sounds good. You can already do the inverse of that with the third question, the minimum.
What was that again? That's just a negative sign.
Negative, yeah.
So then it's just
-1/3.
-1/3.
2/3 and minus.
Sorry if I'm like starting to get like slower than I was first.
Exactly.
I've got a solution for this.
Beautiful.
If you're gonna be really lazy, can you also just put answer the first one and then just copy paste it, put a negative in front of or does that not work?
I'm not sure if it will work, but I'm not fucking with that shit now. Because if
I
I have...
kind of. Yeah, true.
Okay. Corresponding maximum value. Well, we have the u vector now. We have nabla pay. So now we just kind of dot product that shit together. So we take this thing, dot product that thing, c dot, and well, realistically, we already know that like this is nothing more than just squaring the top part of the of these things and adding them all up together. So that's gonna be 4 here, and it's gonna be 4 here. And then realistically speaking, that will be 9 over 3. That's literally gonna be the number 3. Let's go. The monster's helping, boys.
Woo!
Okay.
Oh, guys, I want to do some projects with you. You are such good teammates.
Oh, that's nice of you. Who even are you?
Jesus Christ! Man murdered him.
No,
Who the
I
fuck
heard this guy
even
talking.
are
And
you?
I heard this guy talking, and he's nice, but I have no idea who he is.
Oh, well, maybe you'll never know.
Oh, you're Gert-Jan.
Yes, I am.
Cool. I recognize your voice. I'm like, hey, I know this guy. But that's because I was
Yeah.
talking to you like 10 minutes ago.
Oh.
Okay, cool. Give the corresponding value of the directional derivative at. Okay, well, isn't that just -3?
Yep.
Oh, I'm good, boy. Okay.
Well, but
back to
unfortunately,
lessons.
I have to go right now. So
Now I'm curious, what did we do?
yeah.
Okay, so I don't split
well,
now. And now we just go local enema, extrema, whatever.
Go get your local enema right now. Yeah.
Yeah, this is a group exercise. Everybody get your enema. Okay.
Well, goodbye, guys. Good luck.
It's been fun now. Function, blah blah blah. 3 stationary points. Well, I mean, okay, wait. Let's first go over the slides again because I have absolutely zero memory of all of this. Minimum, maximum. Yeah, we're only 5 hours in. Lol.
Lol.
Lol. This is a cry for help. How many critical points does this thing have? Cool. How do we know? Can you like give us a theorem? Okay. Critical point if fx is 0 and fy, or it doesn't exist at that point. Then we have the second derivative test. Okay, so we have this wacky thing over here, which is just derivative with respect to x, derivative with respect to y. Then we have here double derivative minus the square of the double derivatives. So it's just that one thing that starts with a d of the matrix of blah blah blah.
Determinant.
Thank you. I'm here all night. Cool. I will be.
Probably.
Okay, so I could stop using this nobla. I really shouldn't. I mean, theoretically, I can still use the nobla. It's just not we're not going to be calling it nobla anymore. Let's say fx of x comma y is equal to the derivative of this thing with respect to x. So that's just going to be -2xy plus 8x. The derivative with respect to y is equal to y.
Oh my god, I'm doing 10 billion calculations per second and they're all wrong.
No, I believe you. I'm sure at least one of them was right.
Like at most, or at least one. You pick.
This is the 5th time in the last hour that I've done. Okay, the integral of x squared is 3x to the third. Holy shit, I need sleep.
And after this, we gotta do whip. Okay, so this is correct, I think. So then we set both of these equal to 0. And let's see if that gives us anything. Recompile. Well, then we'll just put one of them as a function of the other. So we will say, I'll just set y as a function of x. So I'll take 2y is equal to negative this thing. Then we divide the whole thing by 2. This thing becomes 2. This thing becomes x squared divided by 2. This is the stuff where the professor would just say, yes, and I'll leave this stuff to do to you at homework. And I'm like, no.
I
Okay.
fucking hate those people.
Yep. Group 3, everybody. Fun stuff. So then we do put this thing in here. Oh, boogers, here's a 2, so I can distribute that. Can get rid of this fraction. And turn this into a 4. I can add an x everywhere. I can add a negative sign everywhere. I can get this thing inside of the bracket, so that's like negative 4 plus 8 is plus 4. And now, because it's all in terms of x, I can say x times negative x squared plus 4 is equal to 0. Therefore, x is equal to 0, logical or x is, this thing is equal to 0. Therefore, x is equal to 0 or x squared is equal to 4. Therefore, x is equal to 0 or x is equal to 2. Or x is equal to negative 2. Yeah, you guys were forgetting that one. I know you guys. You would forget that.
I'm not
Totally
paying
not me
attention.
projecting. Okay, so there's 3 points over here. Oh wait, they said okay, verify this yourself. Cool. Okay, and then we can get the points y for that. We already have a function for y in terms of x. So then we have y is equal to see, x is 0, y is 2. X is 0, y is, or x is 2, y is 4. X is minus 2, y is still 4. Okay, give point AB with A is equals to 0. That means that we have 0, 2. But X was... Or 1 by 2 matrix is like this. And it's 0 by 2. Motherfuckers! Oh. Okay. Determine point Q equals C, D. Well, then they're talking about this point, namely 2, 4. Let me recompile for you guys. Okay. And then we have the last point, which is negative 2, 4. Okay. And now we can do stuff like the second derivative stuff, like this one. So then we can say, okay, d is equal to, well, let's actually calculate the derivatives first. Xx is equal to negative 2y plus 8. Fyy is equal to negative 2. No, 2. It's positive 2. And fxy is equal to negative 2x. Then we have the determinant d is equal to 2 times negative 2y plus 8 minus negative 2x squared. Therefore, that's equal to negative 4y plus 16 minus 4x squared. And when d is we also have to calculate fxx. Okay. Cool. So for x equal to positive 2, then we have d is equal to negative 16 plus 16 minus 4x squared. Well, that's minus 16 is equal to negative 16. Therefore, that is a saddle point. There we go. Okay, for x is equal to 0, then we have d is equal to negative. I'm by the way reading the points off of like this, so we have a point 0, 2, 2, 4, and negative 2, 4. So d equals to negative 4y squared, so that is negative 8 plus 16 minus 4, or minus 0 because x is 0. So that's positive 8. F underscore xx of of x comma y is equal to, let's see, fxx was equal to negative 2y plus 4. Y here is equal to 2, so that's negative 2 times 2, so that's negative 4 plus 4 is equal to 0. Wait. Huh. If d is bigger than 0. Oh, wait, okay. No, wait. Give me a sec to collect my thoughts. For x is equal to 0, d is 8. Therefore, it is either a maximum or a minimum. And fxx of xy there is 0. But it only talks about strictly greater than or strictly less than.
You're fucked.
You're fucked. I probably made a mistake somewhere. For x is equal to 0, d is equal to this, or x is equal to 0, so this is going to fall away. And y is equal to, oh! No, wait, it's negative 8 plus 16. I'm so confused. How are we supposed to know that? Is there like any information? No. Huh? I have no clue. I'll just genuinely, I'm just gonna continue with this stuff. I'll fill in.
Hold on, can I have a quick? What do you want to know? Sorry, I'll have a look for you.
Well, I think my things are incorrect anyways. Oh wait, point P is equal to. Okay, P is the one we're working on now. So for the point 0, 2, our fxx is our determinant 8.
Okay, so it's either a minimum or a minimum or a maximum.
Yeah, and fxx is equal to 0.
I'll tell you soon. I'll just grab my notes and let's see. Directional derivative gradient times u gradient dabba dabba dee dabba die dabba dee. If and fab equals 0. It's here. they seem to be quite adamant about the fact that it can't be 0.
Yeah. But, then either my double derivative with respect to x is wrong, which it probably is.
Well, actually, if both of them are 0, then that means... Oh, yeah, no. Okay, I found it out. So, imagine fxx and fyy have the same polarity, yeah?
Yeah.
If they're so if one is 0, the other is 0, yeah?
Yeah.
So then that would mean that negative something squared must be positive, which is impossible.
Oh, so my math is wrong.
Yeah, because if fxx is 0, then d is less than 0.
So here I have negative 2y. That's correct for f of x. And here I have plus 8. That's also correct. What?
Call that here.
Yeah, no, I don't know. I'm just gonna say.
Isn't fxy just -2 instead of -2x?
But.
Oh no, never mind.
Yeah, no, it should be negative x. Okay. Negative 2x. Yeah. I was gonna say local maximum. Local minimum. Huh? Their determinant is negative 4y plus 16 minus 4x squared. We figured out it with 8, but here they say the double derivative is 4. Am I not filling in something right? Negative 2, oh my god. I copied something wrong. It's actually negative 4 plus 8 is equal to positive 4. Dude, I'm stupid. Okay, that's cool. 4 x equal to negative 2. Well, in the case x is equal to negative 2, we know that d is equal to negative 4. Let's see, negative 4 times 4 plus 16 minus 4 times negative 2 squared. So that's 4 times 4 is equal to negative 16 plus 16 minus 16 is equal to negative 16. Therefore, it's negative and it's a saddle point. Yeah, I say with very much...
Like they say in the Wild West, we win these.
Okay. This one only has 2 critical points. Hopefully this one goes better. So we have f with respect to x is equal to 4x minus 3x squared. F with respect to y is equal to 4x minus 4y. That's not correct. Okay, this should be 4y. Then it makes sense. 4y minus 3x squared, yeah, and this is 4x. Oh yeah, okay, and then we have 4xy, oh fxy is equal to 4. Okay, anyways, so then we need to say f x is equal to 0, f y is equal to 0. So then we have 4y minus 3x squared is equal to 0, and 4x minus 4y equal to 0. Now that last one is really nice, because that last one gives us an equation and that just says, oh, I'm scroll up a bit. 4x, then we can divide everything by 4, so we get x minus y is equal to 0, then we get x is equal to y. That's really nice. That's really nice. that means we can take the second derivative, the second thing, and we can say 4x minus 3x squared is equal to 0. Then we can filter out an x. Then we can say x times 4 minus 3x is equal to 0. Therefore, x is equal to 0, or 4 minus 3x is equal to 0. Oh. And therefore, x equals 0, or x is equal to 4 over 3. And we know x is equal to y. Therefore, the y and it's the same here. Cool. So now we have these two, then we can... Okay, so with b, the second point has to be less than or equal to 0. Well, it's just 0, 0. And the second point has to be greater than 0. So that is just 4 over 3, 4 over 3. Cool, cool. So then we can start calculating f of xx is equal to 6x. F of yy is equal to 4 or negative 4. F of xy is equal to 4. And the determinant is equal to negative 24x minus 14. Therefore, x equal to 0, then the y is also equal to 0 and the determinant is equal to negative 16. Therefore, it is a saddle point. Cool. And for the other point, we will have d is equal to negative 24 times 4 over 3. So that is, divide this by 3, then we get negative 8, and then we multiply that by 4, that's negative 32, negative 16. That's also a saddle point. What?
I think it's a local maximum.
But wait, this thing is fraction 3 over 4, 4 over 3.
Can you recompile?
Oh, yeah.
Thanks.
So when x is equal to 0, then this thing holds.
Oh yeah.
Why do you have minus 32? Why do you not have 32?
Because d is equal to this, and for x is equal to 4 over 3. Wait.
I have minus 6 times 4 divided by 3 times minus 4.
Minus 6.
Because fx is wait, 6x.
Fxx is 6x, fyy is minus 4, fxy is 4. So you get negative 24 minus 16.
No, fxx is negative 6x.
Yeah.
Fucking hell,
because
you're
fx
right.
is 4y minus 3x squared.
Yeah, you're right, you're right. Thank you. So the determinant is then just positive 24x minus 16. Cool. That makes a lot more sensical. Then this becomes 32 minus 16, then the d is positive. Then we fill it in an xx, and that becomes negative, so it's a local maximum. And I remember this because if this is low, then it's a maximum, and if it's high, then it's a minimum. So it's kind of the inverse of what you'd expect.
Yeah, that's how I remember it too. It's really weird.
Yeah, I just remember it's weird. Okay. Oh, Pog, okay.
Oh, right, this one doesn't work.
What?
The answer is one that you shouldn't, like something we have to skip.
Do you know it?
Wait, I sent it to other people. I think it was a max, an absolute max, but I'm not 100% sure. Let me look it up. Although I don't know who else.
Because we didn't do absolutes, yeah, right.
I was about to say, we don't know this, so.
An absolute maximum. Wait, it's 2x. Bracket open 2 minus x minus y. Okay, then it's an absolute maximum value of 6.
We win these!
I think we should just be able to do that.
No, because the answer is an absolute max, and we have to skip that one.
Yeah, we don't have absolute maximum yet.
Like, I knew it was a
it's
a max
vocal.
value, but they told us to skip absolute, so the fuck, I'm not gonna select that one. It's obviously bait, and it wasn't.
Yeah. Okay. So we have x with respect to f with respect to x is equal to. Let me see if I'm still recording. Yes, I am. It's gonna be a really big file. F with respect to x is equal to y squared minus 4. F with respect to y is equal to 2xy minus 4y. F with respect to xy is equal to 2y. F with respect to xx is equal to like 0. Is that correct? Yeah, because there's no x squared anywhere. And f with respect to yy, I'm gonna put some brackets around stuff real quick, is equal to 2x minus 4. Compile. So these are all the stuff. These are all the things we need. Well, then we can just say f x equal to 0. Right arrow x y squared minus 4 is equal to 0. I randomly used right arrow here. Well, I usually don't do that, so you can ignore that. Then we get y squared is equal to 4. Then we get y is equal to negative 2, lower not y is equal to 2. And then for the x, we get, well, actually, so this is just of fx. Okay, then we get fy. So we get 2xy is minus 4y is equal to 0. When we fill in y equals negative 2, let's actually build that around so it's like a function in terms of x. So then we get 2xy equals to 4y. Then we get, since y is not 0 when we're plugging it in, we know 2x is equal to 4. Therefore, x is equal to 2. So the points are 2, 2 and 2, negative 2.
Is there someone that could explain to me directional derivatives or help me in the next room? Please.
I mean, did you look on YouTube yet? Because that's what helped me to figure that really quickly.
No, yeah, but this question, like how you did you guys were doing finding the angle. I'm kind of lost there. Actually, is someone recording this?
Yep.
So if Yura uploads, yeah, okay, I'll just watch whatever Yura uploads.
Okay, cool.
Try this video.
Yeah, I watched that.
Okay.
Okay, so then we can fill these points in fxx, or d is equal to fx times fyy. Well, it's just 0 minus fxy squared, so that's 4y squared. And since y is equal to, well, for both points that just means that d is equal to negative 4 times 4 again, so that's negative 16. So for both points, that means that they're both saddle points. Man, I'm good.
Is this the last one?
I think so, yeah. And then we only
Why
have
is this
like,
one worth 0.17 points? What the fuck?
well, there's probably more points, but you can go over it. Okay. So we have this function starting off with f directional with respect to x. That's equal to negative 2xy plus 4x. F with respect to y is equal to 2y minus x squared minus 2. F with respect to xx is equal to minus 2y minus, plus 4. F with respect to yy is equal to 2. F with respect to xy is equal to negative 2x. Yep. Discriminant is equal to... I'm just doing everything I can right now, so... Negative 4y plus 8 minus 2x squared. So that is positive 4x squared. Okay, so starting off now, we can start with fy is 0, fx is 0. We get negative 2xy plus 4x is equal to 0. And therefore, if we get x out of here, we get negative 2y plus 4 is equal to 0. Then we get x equal to 0, or y, or 2y is equal to 4. Let's see, y is equal to 2. And we can fill these in the other... Wait. Oh yeah, okay. Okay, that makes sense. And then we can fill these 2 points in into the other one. That's like 2y minus x squared minus 2 is 0. Filling y equals 2 in, it gives 4 minus x squared minus 2 is 0. That gives minus x squared. Oh. Minus x squared. Well, let's say 2 minus x squared is equal to 0. Well, then we can just get the x squared to the other side. X squared equals 2. Then we can say x equals to plus or minus square root of x. Square root of 2, sorry. Or x equals the negative square root of 2.
Okay, Cabal.
Oh, yeah, sorry. Okay, so that gives us 2 points. 2 points already. So we already have square root of 2, comma 2, negative square root of 2, comma 2, and then we need to find one more point, and that's when x is equal to 0. What is this thing equal? When x is equal to 0, then we get 2y squared minus 2 is 0. Divide everything by 2. Y minus 1 is 0. Y is equal to 1. So therefore we have a last point, namely 0, 1. Recompile. Okay, so we have a is equal to 0. That's the point 0, 1. The first one is bigger than 0. That's the point square root of 2, comma 2. And r is smaller than 0. That's the point negative square root 2, comma 2. I'm happy that they're finally doing something that I'm good at. Okay, now the nature of the points. So the first point we're going to explore is 0, 1. We have d is equal to negative 4 plus 8. Negative 4 plus 8 is equal to 4. It's positive, therefore f of x xx is equal to let's see, 0, 1. So that is negative 2 plus 4 is equal to 2. Therefore that's a local minimum. refresh. Then we'll do it for point Q. Point Q is the one with square root of 2. So then we have D is equal to -8 plus 8 minus 4. Square root of 2 squared is equal to 2. So that is 8. So then we get -8. Therefore, this is a saddle point. And then we get D is equal to, let's see, the Y is also just 2. So then we get -8 plus 8 minus, and then -2 squared is still 4. So that's still equal to -8. So this is also a saddle point. Man, I'm good. Back to lessons. So we have done 19 now. 2 more lessons, guys. We're almost there.
Ooh.
I love your enthusiasm.
Sounds about right.
Okay. So, double integral over rectangles. What can calculus say about that? I love the fact that we still have like, how many people is this? 1, 2, 3, 4, 5 plus 11 more. That's like.
Well,
Okay,
I'm
that's
still on this call, but like mentally, I've almost completely checked out.
Yeah, no worries. I've been doing mathematics for 5.5 hours. I respect you guys for being here. Gert-Jan left.
Oof. He fucking.
Been here from minute 1.
Yeah, dude.
Yeah.
Colin was here as well. He was muted for a while, but I don't care. Or deafened.
Well, I'm just sitting here muted because I don't want you guys to hear my keyboard.
No, I meant deafened.
Because I have to say
Keyboard
kind of loud.
Keyboard noises make me horny.
Same.
Oh. No horny
I mean, at the
posters on my
start-
YouTube channel.
At the start, you were way
You go to
faster
horny
than me, and
jail.
now I'm quicker than
Don't
you.
be horny. If you're horny, you'll get insta-ban.
Yeah,
Bam!
exactly. What
If
did
you're
you
horny,
say?
go to the CSG NSFW server.
Does that actually exist?
Yeah, it does.
Oh no. When
You
did
should
that
just call
get
it horny
created?
jail. Just CSG horny jail.
Okay.
Also invite me.
Lectures over rectangles. Sorry, integral over rectangles. Huh?
Yes, those lectures are going to be over rectangles.
Yeah, indeed.
Then we're going back to primary school.
Okay. Well, this is just easy. Just take the integral of one thing first, and then the other. And when it's just a literal rectangle, then you can just swap them around.
There is a slight nuance to it. I recommend doing it.
Yeah. Of course, we're gonna do it. But it's just like a refresher. Evaluate the integral. God, I've missed that almost. The integral from 0 to 4 of the integral of 0 to 2 of 2x plus 1 dx dy. Compile. Oh, that looks sexy. Except for maybe I want to escape the space so it looks even more sexy, but there we go. Okay, so, well, first then we integrate this thing with respect to x. That shouldn't be too hard. That is just a half of this. So then we get x squared plus x from 0 to 2. Well, from 0 falls away, then we fill in 2. And that becomes 4 plus 2 is 6. What? Can we do that? It sounds right.
Yeah.
Okay. Then we have the integral from 0 to 4 of the number 6, which, well, then
Isn't
we
that
get
just multiplication?
Yeah, it's like literally 6y from 0 to 4, which is just 6y, 6 times 4, that's literally 24. I'm just gonna fill it in, guys. Dude, we in these.
What an absolute god, just filling it in like that.
Yeah, I know I'm a god.
Wow.
Why be a king when you can be a god? I can't wait until we get like complex integrals that we have to derive with like integration by parts in this stuff. That'll be fun, right, guys?
I mean, is that coming back?
Oh yeah, obviously. Like we have to do a bunch of shit with integral, so I expect it to come back.
Fuck's sake! Like it was so much easier.
Like I'm not sure if it will come back here, but I predict it will come back in the exam.
I fucking hope not.
Like they're gonna do integrals. We already had all the necessary education to do hard integrals, so I doubt they'll just give us easy integrals.
I mean, it would be nice. I can dream, right?
Did you just say dream? Dude, I literally have a 1 in like.
Are you gonna cheat?
I literally have a 1 in 7.5 trillion chance to pass this exam. Still gonna do it though.
Yeah.
Doing this.
Might need some mods for it, but it's gonna happen.
Yeah. Well, the mods suck. No, I'm kidding. I love you, G square, baby. So we have x squared y. That's gonna be half x squared y squared. Frac 1, 2. And the funny thing is, we can just take this thing all the way to the front. And then we just fill in 3 here and then subtract it from 1. Well, 1 times 1 is 1. 3 squared times 3 squared is 2 times 3 squared. 2 times 9 is 18, so this is literally the number 17. Am I filling in x and y's? I'm filling in x and y, aren't I? I should... Old habits die hard, okay? This is only the y, so this is like 3 here, that's 9 times this thing. This is 1 times that thing. So all in all, this equates to 8x squared. Okay, then we... Oh, and I should get rid of... Oh yeah, okay, that makes sense. And we do this. From this bound to this bound. Compile, this is not right what I'm saying now. But it's 8 over 3. And I get the 8 out here, the 3 becomes 6 out here. And then we just fill this stuff in, and that's just 4 cubed minus 2 cubed. And this is just 64. And this is just 8. 64 minus 8. That's like 56. 56 times 8. Well, I mean, I can just leave it like this. I can do the calculations, but honestly, do we wanna? And then this should be the answer. Okay, evaluate the integral of. This looks a lot less fun than the last one. Wait. You guys recognize this? You guys see what this is?
No.
Oh wait, never mind. I was thinking of x squared plus y squared. I was like, are we fucking evaluating the unit circle? I thought like maybe we already know what that is, but it's x plus y squared, not x squared plus y squared is 1. I see. Whatever. So when we evaluate this thing from with respect to x, we get that's gonna be. Actually, you know what? Why make it hard on ourselves? We can just do x squared plus 2xy plus y squared. That's a lot easier to evaluate. And then from there on it gets also easier, because then you can just say frac 1 over 3x cubed. Why is it complaining? Ugh, I hate when I mess up my brackets. And then this becomes 1 over 2x squared and this just becomes xy squared. And then we fill this in from 0 to 1. Well, that makes it easy because the 0 disappears because there's an x everywhere. And the 1 we just fill in 1 for x. So this becomes 1/3. This becomes a half y, and this becomes y squared. Then we integrate this with respect to y. Recompile. For you guys. Because I appreciate y'all, especially for saying true me, even though we've been doing calculus for 5.5 hours. Okay. So then this becomes 1/3 y, 1/4 y squared. And this is 1/3 y cubed. Fill in 0 gives nothing. Fill in 1, all the y's disappear. And it's a third plus a fourth plus a third. And this is like 4/12. This is 3/12. 4/12. And that just becomes 4 plus 4 plus 3. That's 11/12.
You said a third plus a fourth, I think. Is it a half?
At line 6 when you deconstruct the square.
Where is it?
Yeah, you said x squared plus xy, and it's 2xy.
Ah, yeah. This should be 2xy. You're right. So this, well, this fraction 1/3 should disappear. This should be a. So then this should be one a half. So then this should be 14/12, right? 4 plus 4 plus 6. Yeah, that's correct. There we go. Ah. Okay, we're 2 out of 5. Ooh, this also looks fun. We have the double integral of e to the power x plus 3y dx dy. And because this is a trick here we can use is that something to the power a plus b is something to the power a times something to the power b. So we can pull apart this, and we can see that I actually need to place brackets, and then we can see that it suddenly became a lot easier. Because doing this thing, actually it should be 0 to 3, 0 to 1. We first do it in the direction of x, and that becomes really easy because that just is e to the power 3y. Well, actually everything just stays the same. And then we just fill this in from for x everywhere. So then this becomes e to the power 3 e to the power 3y. And actually we can get this e to the power 3, that's a constant, so we can take it out of the integral. We can recompile, and you can see that this is what we end up with. And by golly, is this easy, because we can just say this is equal to 1/3 e to the xy from 0 to 1. And we can just say, if we fill in 0, that becomes... Wow, it actually doesn't disappear, that's nice. So first when we fill in 1, it becomes this. And when we fill in 0, it becomes e to the power 0 is 1. So then we get this. Does that look right? I think it does. Input. Fuck.
Isn't it e to the third minus 1?
Yeah. Like you make the e to the 0 just disappear.
Yeah, yeah.
Yeah, the e to the 0 is equal to 1, right?
Yeah, but where did you write that down?
No, the first time we integrate, when we do x.
Okay, wait, when we do x?
Yeah, yeah.
The line below?
So this one. Oh, you're right, because this doesn't disappear. Oh, yeah. Yeah, you're right. So then this becomes that -1, right?
Yeah.
Okay. So then this thing becomes this fraction minus y. And then I'm going to do this line just over because I don't want to ICBA. So this thing when y is equal to 1 minus this thing when y is equal to 0. Okay. So this should be correct. Recompile.
Wait, no.
No,
Shouldn't the
that's
one
not
be on
correct.
the outside?
Hmm? It's this thing where we fill in 1 minus this thing where we fill in 0. The -0 disappears, and this just becomes 1/3. So I think this is correct. Nobody else?
Wait.
Any idea?
Wait.
I've done that one before. I think you've missed something.
Hmm?
I've done that one before. I think you've missed something.
Oh, wait, at the top here I made a little mistake. It should be 3. I'm gonna enter it, see if
Entering
it's correct.
x, so entering x is 3 gives you.
No, look, after the third line, on the fourth one, it should be e to the third minus 1, like, as a constant, I think.
When we fill in 0 here, that becomes e to the power 0. Wait, why do we, huh? I'm gonna try it again from the third line on. Because I wasn't thinking right when I did this. So we have this thing when it's 3 minus this thing when it's 0. So when x, this is 3, this is 0, this thing disappears because it's 1, then we get this. This already looks a lot better. So then indeed we can get this thing times e minus that times minus 1. And this is a constant multiple that we can take outside. Indeed.
Yeah.
Okay, and from there on it went well. Okay. So then again. Yeah, okay. So then we do the fraction 1/3. We fill in this stuff in from like this. Okay, then we do that. So it's 1 minus 0. 1 minus 0. So that's minus a third. And this is where it's 1. Then we can compile it. 1 minus 0. And I'm just going to fill this in. And it's correct. Thank you. Okay.
Sign up by 1.
Okay. Oh. So we have the integral from 1 to 3 of the integral over pi over 3 of, is that correct? Yep.
I'm doing. I was just trying to do the one after this, and let me tell you, with this foggy of a mind, it's not gonna happen. The next lesson, like I'm telling you.
We'll see, because I am struggling with next lesson, so I do want to do it with as many people here as possible. We're just gonna have to figure it out.
I mean,
I've
maybe like just do the couple of lessons we didn't completely do so far. Like we don't have a green check mark, and the next one just do it another time.
Yeah,
Like
but
do it
the thing is,
tomorrow or something.
we don't have that much time anymore, and the calculus thing is the first thing next week.
So do it tomorrow.
A fresh mind that can help with the next thing.
Yeah, like tomorrow I have we are speedrunning from 2 o'clock onwards, and I already told them I would do that, so I don't really have time tomorrow. The day after that I have work, and I'm also doing the ADS implementation. The day after that, I guess we can do some more the day after that, but I want to try it at least now because it's not a speedrun if we don't finish. You get me?
True.
So we'll see how far we can get. And this is DXDY.
Okay. Well, like you said, we'll see how far we can get. But I'm giving up next week, or I'm giving up with the next lecture. I'll do it again later.
Okay, up to you.
For now, I'm gonna stop recording and I'm gonna fucking leave.
Damn, I'm being left by my own brother, guys. Please stay with
Yes.
me. Okay, so because it's just a rectangle, right? We can get rid of. We can turn around the integration.
Yep.
So I can say first we do the di and then we do the dx, and I also turn this thing around. Okay, recompile. Therefore, this thing is equal to and the integral of this thing. Well, 3x is just a constant, so we leave that, and the integral of cosine is sine, and there is a constant x in front of the y, so we take that to the front and divide by it. So that becomes 1 over x. 1 over x cancels away with x, and we are left with the integral of 3 sine xy. Filling this in for 3 and then minus 1, because it's top minus bottom. 3 minus 1 for y. We can get a constant of we can get a constant of 3 outside of the brackets and recompile. That looks a little easier to finish already. So then we can do the same thing we just did, and when integrating this will become the negative integrating sign becomes negative cosine, yeah. So this becomes positive cos, and this becomes negative cos. And then we divide by the constant that's next to x, so here we can say frac 1 over 3. And then we start at, let me see if this is correct now, or if I forgot a bracket, because I probably did. No, it's correct. No, it's not. Oh yeah, this minus should be here. Because now it looks like that's an addition, not a multiplication. Okay. So we have negative 1/3 cosine of x to the power 3 plus cosine of x. Filling in. So it's pi over 3 minus 0. Pi over 3 minus 0. Filling in 0 for x here. The cosine of 0 is equal to 1, yeah?
Yep.
So this is 1 over 3. Okay, and then the cosine of pi over 3. And the cosine of pi. Well, the cosine of pi itself shouldn't be too hard. That's just gonna be -1.
Negative 1.
Yeah, that's gonna cancel away with this negative sign here. And the cosine of pi over 3. I'm gonna let somebody in the audience do that for me.
1/2.
1/2. Thank you, sir, with the red code. So that's frac 1 over 2. Okay, cool. Recompile. Looks a lot nicer already, doesn't it? add some more brackets. We can distribute that 3 around. This becomes a 1. This becomes 3 over 2. This becomes 3 times this thing. I can get rid of this. Recompile. Okay, then I can distribute that 3 inside. Then this becomes -1. This becomes +3. Well, -1 plus 3 is just +2. So we can just say the answer is -1 plus 3 over 2. But that's just equal to -1 plus 1.5. Just equal to a half. Oh, dude, that felt good. Next. We just did this one. How far does my control set go? That's not this one.
Do you just want the answer?
Yeah.
7 divided by 6.
7 divided by 6. I believe you with my full heart. Thank you. Okay. And we did this one as well. I'm starting to believe they have very little assignments here for us to do.
This one is... I missed this one.
It's a bunch short.
I think it's e to the 3rd minus 1 squared divided by 2.
Wait, so it's e to the power, e to the 3rd minus 1 squared?
Yeah.
Squared, huh? Okay.
Divided by 2. Divided by 2.
Divided by 2. I don't recall this, but yeah. It's a different question, I'm pretty sure. Okay, so the answer we had was this thing.
Divided by 3. Yeah.
Yeah. You were close. Ah, finally, new one. So 0 to 4, 0 to 2 of 2x plus 1 dx dy. Well, now we're talking. This should be easy. That's going to be x squared plus x from 0 to 2. So that's literally the same as just filling in 2 here in x. So that's going to be... Wait, we already did this one too.
Yeah.
This is 24. Let's go, boys. Well done. New tab. Next. Okay, and now we're going to see how will the next one go. Because this is the one I'm afraid of.
Yeah.
Yeah, this one is by far hardest.
Yeah, it's like by far the hardest. Actually, I'm gonna say we're gonna take like a little break so we can refresh our minds a bit, get like a little bit more ready. And it's gonna be the last one we do. So we'll meet each other in like 12 minutes. Is that okay with you guys?
If you say so, sure.
Okay. So I'll see you guys at like 17:45.
Okay.
I've been recording for 6.5 hours. Apparently, there's going to be an evening clock for the Netherlands after Friday.
What time?
8 o'clock in the evening, 4 o'clock in the morning.
I did hear there's some stupid flaws in there, like you can always go home if you're on your way to go home. So if you really want to, you can just go to friends at like 4, then in the middle of the night to go home.
Yeah.
What is the evening clock? What? What do you mean?
It's a curfew, no?
Yeah.
Yeah, there will be a curfew from 8 p.m. to 4 a.m. with the only exceptions being that either you yourself or just you need to bring someone to work or school, or just like you just said, heading home.
So from 8 p.m. to whatever in the morning,
4 a.m.
I can't leave my house.
Nope.
No,
Oh.
you'll be mandated to stay indoors unless you need to either go to
Okay.
work or go home.
Yeah, or you can like let your dog out.
Oh, that's me.
Take your dog for a walk. That's like the only
That's
other
right.
thing I think.
Can you
So
actually?
grocery shopping's not allowed?
Well, just keep in mind the hours are not set in stone yet. They might still change, but probably not.
Well, there goes my regular shopping time.
And
That
if
was
you are
more than 10.
outside without a valid reason, it's a €95 fine.
Let me go to the toilet real quick.
So what do they do if you're still on your way, like right around 8? Are you just
If
fucked?
you're on your way home, you can still head home, probably. But if they don't trust you, you're still going to get fined. And if you need to head to work or to school between those hours, you need, or at least if you need to head to work between those hours, you need a special form from your employer.
I mean, my girlfriend comes over right around 8 if she's really early, but like might be slightly later.
Yeah, but that's fine. You can always head home whenever you want to.
Yeah, you
I mean, she doesn't live here. She lives in Rotterdam and then comes to Tilburg on Friday and leaves on Sunday.
Well, then she'll have to leave earlier, or she
That's
can't.
not possible, though.
If she doesn't live in Tilburg, then she has a problem.
Or
She
just
can have
equip
two
her
houses,
with an Uber Eats bag.
just send her to her house. Like, if your parents are divorced, they can also not prevent
Just
you
order
from
an
going
Uber Eats delivery for yourself. Just, hey, can you deliver me real quick?
Just shove yourself inside that box.
Let's see, they might bring back the amount of visitors that are allowed. Right now it's 2, they might lower it even more, and they might make
How do you
quick.
switch from 2, but okay.
I mean, then it will either be 0 or 1.
I want to say 1, yeah.
Yeah, probably 1, so people don't go full depresso mode. And aside from the mandatory negative PCR test for flights from high-risk areas, they also want to make quick tests in just when you land mandatory.
Bruh.
And currently, the entire planet is high risk. So
Nice.
Wait, so the loophole would just be having her, like sign her up living at this place?
No, just
Wait, but
give
if you
her an
test
Uber
positive
Eats
when you
bag.
land, what do they do?
What?
You probably have a friend who works for Uber Eats or Deliveroo or something like that. Just give her a bag like that.
I
And then
don't.
she can go on her way.
I have one, but she moved to the UK.
I mean, technically, you could still like set it second living because if your parents are divorced, you can also not you're not written that you live in two places, and they cannot prevent you from going to your other parents. So it's kind of like.
And it's not like the place is gonna actually check where you live and if you're actually going there.
no,
I mean, it kind of depends on how strictly they're enforcing it.
It's the
I mean,
Netherlands.
even
they're
then,
not going
yeah,
to do. They're not going to do roadblocks or checkpoints. They're just going to be patrolling the streets. But there's not. We don't have many police officers, so the chances of you running into one are pretty low. We had a police officer shortage for the last few years, so
I guess.
that's why we have Boas.
Yay, your favorite
Good
friend.
friends.
Your
Your good
favorite
friends,
neighborhood degenerate.
Lego police.
And hey, tomorrow is Biden's inauguration. So are you guys ready for chaos and death.
I'm still waiting for the Civil War, honestly.
Yeah.
Like 2021 has been too quiet.
But I would honestly not be surprised if someone tries to assassinate Biden.
I mean, you know, just like Trump had Pence, we should just have like, or they should have like AOC or someone as the vice president. Just kick whoever it is right now, and have someone really left. So it's like an insurance process. Like, yeah, you can assassinate me, but then we're gonna do all the things like take care of people or like that you don't want.
Kamala Harris is already pretty left wing.
I have no clue about her policies, to be honest.
I mean, she's not as left as AOC, or Bernie, but she is a lot more left than Biden.
All right, so there's still an insurance policy in place.
Yeah. So if Biden kicks the bucket, they will definitely not be worse off.
I mean, depends. If you're gonna assassinate him, then you think you're gonna be worse off.
Yeah, but if you think Biden is a bad person to lead the country, then you probably shouldn't even be allowed to vote.
Oof.
I mean, if Biden dies, like it's gonna be Harris, right?
Yeah, it's gonna be Harris.
Yeah, that's a yikes too. Like, but
Right.
both of them are nice. Of course, anything's better than Trump, but like.
I mean, Kamala isn't that bad.
Yeah, I mean there was some stuff with like weed offenses that people were pretty pissed about, but
Her track record isn't clean, but
yeah.
If I had to choose Kamala or Biden, I still choose Kamala.
Yeah, fair, honestly. We have 1, 2, 3, 4, 5, 6, 7, 8 people who are not deafened still here. Shout out to the real krijgers.
I can't get a shout out here. I have been
real warrior.
Half an hour.
Fair enough.
That's fair enough, honestly. I understand. We've been doing this shit for 6 hours and 40 minutes. For the people on YouTube, if you see this, respect to you too.
I mean, it's
Hi,
a lot easier
YouTube.
because you can just like 2x or maybe 3x speed.
Most people viewing this are probably just gonna skip right to this part that we're gonna start right now.
That's true.
Fair enough.
Hell yeah, we're only 4 million away from 100 million coronavirus cases globally.
Yeah.
Well, we're probably gonna reach that tomorrow.
Yeah.
Yeah, and America has 25 million of those, or 24.1 million.
I mean, they're just trying to secure their lead,
Like, genuinely, America has almost, no, I think even more than a fourth of all the global cases.
Yeah, they have over a quarter.
Yeah.
Yeah, but look at it this way. Now, even if they vaccinate everyone tomorrow, they're still going to be number one. Like they are just securing their spot on the leaderboard before they're taking a break.
That's true. You know what they say, huh? It's America first.
Even India, which has a population which is like 6 times bigger, has 10.5 million cases, which is less than half of the US.
Yeah.
Although, aren't some parts like really fucking poor, so they wouldn't even bother testing?
That's true. I think like the numbers that we see and the actual numbers are like kind of skewed, but that's because like there's just no tests or like
you
limited
can
testing capacity.
you can compare European countries and America, for example, but if you go to the poorest countries or at least the poorest regions, I don't think you can really compare them.
Yeah, me neither.
Even if you compare just the US to European countries or countries like South Korea and Japan, they're still doing a lot more.
Yeah.
Yeah.
I always
we have
wonder,
China.
like, how many people are actually having corona in the Netherlands that we're not even testing?
Yeah, for sure.
I think
Like,
it's an estimate like 140,000 right now.
Yeah. Our numbers are like getting a little bit better, but at the same time, it's not.
It's
very
not
good.
gonna be great.
Yeah.
Especially
if you look
with
at the graph, here, wait, look at
more
my screen.
infectious British variant coming in.
Wait, why do you not use dashboard?
Yeah, I also have the Corona dashboard open here. I like permanently have this one open, but then I can't see
That's
the
kind of
graph.
fun.
And the graph is just this number.
Strange,
These
you know.
numbers.
We have a British strain, a Japanese strain, a South African strain, and a Brazilian strain.
Yeah, and they're all more infectious than the one we've had in Europe for the time.
Yeah, and as far as I know, we don't know if they're like if the vaccine is gonna help against the other strains.
It should.
Yeah, it most likely will.
The South African strain have already been cleared for that. Just they will still be the vaccine will still be effective against them, but the Japanese and Brazilian strain we have no idea.
Yeah, we will see. Like the thing is, I have literally been outside once in the last 3 months, and that was to go to the dentist to get my braces fixed. I have literally not stepped
Yeah,
out
I've
of
also
my door
avoided it.
any other times. So
I still managed to get corona, even though I like barely went outside though. That was fun.
yeah, like here, my neighbor has it, my boss has it, my girlfriend's mom has it. There's like so many people within my circles that have it. I just
Yeah.
don't interact with
Probably
anyone
already-
if I don't absolutely have to.
My girlfriend probably had it in both waves.
Hmm?
My girlfriend probably had it.
You're like lagging like a fucking robot, man. What are you saying? Yeah, we're not even hearing
Nice.
anything at this point.
Can you hear me now?
Yeah.
Yeah. My girlfriend probably had it in both waves.
Damn.
What do you mean?
Wait, in the first and the second, or the second and
Yeah, and
third?
the first and the second.
Alright, so is she going for a repeat now, or?
Dude, she's going for like
Well,
world record amount of fucking things.
I mean,
Speedrunning
like,
Corona.
She's
Also,
living in France, and both of her parents are general practitioners. You know, if anyone's going to get exposed, it's her.
by the way, for this thing, I am 100% gonna use Paint.net. I'm
Yeah,
gonna
that's
sketch
probably
literally
fine.
everything.
Just use GeoGebra.
That could work as well, but like I need to be able to sketch them myself as well because I will have to sketch them on a website on a paper without websites. So
Yeah, but the sketching isn't hard, honestly, but
yeah, but like there might be things that I don't know the shapes of or that I think are differently, and then like if I do it in GeoGebra, I won't see it if I do it wrong, and if I do it wrong, you guys will yell at me, which is good.
fair enough.
The break is
will
over.
we?
Well, I mean, they said there was only one guy who was gonna like pay attention and work hard on
Oh
it.
yeah, fair enough.
Okay, dy dx whatever. So everybody, come follow, head around, page up.
It's honestly not too bad though. It seems worse than it is.
Yeah, that's true, but I haven't.
Well,
like-
it's pretty bad if you've been doing calculus for almost 6 hours.
Yeah, that's the hardest part, I think.
Actually, we've been doing it for 6 hours and 45 minutes.
Damn.
Yeah.
Well,
But-
there were breaks in that.
Yeah, okay, that's true. We had
Your
like.
timer doesn't have those breaks.
That's true. But there were like 10 minutes when I forgot to put the timer on, so we're past 6 hours already.
Oh jeez.
Okay, looking at the lecture slides. Yeah, this stuff. Ugh. Okay, wait. I'm gonna see if there's any like theorems here. Oh yeah, the difference between type 1 and type. What do you mean? It's like the different. Oh my god. Anyway, the difference between type 1 and type 2. That makes sense. It's just like type 1 is bottom to top, type 2 is left to right. This is a pretty important slide.
Wait, so when is it which one?
You can do both. It doesn't
Type
really
1
matter.
is the top one, where it's like from top to bottom. And where you just have like x being limited between point A and point B. Let me see if I can throw this up in big. X is being limited between point A and point B, and y is being limited to the graph of and the graph of. And then it's like first the integral of x, then the integral of y, blah blah blah, integral of y, integral of x, because you're gonna like every strip that y thing that you're evaluating here, and then you're gonna sum all of those because the integral is nothing more than a Gaussian sum. You're gonna sum all of those from left to right. And the same here, but then from left to right, top to bottom. I'm gonna put this slide in the calculus channel. I just put random slides there when I think they're useful, so I can look back at them. and people are probably getting annoyed by it, but it doesn't matter. Oh, okay, we'll see how far we will come. Practice now. Consider the integral. Okay, sketch the reason of integration, change the order of integration, determine the corresponding boundaries. Okay, so we have one region that is from x from 0 to 8. So I'm going to mark down those spots. X is 0, x is 8. And then y goes from 0 to y over 4.
Just a general tip: if you see integral plus an integral, just always flip the x and y axes, and then you can always integrate it easier with these questions. I mean, here they're literally saying flip the order of integration, but if you just get the integral by itself, just do it, and you'll be easier out.
Yeah, most likely, yeah. But we'll see. So it goes until y divided by 4. So that is
That's 1/4 of x because you need to flip it.
Yeah, but
It's
just seeing this region, what would that be?
Yeah, it's
Like-
x equals y divided by 4, so that gives y equals 1/4 of x. So just draw 1/4 of x. So just a line.
Wait. If x is equal to y over 4, doesn't that mean that y is equal to 4x?
Yeah.
Oh yeah, sorry, that's what I mean. Yeah.
So that means we have a line like this.
Yeah, a bit higher, yeah, like that.
Yeah, like a lot higher. And that go. Okay, I'm not gonna do it that high because we don't have enough space for that.
It's fine.
It doesn't matter. So and this goes until 32. And then we're talking about integrating. Let's see. So x's. So this is about the x-axis is between 0 and y over 4. Okay, wait.
No, you
I fucked
dy
this shit up.
is at the end, so you need to see it from the y-axis.
Yeah, I see. So it's from y, it's from 0 to 8. Excuse me.
Yes, exactly.
This is a learning experience, everybody.
We're here for
And because x equals to y over 4, that means y is equal to
4x.
4x. So that means we just have this thing. And if y is equal to 4x, 8 is equal to 2x, so x is equal to 4. 8 is x equal to 2.
What? Yeah.
So this is x is equal to 2. And then we are talking about the region from 0 to y over 4 in the x direction. So we're talking about this region.
Yes.
So let me just finish this thing off. So then we have this thing plus from okay, the x is from, or the y is from 8 to 12. So that's just this thing here to 12, and the x is from 0 to square root of 12 minus y. So we have just using this as notepad. So x is equal to square root of 12 minus y. X squared equals to 12 minus y. Y is equal to 12 minus, y is equal to 12 minus x squared.
Yeah.
So then we have, how would it look? Something like
a semicircle, I think.
Let's see. So it's minus x squared. So the higher x goes, the increasingly more gets subtracted. So it's like this.
Yeah, exactly.
Or let's do it more like this.
Yeah.
Yeah.
And hopefully, if you look at this graph, you can see that taking it from dx is easier. That's kind of the goal of this exercise, I think.
Yeah. So that means that we will, let's see. So if we first do the x, that means we sum these parts.
Yeah, first do dy and then outer dx. Yeah.
Wait. Let me get the picture again.
The lines have to be the other way.
Yeah, okay, so right now it is in the form dy dx, or dx
dxdy.
dxdy. So currently we're measuring it like this.
No, that's dy dx.
Sorry, like this.
Yes.
And they're saying it would be better to measure it like this.
Yes, and that's because then you only have one integral to evaluate instead of two.
Yeah. I see. So this would create, so if I put this to the right side, this would create an integral. So let's see, right now it is, God, I need more like space. So right now we have it in the form dx dy, we want it in the form dy dx.
Yes.
So, let's see. From y, so this would be the integral going from y equals to, was it 4x?
Don't you do the inner one? Isn't the inner one supposed to be with like x, with variables?
Okay, yeah, that makes a lot more sense now that you mention it. Okay, so y, the inner integral. Okay, so first of
I
all,
always start from the outside, but you can do whatever you want.
Yeah.
Easier that way, I feel.
So it's now dx dy. We want to get it to dy dx. Okay. So the inner integral is the pieces of y. So they're these pieces. So the inner integral is.
No.
Hmm.
You have to evaluate it differently. How I do this is dx, you want dy dx, right? So you want dx on the outside. So
Yeah.
the outside is just 0 to 2.
Yeah,
So
yeah.
it's integral 0 to 2. And then integral of the regions minus each other, because the region of the upper graph minus the region of the smaller graph is the entire thing.
Yeah.
So what you then do is you just have the upper graph at the top and the smaller graph at the bottom, and that's your integral.
Yeah.
Yeah. But let's see. So the upper graph was y is equal to 12 minus x squared.
Mm-hmm.
And the bottom graph was 4x.
4x, yeah.
So we'll have it like this.
Yes, and that's your answer.
So from 4x to 12 minus x squared. That makes a lot of sense. Okay. Cool. So then determine A. That's going to be 4x. Nice. Determine B. That's going to be 12 minus x squared. Determine C. That's going to be 0. Determine D. That's going to be 2.
You see, it's not too big of a pain in the ass.
Yeah, you just have to like get your intuition. Okay, let G be a solid three-dimensional region enclosed by the cylinder and the region. Sketch the three-dimensional solid. No.
Yeah, it's a bit fucked.
And the volume of the solid. Well, you know, I'm always down for a challenge, like they say in France. Oui, oui. No, fuck off. So the region we're working with is this one. So it's x between 0 and. Well, let me actually put this down. So we have the function is equal to the square root of 9 minus x squared, but we don't have to do anything with that yet. Then we have the integral is from the region from. I'm just doing an arbitrary order of integration, so we do 0 to square root of 9 minus y squared. And then the and that's like dx, and then the dy is equal to the thing between 0 and 3. Sketching this. We have, let's see, the x region is from 0 to 2, so we just create a line here from 0 to 2, and the y region is between, that's, okay, from 0 to 3, and the y region is between 0 and the square root of y minus 9, square root of 9 minus y squared. So x is equal to square root of 9 minus y squared. X squared is equal to 9 minus y squared. Y squared is equal to 9 minus x squared. Is that correct? Plus, yeah. So then you get y is equal to... I'm not sure if we should do plus or minus here. No. Square root of 9 minus x squared. Okay, so when y is equal, when x is equal to 0, y is equal to 3. So we can insert that. That's not true. Well, it is true, but it's not what we want. So x goes from 0 to 3, y goes from 0 to the max point here, being x is equal to 3, being what? 0 again. Does that make sense? I don't think it does.
I mean, where do you go if x is 0? Isn't that still free?
Oh, yeah.
So y is free is still a useful point, right?
Okay, so from x is equal to 0 to x is equal to 3. X is equal to 3 is y is equal to 0. But that would mean we would go from... Oh, wait. I think I did it wrong. If this is the order of integration that we have, then y goes from 0 to 3, not x. Right? Because this dy is like...
Yeah.
Okay, so this 3 here. So when y is equal, when y is equal to 3, x is equal to 0. So x goes from 0 to 0?
No, actually, don't both of them go from 0 to 3?
Yeah, I mean, x is between 0 and the square root of 9 minus y squared. If y is 0, then x is less than or equal to the square root of 9, which is free.
I see. And how would we draw this?
Good question.
Okay, so we have this function, y is equal to square root of 9 minus x. At x is equal to 0, y is equal to 3. And then it starts decreasing until it is... Then I think it would be something like this, right?
Isn't it the other way around?
You mean like this?
I mean, x kills harder than the other one, right?
Ooh, that's true. But, the larger x is, the harder this will decrease. Because the difference from 0 to 0.5 is way bigger than the difference, way smaller than the difference from 2.5 to 3.
Yeah, so it should be more or less at the bottom already when it gets close to 3, right?
I don't think so. Let's actually... Let's have GeoGebra to like... I can't spell. GeoGebra. To like check it, at least. How the fuck do I use this?
Start calculator.
Okay. So we have x is between 0 between x is between 3. And then we have y is equal to square root of 9 minus x squared.
Oh, you were. My bad.
No worries, it happens. Okay, so then we have this. Now what? So we have this function, and we want to integrate this. Well, if we start integrating this with respect to x first, it will be possible, probably hard. And if we start integrating with what? What's the question exactly? Hint, choose a useful order of integration. Let's see if we can turn this around anyways. So if we take the integral from dy dx, then we first have to say the x restraints. So x is from 0 to 3. And then we have to put the y restraints. That's from 0 to 9 minus x squared. Recompile. Yeah, I'm pretty sure this is correct because, as we can see here, replacing the x with y doesn't do anything because this figure is like this figure is in its own inverse. You see? So we can just, without loss of generality, flip this integral. I'm pretty certain. Let's actually check. So if we say here, y is between 0 and 3, and x is 9 minus y squared, what happens? Yeah, so it still works. So flipping this one is really fucking easy, because these two are like equivalent.
Why does it not go all the way though?
Hmm?
Why does it not go all the way though? Like the graph.
And GeoGebra, because they really hate like doing values like this close to 0 is computationally intense, I guess.
But the other way around is not.
Here, you see?
Okay.
It just... Oh, fuck. Like, yeah. So these two are the same, then we can start integrating. So here we have a constant dy. Well, that will just be y times that constant integrated into the bound of integration. This is actually helping me to build an intuition though, so I'm really happy we're doing this. Well, because there's a y there, if we fill in 0, that means it will disappear. So then we can just fill in the top thing and be done with it. Oh wow, that makes it so much easier. Holy shit. Like genuinely, bro. Because look what we get. So then the answer is just the square root of 9 minus y squared, which is just 9 minus x squared, which is 9 minus x squared. And then we can integrate with respect to x. And then we will get 9x minus 1 over 3 x cubed from 0 to 3. So then when we fill in 3, we get 27 minus 9. And when we fill in 0, everything falls away. So the answer is just 27 minus 9, which is equal to 18. Uh, 18. Woo! Oh, that's good. That actually, I was not certain I would get that one, but that actually is correct. That's really nice. How far are we? Oh, dude, 1.5 out of 5 already. Okay. Let H be the solid, that is the intersection of the cylinder, this one, and the cylinder, that one. This is kind of a yikes question. If I go to GeoGebra and I say 3D, and I say x squared plus z squared equals 9. That's this cylinder. And then we have x squared plus y squared equals 9. So the intersection between these two cylinders... Oh, wow, wait a second. Huh. So then we would... this is really hard for my puny little brain. It's not a perfect sphere. I know that much. Right? Because if we have x squared plus y squared plus z squared equals 9. Are these two the same things? No, I don't think so.
Nope.
Damn it. That would have been really easy. Or at least made it a little bit easier. Questions like these are the ones that are going to get me fucked on the test, honestly. But, what do you guys say? Do it or skip it?
I mean, it's not a speedrun if you skip it, right?
That's true, that's true. Making a point.
No, just skip it every time you get this one and just have like 25 questions in total you have to answer. Just hoping you never get this one.
That's true. I mean, I want to be able to do it. Let's do it. Fuck it. We'll do it live. So, we've already cheated a bit because in the actual exam we would not be able to see this. Whee! Did I... Okay. So, if we have this, then like the area we already know, like this is going to be the area over there. That's like what we calculated before. Because 9 squared, x squared plus y squared is equal to 9. Oh, sorry. Exactly. So what this, like, this thing is just equal to the circle. Oh, that's not a circle. Like this. So that's like the area. And our original function was equal to... Z is 9 squared minus x. Huh. You know what I think we did? I think we sketched a first, like a quarter of the full thing. Because we sketched this part, so that's, let's say this part. Or, I can't draw on here, but like this part. And the function for the second thing, namely x squared plus z squared is 9. That's the thing we integrated. Namely, square both sides, move the x to over. Therefore, I think this is just equal to 4 times that. Let's try it. 72. Damn it! Okay.
Too good to be true.
Yeah, it was. It really was. But I don't understand why that doesn't work though. Because we first took this part of the full thing, so that the full thing should be just that times 4.
Can you scroll up a bit so I can read the
I
answer?
think it's because you don't have like a perfect floor. You know, if you look at the first equation, it's like a cylinder turned horizontally, and is that curve.
What do you mean?
Look at the first equation, like the one which cylinder is horizontally placed. You know, in the first exercises, that would be like a straight line. You know, the upper bound of the y-axis would be a straight line because it's a cylinder. Now it's an area placed between two cylinders. So it's like curvish everywhere in the axis.
Yeah.
So we are reducing some areas. It's not just 4 times the last exercise.
How would we do this though? Well,
I think we
realistically speaking, we know that the z is equal to, like,
Wait,
z is
isn't it
still equal to
because
the
it's
original
between
thing.
0 and 3?
Hmm?
Like the one we have now, like also has the negative values, but the first one was only working on the positive. So it's
Oh yeah.
like could be 1/8, maybe.
I'll give it a shot. It sounds like it would work. Is z inherently higher than 0? Oh yeah, because x is... Oh yeah, because like, yeah, okay. I see, because z is equal to this instead of plus or minus. Let's try it. 18 times 8. It's like 64 plus 80. It's like 144. I'm so like insecure. 16 times 8. Seriously? Did I seriously fuck that up? I did 16 times whatever. 18 times 8. Okay. I was correct. Haha. Let's go!
Yes.
Dude! You have a giga brain. Holy shit. Oh, dude, holy shit.
Nice. Nice. That's
Dude,
a lot of work.
that was some 400 IQ shit, man. Okay. So now we have the thing from x to negative square root of pi. Okay, let's sketch it. So we know the x is going from 0 to square root of pi. That's about like 1.7. All the mathematics crying in the background. Square root of pi. And we know y is going from x to square root of pi. Square root of pi. Well, that means that the line it's going from is y is equal to x. So we can draw that line here. And so the thing we're integrating is, let's see, it's either one of these two fields. I just have to figure out which one. It wouldn't really matter because the area of the both is the same though. But let's figure out just to be sure. So dx just goes from here to here. dy starts at x and then goes up until here. So I'm pretty sure we're integrating this area. Okay, cool. So if we did this with respect to y, would it be harder or easier to do this like the other way around though? I'm genuinely not sure. I think. Oh wait, sine of y squared is like a really fucky integral. It's like one of those two fucky integrals that's like really hard. So let's try it the other way around then. So we have this. I can erase this. We have the integral from 0 to let's see, what was it? Square root of pi, square root of pi of the integral of x to square root of pi of some kind of like sine y squared dy dx. So this is our original equation. Original integral, let's say it like that. How would we turn this around? So currently we're looking at it like let's see, so we have I might actually learn this just by heart. Just like dy dx is type 1, dx dy is type 2. Because that sounds useful and it's less intuition I have to build. Starting with di is type 1. So this is type 1, so this is like this. And we want to get it like the other way around, like this. So to do that, we can take the integral of dx dy. So first we have to define the y region. And the y region goes from 0 to square root of pi. Well, good, I don't have to change that. And the line, and then we go from x is equal to y to square root of pi. Then we just change this from an x to a y, and goddamn, we're done. Done, though. I'm not quite sure if this is the same, but we'll see.
Wait.
Hmm?
Isn't it from 0 to y?
Now that you mention it. Yeah, because like the start of every line we're doing is here. Okay,
Yeah.
thank you. Oh yeah, and at like the top point, y is equal to x is equal to square root of pi.
Yeah.
Okay, cool. Recompile. Okay, and now we can start doing this. So, oh, I can get rid of this integral, copy this. Then this thing with respect to x is just adding an x from 0 to y. And well, when we start with 0, oh, this makes it so much easier. Holy shit. When we start with 0, well, the answer is just going to be 0. And when we end up with y, then the answer is going to be y. And now we have something that we can actually do some u substitution with. Woo! Don't you guys love u substitution?
No.
No. Okay, I'm going to say u is equal to y squared. Du is equal to 2y dy. Du is equal to 1 over 2y dy. Other way around. Dy is equal to that thing du. And that should be all we need. So now we can take this y, put it over here. And then by replacing dy by this thing, we can see what our integral will be. And we can replace y squared by u because that's what we're integrating on. And suddenly you can see that the y's cancel out. So you get this one here, cancels out with this one here, and you can take the 1 over 2 to the front. And now this integral is a lot easier than this one. Like a lot. So we end up with
But this one's from 0 to pi, not square root of pi. When we change to u, now it's going to be from 0 to
oh yeah,
pi.
we also have to change the bounds of integration. That's a good one.
Yeah.
Thank you. I would definitely have forgotten that on my test. So that's really good that you tell me now, actually. So then we take this, fill this in, and then we get, well, sine of 0 is 0, sine of pi is also 0? That's not right. Wait, it is.
It's, shouldn't we do cosine now?
Yeah, because I knew I forgot something. So sine becomes negative cosine.
Yeah.
Negative cosine, negative cosine. And then the cosine of u, or the cosine of pi, is equal to negative 1. So this is going to cancel out and become 1. So therefore this is equal to a half.
No, it's going to be 1. Because you have negative cosine of pi minus...
oh yeah, because cosine of 0
plus
is not...
cosine of 0. Yeah.
Yeah, good call. See, I still need you guys because I'm just so fucking sloppy, man. So we
6
get
hours
negative...
and a half.
I'm going to factor a negative out, and then we'll get cosine of top minus bottom, so cosine of pi minus cosine of 0. And then, well, cosine of 0 is positive 1, cosine of thing is negative 1, so then we get negative 2, that's going to be 2, and that's going to be equal to 1. Thank you. Okay. Given is the integral, I is the y dA, here d is the area in the first quadrant enclosed by the x-axis. The line y is a half x, and the parabola y equals to 8 minus x. Okay, sketching time. So it's enclosed by the x-axis. The line y is a half x. So it's like this, or like this-ish. Whatever. And the parabola y is square root of 8 minus x. So that is a line that would go something like, okay, so at x0, y is equal to square root of 8. So this is like square root of 8. First of all, we should see where they equal to each other. So we can have 0.5x is equal to square root of 8 minus x. Square both sides, 0.25 x squared is equal to 8 minus x. Bring everything to the other side, 0.25 x squared plus x minus 8 is equal to 0. Multiply everything by 4, x squared plus 4 minus 32 is equal to 0. Is there something nice that does this? I don't think so. X equals to negative 4 plus or minus the square root of 16 minus 4 times 8 times negative 32. So that's plus 4 times 32. 4 times 32 is 128 divided by 2. Okay. Therefore, x is equal to negative 2 plus or minus the square root of 142. Can we divided by 2? Can we get anything out of 142? 142 divided by 4 is no. Seriously? Can we not? Yikes.
That's 44.
Is it?
No?
I don't
6
think
plus
so. And no. I think I made a mistake somewhere then, because this is like really, really ugly.
Yeah, probably. You could try to rewrite it as a square. So instead of doing this,
I mean,
we
16
could write it
plus
as
28 is not 144.
oh yeah, that as well.
What did you say? Your mic's kind of bad.
It should be 144, not 142.
There we
Just
go. And that's 12. Okay, thank you. So then this is equal to 6, and then this thing is equal to equal at minus 8, or x equals to 4. There we go. Okay, that's really good. So we have x equals to 4 here. This is where they intersect, and this thing here goes from square root of 8 down here to 4, and then it will, I don't know, let's see, so this will, when the square root of 8 minus x equal to 0, 0 squared, 8 minus x is equal to 0, 8 is equal to x, so this will just like continue on, continue onwards until like x is 8. This is like the prettiest graph I've ever drawn. But we don't care about any region that's past this point, because this is all we need to calculate. It's kind of a really bad drawing, actually. Give me a sec. My graph doesn't scale well, so like this. Whatever. Okay. So that's the thing we need to take, and right now, well, we can choose how we want to integrate this. Do we need any more points? We already have. It's from 0 to square root over 8, and then between x is equal to this and x is equal to that. Or y is equal to this, y is equal to that. So when we're talking about y, it's probably best to do dy dx. Dy dx, that's type 1, that's up top to bottom. So that's like this.
Shouldn't we do the negative part as well? Like if we
No,
continue the parabola the other way.
Like this part.
No. Like if x is negative.
No, because it says in the first quadrant.
Oh yeah. Okay.
But otherwise we should have. So that's a good call. Okay, so we have this now. That's our region. That's good. So then we can start doing this. So then we have dy dx. X ranges from 0 to 4. Also a note to self, or like a note to you guys as well. When you're working with this stuff, you know you've done it right if or you know you've got something solvable if the variable like x is in the second part of the integral. Because if you have like an x here, you're gonna end up with something in terms of x, but you want to have just a number.
Yeah.
But yeah, so we have from 0 to from x goes from 0 to 4, or fuck. We should have the other way around. So we have dy dx. X goes from 0 to actually it should be 0 to 4. Y should be from fraction x over 2 to square root of 8 minus x. And then the function was y dy dx, I think. So this one, graphable. Yeah, y dA, in this case being dy dx. So is this, let's see, is this correct? So we have this function from x divided by 2 to square root of 8 minus x. That seems right. Let's try it. So y becomes half y squared. We can bring the half out to the front. I love things where there's no like geometry involved.
Yes.
Okay, so then we get y squared, and this is already integrated from these bounds. So let's see, we do top minus bottom. So we get top gives us 8 minus x minus fraction of x squared over 4. Let me see if that's correct. Dx. And then this spec x should go away as well. Yeah, so we do the top thing squared, which is, yep, and then the bottom thing squared, minus the bottom thing squared. Yep, seems fine. Okay. Cool. I'm gonna turn this into a little bit more readable like this. And then we're gonna try integrating this. So the 8 will become 8x, the x will become half x squared, and the x squared will become 1, or a fourth x squared will become 1/12 x cubed. Get rid of the dx and fill in 0 to 4. I love integrals that go from 0 because that means that they will 100% certain be like when you fill in 0, it's going to be 0, because like if you have an integral of constant, it's going to be 0 times that constant. If you have like anything else, there's already going to be x in it. Okay, so it's compiling. It's compiling. It's taking its sweet diddly darn time. Well, while it's compiling, I'm just going to go on. So when we
It's probably also tired after 6 hours.
Hmm?
It's probably also tired after 6 hours.
Dude, I don't fucking blame it. So when we fill in 0 everywhere, everything just disappears. And when we fill in 4 everywhere, the server is down? The overleaf server is down?
Wow! Wow!
I think that's a GG.
Okay then.
Overleaf.
Well, continue in Vim, I guess.
No, that's just
Yeah.
a GG.
Just continue your notepad, man.
Okay, I'm gonna tweet.
Right.
I'm gonna tweet. Overleaf then, I guess.
It's a sign. It's time to give up.
No.
If we never give up.
Twitter.com. I'm Dennis. Just gonna send an email to a message to Overleaf. Do they have a Twitter account? Yep.
Seems like it.
You okay? There, buddy. I was 6.5 hours into my calculus speedrun TM emoji. Right. I'm not sure. Let me open Discord real quick. TM. I want to copy it.
I believe in Windows you can also just right-click and add emojis.
Oh,
yeah, you
nice.
can.
Into my calculus speedrun when the servers went down. Will my progress be saved?
Oh, it's working for me.
Is it back up already?
Yeah, I think so.
It's not for me.
Control Shift R.
I was about to say, what if I deadass just have like my cookies fuck it up or something?
Nice.
That would be fun.
Are you kidding me? Do I seriously?
That sounds like a possible
okay.
exploit if your cookies are fucking up the server.
Yeah, but it's not. It's working. It's just like starting back up again. Tweets and replies. Oh yeah. Reply. Update. Never mind. It works again. I'm gonna see if my progress is still there. Recompile.
I would imagine the server doing a compilation part's not up yet.
Progress is still there. Dude, seriously? We get a bad time in our speedrun because of something out of our control? SMH. Dude, this...
Is it just gonna keep crashing? That would be fun.
I'm just gonna delete this tweet. I'm just gonna copy this. And I'm gonna go to Notepad. And I'm gonna finish this fucking exercise.
Yeah.
Old school.
Okay.
Don't you have a LaTeX compiler installed in your PC?
I'm not sure. I probably don't. I do have a LaTeX syntax highlighter.
Good enough.
Yeah.
I guess we're all just human LaTeX compilers now.
I mean, at this point, you've seen like 6 hours of me writing LaTeX. You should be at least decent at it. So when we fill in 4 everywhere, this becomes 16, that becomes 64. 64 over 12. This becomes 8. That becomes 8 over 2. That becomes 4. Is that correct? Yeah. And then when we fill 4 in, there's going to be 32. 32 minus 4, that's 28. And then, well, it's a half times this. So this becomes 32. This becomes 18 or 14. Is that correct? Yeah, 14. And that should be the answer. Or let's put it in a fraction form, because I'm feeling fancy. What's 14 times 12? That's like 144 plus 2 times 12. 144 plus 24, that's equal to 168. 168 plus 32, that's equal to 180. Wait, oh, that's sick. This is equal to 15. Yeah, that's equal to 15. The answer is 15. Ooh, here I was thinking that it's gonna be some like really bad answer. It's incorrect. Okay. But now I'm not sure if it's like my math being off or not. Hmm? Okay, so again, this 8x correct. This is 1/2. Yeah, and that is okay. Seems correct. So we have 1 over 2 times this thing when we fill in 4. 4, this becomes 16. So half times that becomes 8. This becomes 4, that becomes 32. Oh yeah, I had 24 here. No wait, that's 24. I had 28 here. Should have been 24. This becomes 64 divided over 12. Divide everything by 2. This is 12 minus 32 divided by 12. Let's see. This is 144 divided by 12. I already took care of this half, by the way. So then that's 144 minus 32. 144 minus 32, that's 112 over 12. And that's a good place to stop. Dude, am I literally bad? Or if I do this and then I say, does this work? If it does, then we'll all fight like the best. It probably doesn't. So if I'll just say this, and then with x equal to 4. When you're so burnt out that you have to do like multiplication, 28 over 3.
Wait, no, that's the same thing.
Wait, 28 over 3. So let's actually check.
So we probably have another
12
mistake.
over 12. 28 over 3. So we fucked up somewhere else. And what happens if I do this and I just put this in here? It's chugging.
I think you have to use a symbol lab for that, but you can do double integrations with symbol lab.
Yeah. I'm curious what went wrong though, because this is the right area, I'm pretty sure. So we take y squared. Oh yeah, a half to the front, y squared of the top thing minus the bottom thing squared. X squared over 2 is 1/4. Yep, that seems fine. Then when we integrate this, we get 8x minus a half x squared minus x cubed, then this divided by 3. This seems correct. That means I made a mistake in my original thing.
Bruh.
It has to be. Right? All of this has x in it, yeah. So it all disappears. I'm so confused. What would the answer be? 20 over 3 instead of 24 over 3. Whatever. Go to the next one. We already did this one, didn't we? No, we didn't. This is like the same type of question where we just do full g times 8.
Yeah, I think so.
Yeah. So it is a parabolic cylinder. Blah blah blah. Region is 0 between. Ooh. Okay. So
Actually, I'm tapping out though, so good luck. I'll watch back the recording. I'm fucking brain dead.
Yeah,
Good night.
I feel ya. No worries. Have a good one. Only the harde kern, boys. Okay.
Yep.
So we have the region x is between 0 and 2. X is between 0 and 2. Is my recording software still running? Yes, it is. And y is between 0 and x. So let's see, y is equal to x. So that means we just have this line. It seems a lot nicer to do than any of the previous things. And we are working on, see, so y is between 0 and x. So like this. Yeah. So we're working on this area. and it is dy dx, so it's type 1. Okay. So the integral would be, oh, and let me go here. Z is equal to 4 minus x squared. So the integral would be, let me see if overleaves this line again.
What do you mean with your dy dx means it's type 1?
Okay, so we have an integral. Let me
So if
get
it's
it.
dy dx, it's the other way.
Hmm?
If it's dy dx,
Oh,
it's...
excuse me. It is of type 1, but indeed that's like this.
Okay.
But right now, that means it's type 2.
Okay.
Let's see, because yeah, x is between this and this, but it is
Can we do both here?
Oh, it's dx dy, yeah. And we can do both, but the way it is written now with this is in the
Oh yeah.
And the type 1, type 2 thing is just something you found on the slides, or is it just...
Yeah. This is just a type 1, type 2 thing. And I just know that like dy dx is type 1, and that's like up top to bottom.
Why don't you just think of it like the outer x is where it's from? If it's dy dx, it's dx at the end, so it's over the x-axis.
But dy dx is over the
Over the
y-axis.
x. Well,
Or
no.
it travels across the x-axis, I guess.
Yeah.
Yeah, we can do that. So dy dx traveled over the x-axis.
It doesn't matter.
But this is like...
I was just asking for clarification.
Yeah.
I was asking about the
But then this is dx dy. But that wouldn't make sense because our thing here has y in terms of x.
Yeah.
Oh, wait, okay. So it is like this, and it is type 1. And the reason I know this is because I said, as I said before, we want to have the thing that is like...
Yeah, the first integral to have the values.
Yeah. So this is from... I can get rid of this stuff. So this is from y is equal to x to y is equal to 2. And here it is, x is equal to from 0 to 2. So we can recompile. Go to the left a bit. Okay, so this is what it
Isn't it from 0 to y to x, not x to 2?
No, it's from x to 2, right?
Wait. Oh yeah.
Okay, clear. Okay, let's see. I'm gonna react to this real quick. It's up again. Everything is still there. Okay. Okay. Is this nice to integrate? Probably not. We're gonna try. Well, this is just gonna be 1/2 y squared from our bounds of integration.
Wait, can you go to Graspel real quick?
Yeah, sure.
I think our sketch is wrong.
Yeah, our sketch is this. Excuse me. You mean our sketch is wrong or what?
Yeah, because y should be smaller than x. So, wait.
Yeah, 0 is between... y is between 0 and x.
Yeah,
So
right.
y...
So here it would be larger than x. I think.
Yeah.
Yeah, so it's that.
So it's like this. Okay, thank you. And also I messed up in the fact that here I said that we were integrating y, but that's still from the previous exercise. We are integrating 4 minus x squared. Okay, so 4 minus x squared, and we also did the wrong thing on the things here. So x still goes from 0 to 2, and y goes from 0 to x. Okay, thank you. Okay, and then from 0 to x, then when we integrate this, well, this is just all going to be this is all constant in terms of y, so we can just do it like this. and then in these bounds of integration. Then because they both have a y in it, we can ignore it when it's 0, and then we can fill in x for y. So this becomes x cubed, this becomes 4x. Okay, cool. Then this, when we derive it in terms of x, well, that's not too hard either. That's just a fraction of 1 over 4 x to the power 4 and 2x squared. This stuff. When we fill in 0, everything disappears, and when we fill in 2, this will become 2 to the power 4, this will become 2 to the power 2, which is 4. 2 to the power 4 is same as 4 squared, same as 16. 16 divided by 4 is equal to 4. The answer is, this is not 24. I said that wrong. This is 2 times 4. This is 8 minus 4. The answer is 4. Let's go! Nice. Okay. Let H be the solid. Let's see. Let H be the solid enclosed by the parabolic cylinder Z equals blah blah blah. And the region, is it the same region as us? No. How many points do we have? Okay, not too much already. Sketch the three-dimensional region, solid G. Oh yeah, but here it didn't say like look at it in terms of G, so it's not gonna be the same thing. So we're just gonna have to do this again. The region X is between 0 and Y is between 0 and 2. Well, then it's just gonna be this, right? Here, let's see. X is between 0 and Y. Well, here it's 0 and here it's Y. And Y is equal to 0 between 0 and 2. And it's the same area as well, so these would be the same, right? I'm pretty certain.
Maybe?
They're usually a bit different, but...
That's true, but I'm struggling to find something where it would be different. X is between 0 and Y. That is the case here, yeah. And 0, Y is between 0 and 2.
No, it's actually the other quadrant. So it's...
no, it's this quadrant. Because they're both positive.
Yeah, they're both between 0 and something, so it's this quadrant.
Is the question underneath here, what's the thing entirely? Yeah.
Ah, so we missed this one. So this... Let's just try it.
Yeah,
what?
No, it's...
Okay. Wait, this...
No, it's wrong.
This sketch is also wrong, I think.
Yeah, no, it's not a perfect quadrant. So what you do is you have one side, you calculate almost half the thing, and then you calculate the other side, and then the third question is what is them together? And then you can do the integration, or you can just add them together. And it's not 4. It's not, so the final answer isn't 8.
Yeah.
It's not
so
a
let's
perfect...
see. Let H be the enclosed, the solid enclosed by the parabolic blah blah blah, and the region. So X is between 0 and Y. So X is between 0 and Y is between 0 and 2. So we know for a fact that it's talking about this. That's a really bad arcolada. But it's like this area in the Y region. But X is between 0 and Y. So X is between... Is that not this area then?
Okay, let me think. Z...
Yeah, I think so, but I'm having a huge brain fart.
Yeah, me too. Because then it would just be the same.
X.
I think it would help to just draw the cylinder also, like for minus x squared.
Well, but that's just the thing we're integrating.
No, that doesn't matter.
Oh wait, I think the reason why... no, wait. I think it might actually be different then, yeah.
Yeah, no, it's the other quadrant.
Yeah.
No, it's still in this quadrant because they're both positive, but it's
No,
different shape.
Like he means this quadrant,
Yeah.
like this thing or this thing as quadrant.
Yes.
Okay.
The first one is the one on the that's drawn right now, and the second one is the other piece, and then the third one is them together.
Yeah, but they should be the same, right?
No, they are not. It's not a perfect square.
But it. How is it not a perfect square?
It's very weird.
Oh wait. Oh wait.
Oh, no, it's actually because of the.
Yeah. I see. So
Z.
it's not. The region is a perfect square, but the thing we're measuring is not. And I will show
Yeah.
you guys how
The
what I mean with that.
three-dimensional sphere over it is not.
Exactly. The three-dimensional parabola. So basically, the only thing we're changing here.
This would be very good in GeoGebra to show, but
Yeah, we can do that. So we have. Let me minimize this. We have z is equal to 4 minus x squared. Why is this double? Delete. And we have. Okay. And 0 is between x and y, and 0 is between y and 2. So we have this area, and we can turn.
No, that's the wrong equation. I mean, it's x squared plus y squared equals 9. There.
Oh yeah, it is the wrong equation. Thank you. So that is going to be z equals to 4 minus x squared. Yeah, that explains a lot.
Yep.
So then it does really matter which quadrant we take.
Yeah, that's what the
And
problem
the only thing that like changes here then is the order of integration, right? Like with this quadrant.
Yeah.
Okay, so let's try that in GeoGebra or in here. So now instead of having this, it would be this will be a y and this will be dx dy. All right. Yeah, and then we probably get a different answer as well. So then we get 4 becomes 4x, x squared becomes 1/3 x to the power 3. We integrate that from 0 to y. Well, 0 is going to fall away, so we might as well just fill in y. So we get 4y y cubed like this. Okay. Then we integrate this again from 0 to 2, so that's basically just filling in 2 in a bit. And this becomes 2y squared. This becomes 1/12y to the power 4. And then we fill in 2 everywhere. 2 to the power 4 is 16. And 2 to the power 2 is 4 times 2 is 8. So we have 8 minus 16/12 divided by 4. 4/3. 1 over. Yeah, let's do that. So it's 8 minus 4/3. There we go.
And now you can simply do it.
Yeah, okay. So now it's just 12 minus 4/3.
Hey.
All right. 7 hours, boys. Almost a full workday. Okay, let D1 be bounded. We're already at like more than 40% of this part, so we should be good.
Yeah, but we've been on this part for 1 hour.
No, only 30 minutes. We started at like 6:30.
Ah, okay.
Don't worry, it only gets harder.
Yeah, exactly. Don't worry, it's fine. Okay, so it's in the first quadrant enclosed by y equals to 2x.
No, you're actually pretty lucky. These are the easy questions of this.
Yeah.
Whole week.
So we have y is equal to x squared. So that's going to be like. Like this. And x equals to y, or 1/4 y squared. Therefore, x is equal to 0.25 y squared. X squared, square root of x. I like how I'm just off by 1%.
You can just look at it and just see it's the other axis parabola.
Yeah, it is. So that's like 1/2 y. Wait, is that correct? Yeah. And therefore y equals to square root of x divided by 0.5. So therefore we would get something like this.
Yep.
We want to get the point where they're intersected. So that is equal to, that's the point where square root of x divided by, divided by 0.5, that's just 2 times square root of x, is equal to 2 times x squared. Oh, well, that's easy, because then we have square root of x equal to x squared. That's just only going to be the case that x is equal to 1. And if x is equal to 1, then y is equal to 2. Okay. Now the question is, how do we, which way do we do it? We can say either the integral from 0 to 1 of the area starting at this graph going to this graph, or we can do the integral from...
For this one, it really doesn't matter, but I would
Yeah,
just
I don't think so, indeed.
outside. It's
we have to
easier.
calculate the area of the region.
Yeah.
Okay, yeah, well, that's not too hard.
Yeah, it's
Wait,
not.
the area of the region. Then we have to just integrate these.
Yeah, it's not even 3D.
Yeah, I was about to say. So we have these two graphs. That means we can take... Dude, this brings me back. Just good old integration. Integral from 0 to 1 of the first graph. So that is the 2 square root of y. Or square root of x. Dx. Minus the integral from 0 to 1 of, what was it again? Oh, 2x squared dx. And for the people who don't understand like what this is or how we're doing this, let me first check if what I'm doing is correct.
I think it is.
But yeah, we are calculating this full region here, and then we subtract from that this region here. Okay, well that means we can factor it the constant 2 out to the front, and then we can just do these integrals like we usually would. So the integral of x squared is 1 over 3x cubed from 0 to 1. Well, when you enter 0, nothing's going to happen. When you enter 1, this is just going to turn to 1. Then we have minus 2/3. And now this thing I have to think about for a bit. This is x to the power of 1 over 2. So this is still accurate now. Oh, I forgot the closing bracket. So then we add 1 and then bring that to the front. So then we have 3 over 2, and this thing becomes 2 over 3 from 0 to 1. Bin up. Well, when we enter 0, this thing goes away. When we enter 1, the x goes away. So this is just 2 times fraction of 2 over 3. We can turn this into a 4. We get 4 over 3 minus 2 over 3. We get the answer 2 over 3. Told you this was fun. I mean, we're only at it for like half an hour, and we're almost halfway there. We're over halfway there.
We're almost half an hour. Have a good look.
Yeah. Okay, well, yeah, I split wrong.
yeah.
Okay, no, we've been at it for over an hour, but we're halfway there. That means only 1 hour left, and then we're done.
And then we can spend the last 4 waking hours doing that.
No, I'm not gonna do that.
And it's theoretical, just say.
Tomorrow morning.
Bit harder.
Yeah, like what the fuck are we gonna do with calculus, man? Come on, we've already finished ADS. We're doing WDT, and what the fuck is calculus, man? Yeah, I'm gonna do the lecture. It's just Hmm? Have you joined a? Well, okay, this guy. Get a load of this guy. He joins ADS lectures.
Wait, what? Who does that?
He joins ADS lecture, but just to listen. He doesn't actually like. He only listens to see if there's anything important being said.
Yes.
Like podcast.
Okay, guys, this is very important. I tell over.
Okay, is my recording still working? It is. Okay. Okay, question 2. Let D be the area of blah 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 blah. So we will again have to graph. This shit is easy, man. So we have y equals 2x squared, and we have x is equal to 1 over 9 y squared. Therefore, square root of x is equal to 1 over 3 y. Therefore, y is equal to 3 square root of x. Is this literally the same assignment we just did? X is between 0 and 1. Oh, no, it's not. They say x is between 0 and 1. So at x is 1 here, that's where we stop. And by plotting this, we get y is 2x squared. That's going to be something like this. Oh. This. Oh. This. I don't care. It's good enough.
It's fine.
And we get 3 square root of x. That's like this as well. But the intersection point is going to be later, because when we say 2x squared, 2x squared is equal to 3 square root x. I'm not even sure how to solve this with not 1. I guess square both sides. Then we get 9x is equal to 4x to the power 4. Oh yeah, I see. So then we get 4x minus 4x to the power 4 minus 9x equal to 0. Therefore x is equal to 0, or x cubed, or 4x cubed minus is equal to 9. X is equal to 0, or 4x x cubed is equal to 9 divided by 4. Therefore x is equal to 0, or x is equal to the cube root of 9 divided by 4. That is not something we're going to use, however, so we can just forget about that. But that's just like the x coordinate of this point. But we're not going to use that. So again, we're just going to take the integral of the top part minus the integral of the bottom part and see where we get. So, yeah, okay, the bound integration are x again, so it's just going to be 0 to 1. And then we have 3 times the square root of x and 2 times x squared. I shouldn't have deleted that stuff, that was useful. Well, we know that this is going to be, when we fill it in, it's going to be 3 over 2. Yeah, so then we get 9 over... actually, I'm going to take the extra steps between, because I'm not entirely certain. So this becomes x to the power 1 over 2. Then we... this one we just do normally. This becomes frac 1 over 3 x cubed. From 0 to 1. Filling in 0, nothing happens. Filling in 1, that thing disappears. This thing becomes 2 times that. Therefore, we get this. The other side, however, let's see, what do we get there? Plus 1 gives us 3 over 2. Therefore, to the front comes 2 over 3. When we fill in 0, everything goes away. When we fill in 1, this thing just becomes 1. Therefore, the answer is... I forgot about a tree. Okay, I didn't see this tree. I was like, what the fuck? So we end up with 2 minus 2 over 3. Boggers, dude. We're already at like 60%.
This one is fucked. Just saying.
Consider the integral. Blah blah blah. Sketch the. Oh my god.
Yeah, this one is absolutely fucked.
Determine. How many points is this? This is.
It's
all this together is like 1 point. Do we want to do that?
Yeah, please, because this is very hard. It's very useful to.
That's
understand.
true. It's useful to understand. You see, the timer's over the skip button, so now we cannot skip it. Okay, going through all this. Okay, so we have this region, which is from x is equal to 0 to pi over 4.
Yep.
And this is the point where I admit I have... Wait, I do have an idea what tangent looks like.
Yeah.
Because tangent of 0 is just equal to 0, so it's gotta be like this.
If the drawing was better, yeah. Yeah, exactly.
And pi over 4 is the case where it's positive infinity? No, it's 1.
No.
God, I'm so bad at drawing this shit. Okay, it's 1 here. Shut up, it's 1 here. It's not... Niet op schaal. Okay, and then y goes from 0... Or, yeah, y goes from 0 to tangent of x. So that means we are measuring this part here. Oh.
No.
Y goes from 0 to x. We're measuring this part here.
Congrats. Good job.
No, wait.
And the x is on the
Oh, you were right the first time, weren't
I was
you?
about to say, y goes from 0 to x. This is the y, this is the x. So
Yeah.
it goes like this.
No, the x is on the outside.
Oh yeah, you're right.
Who are you saying is
I'm
right
so
now?
confused.
The x is on the outside, so it's over the x-axis. So so it's the other. Look at your lecture slide thing.
Yeah. So wait, let me have a think. X goes from 0 to... And y goes from
Tangent.
0 to tangent of x.
Yeah.
Yeah,
So
tangent
y
is the upper bound. Tangent is the upper bound.
Exactly.
Yeah, so we go from y is 0 to y is...
No. Yeah, what you're doing right now is going from x. Is you're going from the left to the right, but y would be going from
Yeah.
the bottom
Okay.
to the top.
Indeed, because what I was doing now is x starts at 0 and goes higher. This is y starts
Yeah.
at 0 and goes higher.
Yeah.
So this is the area we're doing. Okay, thank you. Then, what the fuck is this?
Yeah, it's just a weird looking. It's not too bad. They just
Okay, so it's just a graph that goes from pi over 4 to 3 pi over 4.
Yep.
That's here. And that is 3 over 2. Oh, we don't even have to integrate something. We just change the bounds. Nice.
Yeah.
That's a full point for just changing the bounds on this function. That's how fucking fucked it is.
Yeah, it's a bit hard. Because
So
it goes
x goes
down.
from this point to that point, and y goes from 3
Just a
over
line going
2.
down.
But,
Yeah.
But doesn't that mean that when... Oh, wait, we start at x is equal to pi over 4. So what happens here if x is pi over 4? Pi stripes away, 4 stripes away, so this is 3 over 2 minus a half. So it starts here, yeah. We know that much.
No, wait, does it?
Yeah, because when
Oh,
pi
maybe
over
that's what
4, this
I
becomes a half.
For me, it didn't start there, so it was very, very hard.
Okay,
I did.
pi over 4, pi stripes away with pi, 4 stripes away with 4. So this is 3 over 2 minus 1 over 2. That's 2 over 2. That's 1.
I see. Okay, then it's actually doable. For me, it started way above there. So then I was like, how the fuck do you do this?
Yeah, yikes. That sounds really not fun. And then it just decreases.
Yeah.
So it's just a straight line decreasing from here, like this.
Yeah. Yeah, now it is doable.
Yeah. And we
Okay.
continue until pi over 4. So we know that the x is 0 is less than x is less than 3 pi over 4. Wait, they want it in the form dx dy.
Yeah, so now I just turn it around.
So now we actually have to look at it like this.
Yeah.
Let's see, and this abruptly... Does this abruptly stop here, actually? Because when x is 3 pi over 4... I actually think this might be 0 then.
Haven't checked.
Yeah, let's see. 3 pi... Pi stripes with pi... 4 stripes with 4, and then you have 3 over 2 minus 3 over 2. Yeah, it does. So this just becomes like this. And they want us to take slices like this. Therefore, y is between
0 and 1.
Yeah, so then we have 0 is between y is between 1. And
upper bound is the other line. Lower bound is arctan x.
Hmm?
You have to invert it.
Wait. So, for me, it would make sense that the lower bound is equal to x, or is equal to 0. So, because we're just taking going from 0 to, I guess, then 1, but at the same time. Okay, wait. We know 0 is less than 1. We know 0 is less than tangent of x, and we know 0 is less than 3 pi over 4. But which one are we going to use for the upper bound?
The line.
So the 3 pi over 4.
No, that's the point.
No, I think the lower bound is
the
tangent.
not the. Sorry, I didn't mean 3 pi over 4. I meant like 3 over 2 minus 4 over 2 pi
Yeah,
times
the
x.
upper bound is that line, but you have to invert the x and y because you're doing it over the y-axis now. But you just have to rewrite it. So it's y.
Yeah.
That,
So,
and
so
then
this will end up being. Oh, if that's the line we're going to be using, I'm going to leave this empty. We have y is equal to 3 over 2. Actually, I'm going yeah, okay, 3 over 2 minus 4x over 2 pi. Multiply everything by 2. Multiply everything by 2 pi, actually. 2 pi y is equal to 3 pi minus 4x. 4x is equal to 3 pi minus 2 pi y. X is equal to 3 pi minus 2 pi y all over 4. So this is going to be our function for x.
yeah, that's your upper bound.
Yeah, so we have 3 pi minus 2 pi y over 4. So these are going to be our bounds of integration.
The lower bound for x is not tangent.
But if x would go between the tangent and the...
No, because now you're just forgetting about the tan x line.
Yeah, but how do we do that then?
It's just, okay, so what you do is you just write the integral signs because that makes it easier for me to explain.
Yeah.
So it's integral 0 to 1, the outside one, you know that for sure.
Yeah, because it's going to be 0 to 1 and then we end with dy. Yeah.
Yeah, and then in between there's the x, as you know, so it's dx dy. And then if you look at the graph and it's dx dy, you have to do the top bound is the line 3 pi minus 2 pi y.
Oh, because we're taking stripes like this.
Exactly, and so the lower line.
Yeah. So it's between this graph and this graph. Okay, I was still looking at this. Yes. Finally, thank you. Now the topics make sense.
No problem.
That's like my eureka moment.
Great.
Okay, so this
Hopefully,
is between
all the
the
viewers
tangents.
also have that. No,
That would
it's not
be
tangent. It's
arctangent of y.
Exactly. Yeah, now you're there, and that's your answer basically.
So
well, you have.
let's see. Let's start with the easy ones.
Yes.
So we
C and D.
know that C is going to be 0, D is going to be 1.
I didn't check the one, but I believe you.
Well, arc 10 of pi over 4 is 1, right?
Yeah.
Okay.
Okay. So it is 0. Yes. The
And
1.
1.
Yes. Oh, no, they're such simple things, but they make me feel so good. We're almost at 4 points, guys.
Yeah.
And the A is going to be the lower bound. That's going to be the
arctan
arctan function.
Yeah.
Nice.
You see.
And now to see if I am actually like capable enough to rewrite this function without fucking up.
Yeah, I didn't check it, so it's all you. Yeah, but do you see how this is very impossible now if the line goes over?
Yeah, definitely.
I was like, what do I do here?
Okay. I kind of quickly want to do this conversion again in LaTeX. Give me a sec. So we have the original line was wait, I'm gonna look at the exercise. Here. So the original line was the fraction of 3 over 2 minus the fraction of 4 over 2 pi times x.
Yeah, sure.
Recompile. So this is the original line. That seems correct.
Yeah.
And then we have y is equal to, obviously. Okay. We multiply everything by 2 pi. So this is going to go away. This is going to become a pi. This is going to become 2y pi, and this is just going to become 4x. Cool. This seems to make sense so far. I'm going to add 4x on both sides, and I'm going to subtract 2y pi on both sides. Yep. And then I'm going to divide everything by 4.
I think that's the same thing you had.
Yeah, I think it is. But now I know for a fact that it's true, so I can now go to B and paste it in. Check my answer. There we go, man. Only 1 point left.
Oh my,
This is 1 point. Okay,
getting
okay.
Easy questions. There's some very hard ones in here. Jeez.
Okay, guys, this is the question. After this, we're done. Donezo.
Well, imaginary numbers.
Shut up.
You have to get it right first time, right?
Yeah. Okay, so let's see. We have a function. Oh. We have a function going from x is 0 to x is 4.
You don't really need to graph it, but
I will.
Okay.
I like want to have this right, and then we're just done with it. And then it starts at it starts at y. Square root of x2 y is 2. So square root of x, well, that's going to be 0 at the start when x is 0, and then it's going to go up in a square root like manner. Yeah, square root like manner like this.
Yeah.
To is that correct? Yeah. Like parabola is like this, square root is like this. Okay. So this is
Well, just fill in
like this is just
fill in the part that you need.
I was about to say, wait, we can just fill this in. It doesn't want me to swap things around or anything. But at the same time, y 1 over 1 plus y cubed. That's going to be a lot easier to u substitute when we have an x here. So I'm going to turn it around anyways.
Yeah.
So we are looking at the area between x square root of x and 2. So it is this area.
Yes.
Like this.
Yes.
And right now we have dy dx, which is type 1, which is upwards. And we want to change it to like this. So we want to have x.
And the reason is just
we want to have y is between 0 and 2. And we're going to have x between 0 and square root of let's see, currently it's y equals to x squared. But let's see, y equals to, or a square root of x. We can turn it the other way around by like saying x equals to y squared, but should we? I think it makes sense actually now that I think about it.
Yeah, I would do it.
Yeah, because when x is to, or when y is to, wait, when x is for,
Yeah, it makes sense. If you tilt your head 90 degrees to the right, it's just a parabola for the x-axis.
Yeah. Okay, so this is right. So then we get the, let's see, the integral is 1 over 1 plus y cubed. So we have the integral, let me go back a bunch. There we go. So we have a double integral, integral from something to something, dx, dy. And I'll change the bound of integration soon, but first let me get 1 plus x cubed. And it goes, let's see, we want to have it this way, so that's dx dy. The dx is between 0 and y squared, and the dy is between 0 and 4.
2. Wait, what?
So now it looks like this. Oh. Oh, yeah.
Dx dy and then 0 to 4. How?
Oh, wait.
It's to 2, right?
Yeah, 0 to 2. Sorry. Oh, what do you mean we found an error? This is correct. This is correct. Fraction is correct. Dx dy is correct. Not this again. Okay. So this is our graph. Y goes from 0 to 2. X goes from 0 to y squared. Of this thing. Okay. Well, then we can start solving. So in the term, wait. Am I really this stupid? Because this is harder to solve when we start with x. And it was already in the form of dy dx. I'm going to see what happens if we do it the other way around. That might have been genuinely smarter.
Shouldn't it be 1 over 1 plus y cubed?
Yeah, that's a lie.
Because the function doesn't change.
That explains why it was harder. Thank you. Okay. So when it comes to x, well, this thing is just straight up a what's it called? A constant. So we can just fill in x here and then go from 0 to y squared. When it's 0, we end up with 0 because there's an x on top, and when we fill in y squared, we get y squared on the top here. So this is our last integral. And now we're going to do a cheeky little u substitution. So we're going to say u is equal to y cubed, or y cubed, yeah. Du is equal to 3y squared. Dy is equal to, sorry, dy is equal to du, or fraction 1 over 3 y squared du. Recompile. So now we've got these things to substitute in. So we're gonna take this thing, fill it back in. This is gonna be 1 over 1 plus u. The y squared is gonna be absorbed into this thing, which we can just literally straight up replace. This y squared will go away with this y squared. The 1 over 3 can get passed to the front. And then we have the integral of 1 over 1 plus u. And the integral of 1 over 1 plus u, ladies and gentlemen, is equal to the natural logarithm. And as you have seen, I have made a fatal mistake because I have kept my bounds of integration the same. So these bounds are not correct anymore, but I'm gonna keep them like this anyways, because then we can go the integral of this thing. Then we can fill in y u is equal to y squared again, or y cubed again, and then we can use our original bounds, so from 0 to 2. See if this is correct. So yep. Okay. Now the question is, so we get when this is 2 minus what we get when that's 0. Don't forget the brackets. The ln of 1. Well, what do you have to do? E to the power to get 1? Well, that's 0, so this thing falls away. And this is just the ln of 9. So we will end up with 1/3 ln 9. I feel like a fucking contestant on a show. Like, is that your final answer?
Yeah, it's always so scary to just submit your answer. Like, it's scarier to do it on Graspel than to do it on a test.
Yeah.
Yeah. Come on, press it.
Let's go!
Yeah.
And that's our speedrun done.
Wait, no.
What
I'm
do you
not
mean?
gonna do
It's
like,
more like a slow run.
We're not gonna do it. It's not a full run, but like.
Why don't we finish it with the imaginary?
Because people were complaining like imaginary we haven't had that yet.
Just do it.
Yeah.
Let's just go do it.
But I can't undo my split, I don't think.
Do people go to lectures anyway? I mean.
Okay, wait. I'll fix it. I can do.
Well, for calculus I do. For the rest I don't.
This page down. Oh. How is page down next? Whatever. Okay. But by God, will we have to zoom through this because I'm like almost ready to eat. So complex numbers, start practice now. Write this in the complex polar form. Well, this is already in polar form. Oh, give the complex conjugate. Okay, so we currently have r is equal to 6. Theta is equal to 0, or to 4. Therefore, we have r times cosine theta plus I sine theta. Well, theta is 4. R is 6. Theta is 4. So this is the number. Recompile. Filling this in gives like this. So this is our complex number in the form a plus bi. The complex conjugate of this number is a minus bi. Is sine an even function? Wait, okay, so sine of negative sine is equal to negative a sine of negative. So this should still be true, or let's say this should still be true, right? But when are You know, I don't think I'm ready to do this yet, honestly. Unless you guys have an idea.
I forgot how to do this.
Isn't this just the answer to it?
Yeah, but we have to give it in polar form, and theta here is different on either side. Oh, wait. Cosine x is equal to cosine of negative x, so we can just say it like this. Then we can have 6 is equal to negative 4i. Only because of that one fucking math rule where you can say cosine x is equal to cosine of negative x.
Don't you need the e back in?
Hmm? Oh, yeah, okay, I was already like, huh? Okay. Check my answer. Dude, we're on a
Yes, let's go.
Okay, write a complex number in the polar form with theta between. Okay, well that's not too hard. We know r is equal to the square root of 1 squared plus square root of 3 squared. Well, that's just going to be square root of 3 is 4. Oh, square root of 4 is 2. Okay, and theta is the arctan of b over a. Right? Yeah, I'm pretty sure it's b over a.
I do remember seeing that somewhere.
Let's see, b is square root of 3 over 1. So the arctan of square root of 3. There we go. Next one. Determine the real part of this thing. Well, that's not too hard. Then we just have e to the power of... Well, r is equal to 0. Well, that's just going to be cosine... r is equal to 1. And theta is equal to negative 20. That's going to be cosine of negative 20. What?
Isn't it just literally e to the power 5?
Hmm?
Isn't it literally e to the power 5?
Oh, 5 minus 4i. I thought it was 5 times minus 4i.
No.
Okay, that makes sense. So then we have e to... So r is e to the power 5.
Enough.
Theta is negative negative 4. So then the real part is r times cosine theta. So then we get e to the power of 5 cosine negative 4. And then the imaginary part is I sine
Negative 4, right?
Yeah, we also have to multiply by e to the power of 5 I sine negative 4. I'm not sure if they want me to give the I as well. Probably not.
No,
Motherfuckers, didn't even give me points. Write the complex number in polar form. Well, then we first convert it to the other method. So this is going to be r is equal to... Well, that's just going to be r is equal to 2 because square root of 1 square root of negative 3. And theta is equal to b over a. That's going to be negative 1 over square root of 3. Square root of 3. So this is true. When we multiply, we do r to the power 7. Or when we do the power, we do r to the power 7. And theta becomes times 7. So this is just going to be 7 over square root of 3. So it's going to be an answer with 2 to the power 7. So these two fall off already. Oh, and actually, this is going to be the tangent of. Anyone know what the arctan of negative 1/3 is?
I don't know.
Let's try arctan.
Yeah.
Or
I guess we're supposed to know these
square root of
things.
3. Sorry.
Are we actually?
Hmm?
Negative pi over 6?
Negative pi over 6. You were faster than the fucking thing. Jesus Christ. So that will mean that the thing will be negative... oh yeah, well, it's going to be negative pi over 6. But that's going to end up being negative pi over... negative 7 pi over 6. But 7 pi over 6 is going to be equal to 1, or is it negative pi over 6? Yeah, okay. So that is going to be 1 plus pi over 6. But tangent loops every pi, so we can get rid of this 1 pi without problems. Is that correct? I think we have to. So that will become negative. So it's a 2 to the power 7, and the answer is negative pi over 6. Let's
I
go.
just realized this is my first lecture after the midterm I've attended, if you can call this a lecture.
Nice. Give the imaginary part of that thing. Well, that's just going to be fraction of 1 plus 2i over 1 minus 2i. Recompile. We multiply both sides by 1 plus 2i. And the reason we do that is because then in the bottom we get a minus b, a plus b is equal to a squared minus b squared. That's going to be 2i squared. 2i squared is plus 4. So this is going to be just plus, this is just going to be equal to 5. Okay, and if we multiply out the top, we will get 1 times, well, it's just equal to this thing squared. I love how we're doing this without like knowing the things we have to know. So this is actually equal to.
Well, we had this part of the question.
Well, yeah, okay, this part so far. 4i. And then it's going to be plus 4i squared, which is minus 4, which is why this is negative 3 plus 4i over 5. Therefore, the imaginary part is going to be 4 over 5. I don't know if they want the I or not. I don't think so.
They want the I.
Probably not.
Okay, so the imaginary part of is not with the I. We only have 1 point. This is the last one. Give the complex conjugate to the following number. What a way to end
they do
it.
want the I. Now they want the I.
What a way to end it. That's it.
Let's go.
That's the end. 7 hours, 44 minutes, and 17 seconds.
Nice.
I actually fucked up my splits as well. It's over. Am I still recording? Yeah, I am. 8.5 hours. 8 hours
Jesus
and 40
Christ.
minutes of recording.
I would not be looking forward to uploading that to YouTube.
Well, everybody from YouTube, if you're still here, thank you for sticking with us. I hope you had a nice time. I hope you get a good grade. And yeah, if you have any questions, hit me up on Discord, Uriella4936, or on Instagram, Twitter, Telegram, Uriella. They'll also be in the description, and I wish you the best of luck.